who has accepted our invitation and taken out their time to be here with us. Welcome to our esteemed jury members, the e-Yantra team, our media team, and all the participants of eYRC and eYIC. Over the past 7 months, you have poured your time and energy into this competition, and now as you take the center stage, it's a moment to pause and appreciate the growth and learning that has come with it. So we understand that the final moments might be a little bit of excitement and nerves, but do remember that reaching this point itself is a tremendous achievement in itself. So take a deep breath, embrace the moment, and above all, enjoy these 2 days to the fullest. So to officially inaugurate this grand occasion, we are honored to invite our principal investigator, Professor Kavi Arya, along with our esteemed guest, to light the ceremonial lamp.
So, will you invite? Here, we have a ceremony here. So,
Four.
Okay, the principle is we have a lighting of the lamp. So safety sake, we have an electronic lamp. Okay. That's this to light. That's the difference between electronic speaker and mechanical.
Yeah, like the vendor is don't know how to do it.
Great. Good morning, everyone. This is a very special day. It's the 14th edition, would you believe it? 14th edition of the e-Yantra Robotics Competition. We've been in existence a long, long time. We've trained 250,000 students over the last 14 years, perhaps more. And everybody who we've touched, by the grace of God, they've done very well in life, whether they've come to the finals or not, just because they have participated voluntarily in a very grueling competition which has helped them discover themselves. And that self-discovery is seen in the placements. They get placed at 50 to 100% higher packages, right? Which is a sign of the success of maybe what we do. We've set up 550 e-Yantra labs across the country. Each lab is an innovation hub which tries to seed a different kind of culture in the college that hosts it. And many of them go for higher degrees to the best universities in India and abroad. In fact, we can guarantee if they come to us as the project staff, they'll be in the MTech program or the PhD program after about 2 years or so. In fact, I'm very happy to welcome back our very experienced veteran from eYantra who came to us as a competitor, came through the internship, joined as project staff, registered for a PhD here, almost completed the PhD, but has run off to industry with GE in Bangalore and doing very well for herself. A big hand to Rutuja, who's joined us here today. She's done some very interesting work in compiling Python programs into chips, Python programs into RTL, which will, I feel, really transform the way that we look at hardware. Okay, that was she's co-guided by a very distinguished colleague in electrical engineering called Madhav Desai. So, what are we here for today? Today, we are here to celebrate the achievements of not only the finalists who've come here, but the people who are not here with us today. For space restrictions and logistical restrictions and so on, we've just been able to entertain a smaller number of you here in the finals, but I feel that everybody who's taken part in the eYantra competition is special, because they don't need to do all this. They don't need to subject themselves to all this rigor, like climbing a mountain of engineering, but they did it voluntarily, which shows some kind of passion. And we are also now trying to see how we can take the people who are not only the finalists, but all the others who came at least up to stage 2. Stage 2 means work with the hardware in your hands and try and place them, train them a bit more and place them in industry. So that's another thing that we are working on. But what we are here today is to celebrate your birth as engineers. Our higher education system has let us down very badly, because we seem to believe that taking knowledge and reproducing it in an exam is engineering. It is certainly not engineering, as you've discovered now, right? Engineering is about having empathy, about wanting to improve the world around you, about solving problems to improve the world around you, about gaining the skills to solve these problems in the world around you. And in that process, you discover a passion. Engineering is cool, engineering is fun, and it needs to be celebrated much more. Engineering is the building of stuff, right? It doesn't matter whether it is software, hardware, mechanical stuff and all that. At the end of the day, we want products to solve things. Look at what SpaceX has done. It's extraordinary, right? The way you can fly a rocket, bring it back, catch it on a robotic launchpad mechanism or whatever it is, or to fly it back and make it land. I mean, that's the celebration of control systems in a way that can only be appreciated perhaps by engineers, but now by other people also. So, problem solving. And the other thing that we want to do is that we believe that the world has become a very uncertain place. AI has made it even more uncertain. I thought that low-skill jobs are going to disappear, but I'm beginning to realize that even medium and high-skill jobs are going to disappear. And what that means is that anything that is legacy is under threat from AI. Because anything that is there can be automated. In fact, someone was mentioning to me yesterday that, you know, in industry, you have all these problems of unions and, you know, very difficult to handle manpower and so on. So there's a very compelling reason, even for places like India, to have robotics in the manufacturing lines. That means more jobs for you guys. So that's that. AI is going to make jobs disappear. So what do? We have to create new jobs. Who creates new jobs? It's the scientists, the engineers, the entrepreneurs, the people who are looking around for problems to solve, the people who are looking around for problems and seeing them as opportunities, the guys who are doing startups in various things, right? The guys who are doing science, whether it's basic science to create foundational knowledge for new ventures, or it's engineers who are taking existing knowledge, putting it together to solve problems and creating new stuff. So that's the kind of attitude and mindset that we need to kind of celebrate, and that's called an entrepreneurial mindset, right? So engineers are all about being an entrepreneur in the whole area of solving problems. So today we have some very special people with us, right? I'm very happy to welcome them all with us, apart from the jury members of the first theme this morning, who I'll introduce in a moment. We have my PhD advisor from my Oxford University days, who's done some very interesting work. He's done some amazing startups, and he'll be giving us a keynote on the future of engineering as he sees it tomorrow. So I'd like him to just stand up and take a bow from all of us. Professor Ian Page, right? And he started an amazing startup way back in the late 90s called Siloxica, which allowed you to compile something like C into hardware onto FPGAs and things like this. Now he's a director in a company called Chipflow, which is doing Python to RTL work, which is quite interesting. I'd like to welcome our friends from here. I'll start from the left and work rightwards. Nitin Gupta, right, the founder of Flightbase. You can take a bow maybe, right? I'll introduce him a bit more in a moment. Romesh Kaul, right, a colleague from my days in Mahindra & Mahindra. Dwaipayan Mukherjee here from Electrical Engineering Department. Shivram Kalyanakrishnan, an AI boss from my department, Computer Science. Paritosh Pandya, who used to be Dean Computer Science in TIFR, now he's in our department. Raghunath Iyer, right, who is a very experienced industry hand and an IIT alumnus. Madhura Purna Pragna, right, who used to work with us in the lab. Then she went off and did a PhD in Germany. She's a teacher in PES, and she works for Xilinx at the moment. So thank you all for being with us. We have Shubha Pandit here also, who used to be the principal of KJ Somaya College. Now she's an e-Yantra team member and doing some cool stuff with us. So without much ado, I think there's not much time, so we just launch into the theme. So let me just introduce the jury members of the theme. We have, as I said, Dwaipayan Mukherjee. He is BE from Jadavpur University and MTech in Control Systems from IIT Kharagpur. Then he did his PhD in Aero from IISc Bangalore. And then he worked in Technion in Israel, and then he's been an associate prof here with us in electrical engineering. And his research interests are multi-agent systems, cooperative control theory, cooperative control theory, and control theory in general. But Shivram, there might be some work that we can do together also, especially with your interests in reinforcement learning and things like that. We have Nitin Gupta here, who is the founder and CEO of Flightbase. He's a BTech from IIT Bombay, so welcome. So he's a master's in aerospace engineering from Maryland in the USA, and he's got about 20 years experience in automation and aerial robotics. And so he specializes in drone autonomy. And his company is doing amazing things on a global level, and they specialize in swarming drones, right? Swarming-based solutions. So it's quite interesting. So Flightbase was awarded the Grand Champion Award at the NTT Data's Global Innovation Contest in Tokyo, and the TAI 50 Award at Silicon Valley, I believe. Right? So his products are used by enterprise customers in 50 plus countries in the world, and I was very interested to hear that. And his office is in Baner in Pune, so even better to hear that. So he developed the idea in the US and then opened a huge office here and shifted his operations here, but he works out of the US and India, right? So I believe. So you might want to talk to him as to how all this happens. We have Shivram Kalyanakrishnan. He is a faculty in our department in computer science. He's a PhD from UT in Austin, and he's been a research scientist at Yahoo Labs in Bangalore and an Inspire faculty fellow at IISc in Bangalore. And more interestingly, he's been a member of the first study panel of the 100-year study on artificial intelligence, AI 100, which in 2016 released its report titled Artificial Intelligence and Life in 2030. Shivram, I think we need a keynote from you also very soon, right? So he's very thick in the AI community, and his research interests include AI and machine learning, going across topics like sequential decision making, multi-agent learning, multi-armed bandits, and humanoid robots, right? So there might be some overlap there also. And then lastly, we have Romesh Kaul, I spent a stint in industry in 2007 as a chief technology officer in Mahindra & Mahindra, reporting to Anand Mahindra. And there I met some very interesting people. Romesh is one of them. And he's doing, he was a former ED and a CEO with Mahindra CIE Automotive. So he knows the hardcore manufacturing industry of manufacturing auto components and gears, and he's worked with a Spanish company in doing that and stuff like that. What we are hoping is to do a lot of work with him to mentor the e-Yantra labs which are around the country. As some of you know, I'm on the Apex Education Council of Jammu and Kashmir. We are trying to implement the National Education Policy 2020 in all the colleges of the state. And e-Yantra is seen as a part of that, where we are establishing, we've been tasked to establish 30 e-Yantra labs, 15 in Jammu, 15 in Srinagar. And I'm delighted to say today that we have a team from Kashmir itself, right? So would you stand up? Right? Team from IUST, Islamic University of Science and Technology. Big hand to you guys. We have your faculty also here, right? Pardon? So the two of them are there. Who's there? From IUST, where are they? Okay, they're shy. And we have Professor Mujtaba here, right? Syed. Hi. So here he is, and he looks after the e-Yantra activities. So IUST is one college in Avantipora which has adopted e-Yantra since 2015, and they've done a same thing as what KJ Somaya College has done here. They've used the lab to create an amazing innovation ecosystem. There's a lot of startup activity in that place, lots of innovation, lots of publications, and amazing energy in IUST, right? So welcome here. Romesh, to just finish, he's been consulting in the areas of operations, strategy, execution, business process improvements and all that. So he's got expertise in things like program management, business excellence, strategic planning, change management, and so on. And he's very passionate about innovation in the workplace, people development, mentoring managers, and so on. So in fact, we wanted to bring Romesh to Kashmir. Syed, you should maybe speak to him. And he's happy to mentor all our students in J&K. So we planned some programs and workshops and all that there, which we thought we'll prototype there and then take it to the rest of the country. So great. So without much ado, I'd like to call the theme developers from the drone theme here, and they can take the program ahead from here. So thank you very much. I'll also be addressing you tomorrow. If there are any concerns you have, then you can catch me in the day, talk to me, and maybe that will appear in our talk tomorrow. Ian is going to give a very interesting keynote, so you should be around for that also in the morning tomorrow. And Shashank Singh here is a big ardent fan of e-Yantra, and he often makes videos for us totally voluntarily. And he's a guest that we are very happy to have. He might collar you and ask you for a soundbite or to act in a little movie that he's kind of thinking about. So just be warned, okay? So without much ado, over to the team here. Thank you. Thank you.
Hello. So I would like to welcome you all to the most exciting theme of this competition, Varos Drone. So welcome you all. This Varos Drone competition is a gamified concept of real life. It's inspired from real life Varos drone operations. So it simulates the challenges of autonomous navigation, localization, and package identification in a controlled environment. As the competition goes on, participants have a lot of learning. So we'll go through over them. So participants have learnings of quadcopter simulation, where they test out their codes of path planning and control systems in simulation, and they have learned a lot about control system. So controlling the drone effectively is a fundamental part of this challenge, and they have learned a lot about path planning algorithms over this course of 6 months. And image processing is used over here to localize and plan the path effectively. And both Python and C++ is used in this particular theme to code the control systems for the drone. And participants have learned to use a lot of tools and frameworks over this competition. And ROS2 is the main framework that have been used in this particular theme. So ROS2 is the main framework which is used for effective communication between the drone and the computer and data processing and stuff. And Gazebo simulation software is used for simulation, and both C++ and Python is used to code. And Betaflight is an open source flight controller firmware. And OpenCV is the open source library for image processing that is being used for locally Wacom. So we'll go to the environment. So we'll see the arena stuff. So this over here is your simulation screenshot from the simulation. So bottom left is the simulator. So as you can see, it depicts the actual warehouse that we have in the hardware over there. And the right screen is your Vicon frame, and on the top left is your is used for collision detection. So this is a screenshot of the actual hardware configuration. So all these red stuffs are for package to simulate package gamified concept of packages over in the warehouse drone. And the right frame is nothing but top view of the hardware arena. And this will be the final configuration of today. So participants have to start from the starting position, and they have to go the package named number 1, and they have to go back to package 6, and they have to land. So Swift drone is our indigenous drone. So we in e-Yantra designed it, and it uses Vicon over top of it to localize and navigate through the drone, through the arena. So this is our team. Now we'll go to the scoring criteria. So there are two scoring criteria. One is scorer score and there's judges score. And scorer score as this formula, we'll break it down. So 250 minus t. So the faster your drone, the higher the score you will get. So and waypoints reached. So for all the waypoints that you reach, your 50 points will get added into your score. For the all the packages detected, you will get 150 points added to your score. And for all the collisions, you will get 50 points as a penalty. For each collision, you will get a 50 points as penalty. And there's a landing bonus of 100, and there's bonus criteria of 200 marks. And there's judges score. So after your run, judges will question your question your knowledge on quadcopter dynamics, control systems, image processing, and path planning. judges will question their knowledge about participants' knowledge about all these stuff. And I would like to thank the team developers. So Arun P. Madhu, Bhavik Jain, Sri Venkateshwar, and myself Shakti Magendan. And special thanks to Smith, Adish Desai, Jason, Shyama, and the inventory and office team, and support and funding. So I would like to thank Ministry of Education for funding us, our beloved PI Professor Kaviarya sir, and the entire e-Yantra team. Thank you. Let us enjoy the show.
If it's possible to stream here, then check once.
I think we should remove this first. Then do.
Click here. Okay.
Nice. Now do full check. Now they have to switch. Ask her to switch, no?
Full screen.
Zoom कर सकते हैं
वही देखो.
ये better than the one you get there. क्या दिख रहा है
फुल स्क्रीन
नहीं
नहीं हुआ. वेरी बैड. ठीक है.
So guys, yeah, the team which is here setting up is team ID is 1818 and they are from Loyola College of Engineering and Technology. So I will just brief you a thing. First drone will arm. After arming, fast chorus, when the drone takes off, you have to start on the timer. Then drone will reach to one waypoint. Then we will say one waypoint has reached, and we will when package is detected, we will say package has been detected. So then you can add the score accordingly. And when the drone lands, then we will say drone has been landed. Plus, if there is any collision, we will say collision stuff. And more than 5 collision, run is invalid. While running this theme, one of your person have to take a mic and you have to introduce yourself and what all challenges you have faced. You can parallelly tell. Okay. So let's make this an interesting event. Yeah.
So where is Loyola College? Tell the audience.
Yeah, from Chennai.
आप यहाँ से ऑन ही रखो, मैं 6 पर नोट कर रहा हूँ. प्रेस करके रखेंगे तो अगर ऑफ करना है ना तो प्रेस करके रखेंगे.
So tell us a little bit about the college.
Good morning all. Myself Mohammad Abdulaziz. This is Joel, Vinny, Jonathan and Roger. We are from Loyola Ecam College of Engineering and Technology. Loyola is actually famous in and around Tamil Nadu, Chennai, the south of India. It is in the heart of Chennai, Nungampakkam. So basically our college is famous for arts and science. So whenever we say engineering, none of them really identify that Loyola College as an engineering. So that was very difficult for us to establish that we are an established college in the center of the city. only our college is, engineering college is in the center of city. So that is actually very proud for us. And Loyola has been there for around 100 years. And
So how many teams from Loyola have come to finals
Just
at
one.
e-Yantra?
just fun.
So you're the first.
Yeah.
Big hand.
I will ask the team whether they are ready for the run or not. You have to say ready. Then if I will ask scorer is ready and judges is ready. Then only I will instruct you to arm the drone. When I instruct to arm the drone, then after that you will not touch the laptop. Cool. Just inform me before.
So ourselves, we are multidisciplinary. We three are from electronics and communication, and this one is Vinith from computer science. So it is an interdepartmental team. And we were actually struggling initially with software to hardware part. Simulation part was also difficult, but we found it somewhat easier compared to the hardware conversion. So it was an ideal situation in simulation, no noise, no errors, nothing. Just take off PID value tuning, and then we move the drone. That is all. But whereas when we move to the hardware, it was completely noise.
Yeah, we can start the run and we can you can continue doing that. Okay. Yeah. Sorry for the interruptions. Team is ready. Score is ready. Judges, you are ready, right? So yeah, let's go and count. 3, 2, 1. You can arm the drone.
Again.
Yeah, try to rearm it. Yeah, you can, if you are armed, then you can leave the laptop. You can start taking off. Yeah, time has been started. So though, as you can see that these two red boxes, they are going to detect it. So drone is moving to first box, first waypoint. So waypoint has been reached. They are detecting the packages, right? Yeah. Waypoint reached. Regarding packet detection, we will have an Vicon running in ROS back, so we will evaluate and we will tell the scorers whether the package has been detected or not. Yeah, now it's moving towards the second waypoint. Guys, you have anything to say in this?
Yeah, so we can see it's moving towards the second waypoint. So you see the drone is currently, to an extent stable. So to reach that point was quite a long journey. It was a journey of like 8 months.
One package detected.
So starting from simulation,
second waypoint reached and second package has been detected.
Simulation and going on to a hardware stage was like, it was a totally different world. Like hardware stage, you can't expect what the hardware is. You have to understand how that hardware works, how to deal with them. It's like it has its own soul. That's how we felt. You have to understand it, otherwise you might end up with a broken hardware.
So yeah, the drone is still trying to stable the waypoint. So it is expected to come back. Yeah. So it's hovering. It's expected to come back to the landing point. So as you know that one collision. So you are ending the run, 2 collision, 3 collision. Oh, okay. Yeah, they end the run. Yeah. Now they will. Team wants to do another run, so you have 1 run left. Yeah. So main hurdle is here, like the drone techies know that as the battery drains, the thrust, the drone can't able to manage the thrust. So the quirk is that they have to create like an algorithm which will balance that stuff. That's only the throttle holding is the main quirks here. Roll and pitch, it's easy to tune, what we have seen from the participant side. Zero LD. Yeah. PD we will recheck once after. Yeah. So team is ready. Scorers, just a minute. Scorers are ready. Yeah. Judges. Yeah. We can start. You can arm the drone. Yeah, you can arm the drone. Yeah. Yeah, timer starts. So again, same is going to happen. Okay. So we have 2 controller here. One is an outer loop.
So we are also facing one more problem over here, that is the perspective time. Like Vicon has a perspective noise. Because
1 waypoint has been reached. You continue.
Yeah, because there is a, according to the image perspective, there is a pyramidal, you can imagine like a pyramid. So we can get an exact coordinate with low or no noise in the center
no
area.
package detection.
But when it moves towards the corners or sides or edges, the noise increases. So there the PID, the control system, needs more dampening, and the region-based control system is more active. I mean, implementing that kind of PID will be more helpful over there. So we implemented that. This is what we are getting over here.
One waypoint reached, second waypoint. So no package has been detected. So no, yeah, land is done, time stop. You can move towards Viva section. Next team can set up it. Yeah, we will move towards next team. Next team can set up in meanwhile. Team ID is 1558.
Thank you all.
Yeah.
So we do the questions now?
You can ask the questions now.
Where should they stand?
They can stand here, in front of you here. Yeah. Yeah.
So we are
This
right
is
here.
team number 1558, which is setting up.
So good show, Loyola. So I have, I think, interest of time, I'll keep it to one question. See, you had these 4 or 5 aspects in your optimization function, right? The number of waypoints you reach, landing, things like this. So how did you go about deciding which to focus on, like balance between these objectives? And moreover, was it dynamic? I think the second time I saw you went and landed, even if you did not detect a packet, which suggested that depending on the time left, you were deciding what to do.
Yes.
Can you talk a little bit about this aspect?
Sure, sir. Sir, so right now, the actual task is to go to the position and detect the packages. That is the main task. You can see it's the theme. Now, we focus more on marks, like last moment when we had the whole, like coming to a home location to back to a new location, having different hardware. We had to focus on other aspects so that much of tuning more won't be required. So what we thought, even if suppose the package is not getting detected, it reaches the position and it completes the whole mission. So that was our perspective. That is how we solved. Initially, it was focusing on one particular task, like takes off and then reaches the each and every waypoints. Even though it might not land, we made sure that it reaches everywhere. That was how we took each step by step.
These are all manual rules that you put in.
Yes, sir.
Okay.
Hello. So congratulations, so good job. So I come from the industry, so my question is more about how do you take this kind of concept and apply it to some real problem. So have any of you have been to a real warehouse?
Yes, sir.
Okay. So what do you think will it take for us to take this technology to a real warehouse? Where will the challenges be?
As you see, we have one fixed camera on top, so we have this perspective issues. So and initially addressing that perspective issues and applying more amount of cameras, we can use the CCTV footage in order to implement that with perspective transformation and then overlapping images, cutting the X's and the repetition.
Is that going to be the best approach for a large, like warehouses are really massive, like millions of square feet?
Actually, I'm comparing with this arena.
Right, but in a real warehouse, which is millions of square feet,
yes, sir.
How many cameras would you install?
Okay, sir. In a real warehouse situation, we won't be limited to single camera. The localization won't be limited to single camera. There can be like 10 to 8 cameras all around that can make up all the images and join together, so that there won't be.
Can you think of an approach where you don't need external aid, where you don't need an active camera to navigate without a GPS, of course?
Without GPS,
it's a GPS denied environment, but can you do that navigation without using a camera kind of a system? Because that will not be feasible for a 1 million square feet warehouse.
So then it has to be autonomously based on the location of each warehouse packages. The drone will have a preloaded arena, like the whole area, and it can localize using lidar or something like that.
So you can use some kind of SLAM techniques.
Yes, sir,
for
SLAM
onboard
technique only, yes,
navigation.
sir.
Okay, great, thanks.
Yeah, a small quick question. I think you alluded to simulation is something, and then when you come to the real hardware world, you actually discuss. Did you make a list of, do you have a list of experiences and list of issues that you faced typically, and qualitatively, quantitatively, how many did you solve, how many did you find solutions for? Just throw some light on that.
It's a lot of learning we did here. Like, coming to a hardware side, we have to understand that each hardware has its own way of approach. If we load some firmware, it will have its own speed, it will have its own configurations.
Okay, and the what part is normally understood in a real world. You know, I'm also from the industry.
Yes.
A real world, you understand the what part of the problem. But did you reach the why of some of those gaps between, because normally you would start with the
Yes,
simulation, sir. And then why is that difference happening? Did you reach that why?
Yes, sir, we reached the why. Sometimes the things are not certain. Everything is, even though manufactured in terms of FC and all, like it goes till a silicon level. So even a small change inside the silicon level can, but that is a different case. In terms of coming back to the mission, we figured out a lot of whys later on when we figured out the base of the problems. Like the control system itself had a huge problem of noise. We came out to that noise issue later on, way later into the whole mission. Yeah, we had the problem of the frequency. The frequency was like the amount of processing that we are doing into it. Like if it is low frequency and we are processing low amount of data that we are getting out of the whole thing, then the drone won't even stabilize. It will be just hovering here and there. When we increase the frequency, we are maximizing the data processing, and we are controlling all that data. So we can keep the drone within our control, within that boundary.
Thank you.
I thought you said something about using more damping for noise. So how do you increase the damping in the PID control?
Yes, sir. D helps in increasing the damping, the derivative.
Even in the presence of noise? Is it recommended to use high derivative gain?
No, it's not recommended to use high D, though we have to balance it out using P also. And I has to be reduced.
Why do you think that?
Yeah,
why has I got to be reduced?
Okay, if the error increases and I is too high, then the error will add up, and it will create a drift within the drone.
But I thought the role of the eye would be to mitigate the error, isn't it?
Yes, there's it's like integral wind-up comes out, and it makes the drone to drift it.
You've actually checked that with
Yes.
higher values of integral gain?
Yes, sir.
Okay.
But later on, in hardware, it took us time to figure it out there, because the noise is uncertain. So we can't figure out the exact I unless we try. It took us a lot of try as it.
Okay. Sure. Good job. I'm not part of this jury, but you keep referring to noise. Can you tell what exactly is this noise what is it that you call noise? Because I have not understood this.
Any disturbance in the environment, we say it as a noise. So if you see the camera, even the RF signals around us. So if there is we are doing transmission from the transmitter to the receiver. So if there is any interference in between that RF field bandwidth, that we can consider as a noise, and parallel processing behind the systems. So if there are any other process running behind, that causes some issues in the processing.
Now I get what you're calling as noise. But, I mean, this is real world. Yeah. Okay, so all communications are not reliable. No communication is reliable. But then, I think the ROS or whatever other systems you're using, those should be having the required retries and backup mechanisms and so on, right?
In terms of noise, it can happen each and every, like camera is having. It is doing a huge image processing just to localize the drone. So when that whole process is running around, that noise will come in like decimal forms. That is one form of noise we are getting. And another noise will come in after processing. We are getting transmitter signals. So those are one form of noise. We can mitigate all that using one or the other form of filters that we applied.
Okay.
We applied a lot of.
I mean, you also mentioned some other process interfering with your computation process and so
Yes,
on.
sir.
But
Actually,
all this is okay. I mean, you are learning. This is to be anticipated. That's all I wanted to say.
Yes.
I understand. I understand.
Okay, cool. Then, yeah. Can we move on to next team? So this is team 1558 from Dr. Vishwananta Karad, MIT World Peace University. It's from Pune. So yeah, one can introduce themselves, and you can just introduce yourself and just tell me when you are ready, so we can. The team which has been completed should move towards exit interview. You can move towards reception. They will tell where the interview is happening.
So I am Vikrant Mehtre and he is Manas Shintawar. We are both from Dr. Vishwanath Karad, MIT WPU. Our college is situated in Kothurud, the main center in Pune, main hub, the heart of Pune. And the main issues we faced is we had
sorry for disturbance. We can start it, then you can continue with the disturbance. Okay, it's fine, right? Yeah. Is it setup is ready?
Yeah, fine.
Yeah. Scorers are ready. Judges. Yeah. Drone is timer is start. So now, yeah, as you can see, drone has started moving towards its first waypoint. Yeah, you can continue your challenges.
So our main challenge was our college was under redevelopment. So we had to set up this whole setup in a shade, which has bad lighting conditions. So navigation itself was a huge task over there.
And we have to set up our camera on the single tripod. So actually, if the camera position should be for the Vicon system is steady, and we have to set up our camera each time for the new run. So run se pehle ekada it is 1 to 1.5 hour is we are setting up the camera. Then 2 to 3 hours of testing. Then again camera हम नीचे लेते हैं.
One waypoint has been reached.
And यही रूटीन हमारा लास्ट के जब हार्डवेयर राउंड इज बहुत टफ गया लाइक.
And secondly, we had a hardware issue that our second laptop is an office laptop, so it is not able to perform well for these tasks. So we have 2 threads in our code, one for checking if the drone is stable and another one for PID tuning, for PID, which runs at 30 Hz. So
no package has been detected.
So when both so when there was no sleep in the loop of checking, so when there was no sleep in the checking for 0.1 second, the the PID was not able to run at 30 hertz constant. So that was the hardware consideration for our drone.
So like our laptop's computational power is also not able to handle the Python code. So we have to optimize our code such that it should run on our laptop and we can perform the task. So it is also a very big challenge for us to optimize the code. And that PID tuning is also a very big task. Like in low lighting condition, it's very difficult for us to remove all the image-based noises and performing the hovering task.
One waypoint reach.
And also due to the bad lighting conditions.
One package detection done. You can consider this as a collision. End of the run.
You can change your battery.
Battery down.
So now they will move towards the next run.
How many collisions you consider for this?
Last collision. Three collisions. Okay. Just inform me before you are arming the drone, okay? Wait. Drone has been armed. Scorers be ready. Yeah, timer starts. It's an invalid run. Now you can move towards for Viva section. We will move towards the next team, that is team ID 2087. And you can start setting your run.
Okay, good job, guys. So my question to you is, so you mentioned what kind of challenges you were having closing your controller loop, right, on the laptop.
Yes.
Did you make any special provisions in order to ensure real-time performance of your control loop on the laptop?
To ensure real-time, we just added sleeps, means the checking does every 0.1 second. So we reduce the checking time.
What is your loop rate? What is the frequency of your control loop?
The control loop runs at 30 hertz, while the checking is done every 0.1 second.
So sir, in ROS for the actions, we server feedbacks the client, and we don't have any control over it. So it runs at maximum hertz. So that's why whenever our client starts, our drone gets disbalanced. So बहुत time तक हमें पता ही नहीं चला कि ऐसा क्यों हो रहा है. So we were thinking कि something in code issue, but then sooner we get to realize as soon as client starts, हमने फिर debugging चालू किया, then we will get to know कि the feedback loop is running in such a high frequency that our computational power for the PIDs getting very low. So फिर the values भी उसे जो खराब जा रही. So हमने
detailed profiling ki is the loop actually running at 30 hertz and
the PID loop is actually at 30 hertz, but the feedback loop we don't have any control over it.
We are able to identify it via
Plot juggler graph. The RC values are getting a lot of noise or miscalculations due to the power source.
How are you able to fix those issues?
We just add a sleep for the 0.1 second frequency checking it. So the time dot sleep is the like Python time library.
Are
We
there
just
better ways to control the real-time performance of your code?
So actually, if there were two separate programs, it would be better. If there were two separate programs, it would be better. But we did it in one program only, so two threads on one CPU are creating an issue.
Good job. I think don't be disheartened by the fact that you have had a mishap, but overall a good job. I think I personally feel very fascinated with the effort of this team. I mean, what normally a 4-member team is sharing, I think you have done too. Might sound a little mathematical. So, what do you think was some of the, if I may, what did you miss in this whole journey? What were you as resources, what did you miss?
Actually,
did you miss anything at all? Maybe a silly question.
Like in terms of resources. So, sir, actually our like हमने भी इधर बोलना नहीं चाहिए, but actually our college doesn't understand our like side. They didn't give us space and they didn't give us also money for the extra things. So for this we have approached our Robocon lab. So there we set up, and the Robocon lab height is very high, so we have to set up our camera.
I mentioned this is not a question. This is an observation. This is an observation. I mean, when about 300 I think 300 some contestants team started. How many? What did you? 220 odd teams started, and you made it to the last 5. That itself is highly commendable, I think, right? So, having said that, it shows the passion that the two of you have. And वो Bangla में बोलते हैं एकला चलो रे. I think you kind of you had good mentors in the but I'm not still getting an answer for what you missed. Yes, your institute did not support. What did you miss?
So what we missed is moral support in those last month that means it was not happening, and we were the only two handling. So the moral support and moreover the teamwork.
Good. Thank you. God bless you. I think good job.
Yeah, this one is more testing your general knowledge. So you've heard of neural networks and how they're revolutionizing all of AI.
Yes.
So what role can they play on a robot, like your robot maybe, to go and do its thing in a warehouse?
Sir, in dynamic environments, reinforcement learning can help. Means it is being used in for navigating cars in dynamic environments. The warehouse is not such a dynamic environment.
I asked specifically about neural networks,
sorry.
deep learning.
Deep learning.
Yeah.
So, in deep learning, I cannot come. SLAM is the main thing that we use in general.
You think they're being used in robotics or no?
It will be used in robotics for decision making and that stuff. Here also we can use neural networks to.
For what?
For say. So image processing, but Vicon is a better system. That's why I'm not considering it, because we have trained multiple.
No, so I was asking more generally, not this particular competition and setup, right? But robotics in general. How are neural networks going to help?
So neural networks do a very nice job in decision making jobs in computer vision and all those things for image detection, stereo vision, and moreover use sliding window for the local mapping and global mapping. There are two concepts. So for local mapping, neural network in reinforcement learning there is deep neural network where we use it, which performs very well. So that's why I consider the reinforcement learning in my first approach.
Okay.
And we are still working on it. I think it will work better for local navigations in dynamic environments overall.
All right. Okay.
So what I think neural networks can help for in this simulation, like currently the biggest achievement is NVIDIA announces some robot with the Disney and deep minds. So what they have done, they have created a robot and simulate them in real time, and then the robot gets trained via the real time simulation. So it kind of a reinforcement learning thing, but they are using the neural network for the understanding of the model, because in normal reinforcement learning we use the Q table, which is not efficient. So in I guess 2012 or 13, deep neural networks has been introduced in the reinforcement learning, and which is a big achievement. In 2016 the AlphaGo company beats the Go world champion with the help of a model which trained by the reinforcement learning. So in robotics, reinforcement learning with the help of the neural networks can play a major role, and then normal CNNs can be very useful for the image processing task.
All right. Good. Yeah, thanks.
So we can call the next. No, Raghunath sir, you want to ask a question? No. Okay, then we can call the next.
Okay, cool. The next team ID present here is
Thank you, sir.
yeah, 2087 from MCKV Institute of Engineering.
2087.
2087, yeah. So before arming, just inform me. I have to confirm.
So what's so special about the engineering college?
So good.
It's better
good,
they
good.
will say about them.
Yeah.
Good morning, everyone. I am Ramita Singh, and this is my teammate Baris Moitra. We both are from MCKV Institute of Engineering from West Bengal, Elua. So if we want to talk about our college, our professors are very supportive towards us. They have helped us a lot in, so basically we are from electronics and communication department. So they have helped us a lot in understanding different hardwares, and since this is a project with both software and hardware domain, so we got some advantages from our professors of our college in the hardware domain.
Just 10 minutes. We will arm this zone. You can continue while running. Yeah, cool. Scorers are ready? Yes. Yeah. You can arm the drone. Judges are ready? Yeah. Thank you.
So it is after one person. So
Timer
it's the name
starts.
of one person.
Yeah, now you can explain what all challenges you have faced, like how you have tuned the PID stuff.
So throughout our journey of 6 months, we have faced issue in PID tuning. It was one of the most important factor in a perfect and successful completion of our run. Another challenge we faced was lighting issues, because we had to change our location twice, because the first location was not high enough for the camera. The camera criteria was of 10 feet, but we didn't get 10 feet in our first location, so we had to change our location. And in that location, there was a lot of lighting problems.
One
had
waypoint reach, one collision.
So we had to fix that lighting problem with different tube lights and flashlights.
Two collision, second collision.
So that was one of the challenges, and the rest he can explain.
Yeah, we also looked into we actually implemented a low pass filter to filter out the noise so that we can increase the D gain effectively. So setting the filter cutoff was extremely crucial for this task. And yeah, the PID tuning and obviously the detection at the packages, it's not working now, but yeah, it definitely worked a bit. It definitely worked a bit.
Third collision.
The Vicon detection was also a challenge for us, because in different lighting conditions, the camera was not detecting the Vicon, and when the Vicon was not detecting, the drone was becoming unstable.
Fifth collision. There's an environment. Shakti. Arun.
You can test. It's better than yes, you are better.
Yes, we are better.
So take this, like put your binding please.
नहीं बाइंडिंग बाइनरी की क्या all other team after that just be ready.
Bhavik. Yeah, we'll have another run after the all teams has been complete. Now you can move towards to jury interaction. You can. Yeah. You can explain why this has been happened. Cool. In meanwhile, we can tell we can call another team. That is team ID 2735 for setting up their run. 2735 from NIT Rourkela.
Hi guys, I feel bad for you and worse for your drone. Did you expect this level of
No.
surprise to happen? Anyway, good effort. I think you all gave us a lot of a bit of a laugh in the middle of everything. So, just a sort of general question: what is your understanding of path planning algorithms? How do you do path planning? Suppose you know like where you are, where you want to reach, what the map is. How would you get there efficiently?
For this theme, we actually implemented a A-star algorithm. So we used a heuristic that would we inflated the obstacle layers first. We created the map, then we used A-star path planning algorithm. So we used a custom-made heuristic actually. So first we created a clearance map. So for each free space, what is the nearest obstacle? So then we gave a threshold that if it's too near, then like maintain a margin, so that path will be preferred. So we implemented it using a bias, multiplying it a bias with that, so that it passes like away from, it stays away from the obstacles.
Good. So you mentioned heuristic. Can you explain what are there's two components that go into A-star, right? One is the heuristic, what is the other, and how do they work together?
Yeah, one is the total cost basically. So one is the heuristic and one is the distance. Yeah, basically distance.
Good.
Yeah. So Fn and Hn.
Great.
basically.
Good. Yeah, all right. So you know your A-star. That's what I was asking. All right. I'll pass it on.
So in conjunction with this filter that you've now designed, you said, what necessitated this? Because the other groups we found, they have done it without this filter. So why did this idea of this filter strike you as something that you should try?
Yeah, actually the room we were in, practicing in at home, so that it had very low lighting. So the Vicon marker was sometimes getting detected and not getting detected, and there was a lot of noise, fluctuations in the Vicon readings because it's getting the circle reading and then getting the position. So there was a lot of fluctuations in there. So that's why we had to implement the filter. I mean, here the lighting is good, but in there it was.
Typically, in order to design a filter, you would also require some information about the kind of noise you're trying to filter out.
Yeah.
So, how would you approach this, or how did you approach this rather?
Actually, we came here for practice. So there we were trying with various filter cutoffs. So there we were trying to like check.
Again, a heuristic sort of a check.
Yeah.
Okay.
Check like what is the filter cutoff.
Values for the frequency cutoff and seeing which performs the best.
Okay. Any thoughts on why it went off towards the end?
So
Like your assessment of the diagnostics?
Yeah, like I was checking there. So the icon was suddenly not getting detected. So I think maybe like our icon marker is very like shiny.
Okay.
So maybe this light reflection it did not get detected. So there is too much light, right? So that's why it was not detected and it
So
went
it's
up.
basically it's been tested for a particular setup and now you had to implement it in a
Exactly,
different
exactly.
place. It wasn't robust enough to.
Yeah, exactly.
That sort of a change. Okay.
Yeah, I think very peculiar question. Why did you bother your drone so much that it decided to bolt? You must have put a lot of.
We use a different time. Show the mark. Yesterday we were practicing it, literally cut him.
And you beat him up, right? Okay, now you are also in effect a two-member team. There are three names mentioned here, but you are only two of you here.
Yeah.
One member couldn't come because of unforeseen circumstances.
But that member contributed to your work?
Definitely.
So, but these last few days that you've been here are also exciting and learning in terms of the real heat, the real environment, the real competition, who am I facing? So that is missed.
Yeah.
Okay. Good, all the best. I think making it to the last 5 itself is, as Dr. Arya, Professor Arya said, is highly creditable. I think great work. Good.
Thank you.
Okay. So you had a number of collisions during the first run. What is your diagnostic? Why did that happen? Is it more because of the Vicon issue or because of your controller tuning?
I think like the Vicon coordinates, like package location, I think it was too close to the obstacles. That's why when it reached the package location, it got like it was
some calibration issue there, or
I think
why was it so close?
I think it was more related to the mapping. Like the Vicon coordinates, I think it was too close to the obstacles. That's why actually we took a chance. So we wanted it to be detected by the sensors, but that did not happen and it collided.
Got it. And the issue that you mentioned, that later on that Vicon marker was not detected and that is why it went off. Have you implemented some kind of Kalman filter or some predictive algorithm to estimate where the marker would be?
No, we did not.
It is always just in kind of detecting where it is, and that's it. There is no filter on top of that.
No, completely based on what we
But
are
if you
getting
think
from
you
the
had a
camera.
filter designed on top of that to get the marker location. So if you have a
Estimated.
Kalman filter or estimator on top of it, could that have prevented something like this?
I think it would have.
Because it will not go off quickly, right? Then it will just predict where it is and wait for the next actual reading.
Yeah.
Okay.
It would have stabilized that there.
Okay. Thanks. Good job.
Yeah, thank you.
I have a question. How do you suggest we recover that drone? It's a valid question, actually.
Yeah,
using another drone.
Actually, maybe it is already connected to a battery. So maybe if we take another transmitter, maybe remote control one, set the binding phase equal to that, then maybe we can control it back here.
Okay.
Maybe.
Okay. So can that be turned on and flown from where it is now?
It is actually turned on right now, so I think it will connect if we set the same binding phase.
Before the battery runs out.
Okay.
Yeah. 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 Then that would be difficult.
Look, technically, as you said.
Yeah.
Using another
And
device to get back. It is physically stuck.
Thanks.
Thank you, sir.
Team can
Thank
meet
you,
us for exit interview
Hello.
on reception.
Team.
Yeah.
Hello. You can go for exit interview.
You can go to reception. They will tell where exit. Okay. So this is next team, that is 2735 from NIT Rourkela. Team, just ping me if you have set it up. Scorers are ready? Judges are ready? Yeah, cool. Yeah, team can arm the drone. So timer starts. So yeah, you can introduce yourself and start explaining about your challenges.
Hello, I am Swastik Aditya Ranjan from Warehouse Run 2735. We are from college National Institute of Technology, Rourkela. This is my fellow
One
teammate,
collision.
Priya Ranjan Raut. And the problem we have faced is started from simulations only. We have to learn.
It's an invalid run. End of run. So they are moving towards the second run. Scorers be ready. Judges ready. Yeah. Team can arm the drone. Timer starts. Yeah, end of run. Yeah, now team can move for jury interaction, and you can explain what happened and what you think might be a reason for this. Yeah. So in meanwhile, next team, team ID 1284 can start setting up their run.
Good morning, sir.
I'll start. So, hard luck, but nevertheless, great effort. So, what went wrong? What is your understanding?
So, there is some lag in the feed. So,
Lag in the feed, the camera
yes,
feed?
Yes, sir.
Okay, that is introducing the latency and.
Yes, sir.
Okay.
So, due to the lag in the feed, the integral value keeps increasing.
Increasing. Oh, like, of course, your control loop will become
Yes.
unstable if there is that latency. Do you have a way to measure that? Do you have a way to estimate how much that latency is? And
So, we can measure the frequency.
Okay.
Of means how much images it is producing per second, like that.
Can you think of a way to measure that latency and kind of auto-correct your algorithms to account for it?
So, we can use filters. Means if latency means the same image gets posted, na. So I don't think filters will help there.
Yeah, filters will not help. You will have to
Because
first
we
estimate how much the
will
latency.
speed up. We need to speed up the camera only.
Right, but if
Because camera is lagging.
Okay.
I see a team of 4, but you're 2 here. Second year.
Yes, sir. Second year.
So what happened? The other two contributed?
So they are not contributing.
So it's
they have
been
not contributed.
two of you throughout?
Yes, sir.
Okay. So you learned about this latency pretty early on. Any approaches that you might have thought about in the control system design to at least try and alleviate if possible, or is it like impossible to do?
It is possible, but we can eliminate the errors by using some filters.
It's not just about errors, no, it's latency. That is a
So the delay.
Yeah. It's a
The
much more
delay is
serious problem.
mainly due to the heating issue of the camera.
Mainly due to the?
Heating issue of the camera. Means after regular runs, its frequency drops. We have observed that.
Okay.
So we have to wait for some 30-40 minutes after that.
Then we run.
The run will be fine again.
Yes.
But if you run steadily for a long period of time, the camera will. Sir, this one, sir, Lenovo.
So the overhead mounted camera, the field one.
Okay. So if that is correct, if your surmise is correct, then it should be the problem. It should be a problem with other groups, the one that comes after as well, isn't it?
So, but we have observed that
Yeah.
the frequency drops gradually. Means when the camera is on for starting, it comes around 30 FPS. Then it gradually drops and comes around 20 and below.
I understand your observations, but is it something to do with the overall setup in itself, or? Yeah.
So we can use better cameras.
No, that's that kind of defeats the purpose of control system design, right?
Let me be the devil's advocate. I say, if camera is not a problem,
Okay.
what else can be? Okay.
Means
If camera is not
what
the
we will
problem.
use instead of camera.
No. I am thumping the desk and saying camera is not the problem.
Okay.
Are you still going to say that camera is the problem? Or,
So
would
we
you
can-
accept, or would you step back in your thinking and say, yes, have I explored other areas that could have gone wrong?
So because as our previous runs we have met with our camera, so it was far better from this, and we have successfully completed all the detections.
So is this the first time today during your
No,
two
today
runs
morning we have
that you-
tested in this same camera, it worked.
So then your theory of camera not being the right thing is not valid, right? If it worked in the morning, then how can we say
Sorry,
that in
some
later
time was given.
Sorry?
Means, some break was given before it.
I don't quite follow what you're saying, because if it worked in the morning and it didn't work now, and if 4 is a statistically sensible number, 4 or 3 other teams seem to have presented. Sorry, I just want to, sometimes our minds get fixated on what we saw happen. Why you seem to be fixated on the camera? Do you even want to consider that it could be issues other than the camera?
So because
as Dr. Arya said, it's about solving a problem. It's a problem that you've had,
Yes,
right?
sir.
Forget the problem of the warehouse. Now look at the problem that you have had a failure. How would you solve this problem? Simple answer, change the camera?
No, we can do other things.
Like what?
We can have a better tuning per PI.
Okay, thank you. Good work nevertheless.
Thank you,
The
sir.
fact that 5 teams have reached
Yeah, whether this works or not is not important, but how you're thinking things through, assessing the situation and trying to get past it.
Very often in life, we give up because we are, in our heads, we have decided what the problem was. And then we stop thinking beyond that. That's, I guess, the little.
So I have a more technical, follow-up to the same discussion we've been having. Don't be so disappointed. It happens. Congrats for coming here in the top 5. But the thing is now, a lot of robotics working with hardware and so on is debugging, right? When things don't work. I'm sure many more of these events happened when you started. You got better at solving them, right? So how much code have you written in terms of logging, debugging? Like if you, can you look at the trace right now and have a much better understanding of what happened? Of course, right now you were answering these questions just with your own intuition, right? But is there a record now that can help you diagnose what might have happened?
Sir, in the debugging part, we have done debugging for, we faced a issue of frequency in the loop, of the PID loop and the loop which checks the drone, the presence of the drone in the sphere of the, means when it is locating the package. That we tried to debug, that it was getting, means the frequency of the PID loop was getting reduced due to the checking of the, that
Sphere in the loop.
Sphere means package detecting sphere. That loop was running at a very high frequency, so that the performance of the full laptop was coming down. The drone flies to the package. When it gets into the sphere for the first time, the loop starts and the PID loop fails. That we faced a issue. We tried to debug it and we found the solution after 2-3 days.
All right.
That was the main problem we faced.
All right. Thanks.
Thank you, sir.
Okay. And then
so team can have team set it up. So scorer can be ready. Judges ready. Yeah. Yeah, wait. So yeah, now you can arm the drone.
Cartooning and the other.
Yeah, meanwhile they are setting up, you can just introduce yourself and your college.
Good morning everybody. My name is Arjun. This is Salo, Govind and Devanand. We are from SET College of Engineering in Trivandrum, Kerala. So we are actually studying artificial intelligence course there. So that came at a disadvantage of being, we are not very familiar with the hardware or the, even I didn't know what PID was before coming to eYantra. So this meant that we had to learn a lot to even compete at this level with other students. But being in core computer branch, we had an advantage that our software, the software part of the whole system was very good. This means that our so this meant that in the code we have a path planning algorithm. So we were since we had a better understanding of writing good code, we really optimized on the path planning algorithm. So we took a really good path planning algorithm, BAT star, and optimized it for this custom setup. This meant that our path planning part was almost perfect almost all the time. This gave us a really good base working model. Also there is we had to make an artificial intelligence model within this system which will convert the Vicon coordinates to pixel coordinates. We also went overboard on that because we are artificial intelligence students. We tried a linear regression model, then tried neural network models with different parameters, and that thing was also almost perfect. We got almost perfect models in both training and test set. Also, unlike other participants, our setup on our house had too much lighting. The lighting was really good, so the overall setup combined with the almost perfect software meant that our drone was working really good at our house. But yesterday when we came here, because our lighting was really good, because it was under direct sunlight, we had an issue with the image processing part. So our drones were, the Vicon coordinates were not properly detecting during that part. So that was a problem. So right now it seems as if there is some arming issue. The drone is not properly being armed. It was working yesterday. Yesterday we were facing the problem of the Vicon coordinates not being detected because of the lighting issue. So hopefully it will be resolved soon.
So actually the receiver is not connecting with the drone, so it's going to an hotspot mode. After 2 minutes the receiver will go to hotspot mode when there is no connection is there. So this is happening. Constant.
So did you guys ever have this arming issue before?
No.
Okay. Welcome some other people who just joined. Okay, while these things are being resolved, I'd just like to join a few more friends who've joined. Saraswati Kritivasan here, who used to be a senior manager with eYantra in the very early stages, who helped us build up the program. You can stand up and take a bow. Big hand for her. Yeah. Is Krishna Lala here? We have Dr. Krishna Lala. She's not here in the audience now, but I think she's around, who kind of also helped us a lot, especially build up our amazing lab setup environment. We have about 550 eYantra labs across the country. We have two friends from industry. We have Prakhya Avasthi and Ayushi Bisht. Is that you guys? Okay, from Adverb Technologies, who's a drone warehousing company, is it? Okay, so warehousing is very close to your heart. So okay, thank you for being here. They wanted to see what we do with students. Yeah, thank you very much. Big hand. So while this is all happening, would you guys like to offer your comments about what you've been seeing? Starting with Nitin maybe, because he's our industry guy here.
I think it is very commendable. It's very, it's a great opportunity for students to quickly learn so many skills by participating in competitions like this. And no, thanks to you, Professor Kavi Arya, for taking this initiative and making it such a big movement. And yes, no, so it's really great because as you correctly mentioned in your initial speech that a lot of these skills are otherwise regularly not taught as part of the regular curriculum, and this is what really matters and what is really important for the industry. And as people from the industry, we are always looking for students who have that spirit, who are looking to who are looking at such opportunities to upskill themselves and really acquire the skills required to solve real problems. And I can really see these students will do well as they move ahead, because these will be the guys who will be sought by the industry, because they can be absorbed quickly and they can quickly actually understand what's going on and use these skills to solve those problems. So thanks to you and thanks to the students for taking it up so well.
Big hand, I think you're very So traditionally, sort of at the end of the theme runs, we kind of we invite our jury members to give their feedback. It's a bit premature now, so I'll save them till the end, until they've seen all the teams, because you never know what is going to happen in the next round, basically. But this is a very important insight, that industry wants trained people who are trained engineers, because they have to spend almost a year training them, right? Would you pay us for it? Okay, very valid question, because we are thinking of a model now where we can take at least 20% of or 10% of the students who've taken part, put them through a 3-month intensive training program if they are job worthy, means that you're 4th year and looking for a job. Put them through a 3-month program and then place them in industries that actually can use their core engineering skills. Yeah.
So another important thing that is very important right now is all that is happening in the world of AI, and the world is moving very, very fast, and the entire world's foundation is being rewritten because of AI. And what that means is that the training programs that we design or think about have to embed AI in whatever we do. So as an industry, we are an AI first company. We use AI across all our functions, and we are completely redoing the way we used to do things. So the way we used to think about control systems and the way we used to think about all kinds of automation is completely changing. So we'll have to, even as part of academia or trainings and everything, will have to be completely rethought of. So
you set it up for me, Shivram. Shivram is our AI expert, so perhaps he should comment, and maybe, first of all, can you help us?
Yeah, so I think the easiest first thing that comes to mind is my own journey. I remember being a grad student. I mean, I didn't get into this in my undergrad, but I was doing something called reinforcement learning when I was in grad school. And I remember when I wanted to come back to academia, I had to make a very conscious decision. Do I get into hardware, robotics, or stay on the software side? I was an escapist, right? I didn't want to be sitting here debugging the way these students are. So I chose that most of my work is in software. I don't really work with nuts and bolts and soldering and hardware. But I have tremendous respect, right? Because the real world is the real world, okay? And solving problems is not like an academic, purely scientific, abstracted endeavor. It's got all of these things. So what we're seeing is the reality of getting these systems to work. And I mean, I've also been a teacher here, right? I've been a faculty here at IIT Bombay for 10 years. It's much easier to teach students, get them on board if you're doing equations and maths and highly abstracted stuff. It's much harder, right, to roll up your sleeves and work with hardware, right, diagnose. So, I mean, we've seen 4 teams, they've been answering our questions, and it's very clear that they have this view from the trenches, right, which is not apparent to many of us. So, hats off to Kavi for being, persevering with this for so many years now, and 250,000 students is no mean achievement. So I think this is really tremendous. You know what really speaks for itself? The fact that it's not working and there are students sitting there and debugging is really something to be very proud of. This is really the point of e-Yantra, I think. and really hats off to Kavi. Let me hand it over to anybody else. AI, okay, sure. Yeah, so the crystal ball was from 10 years back, and I think all the predictions we made, none of them is going to come true because generative AI happened 1 or 2 years back. Okay, so a little bit more. So 2015-16, there is this person, Eric Horvitz. Okay, Eric Horvitz is like a pioneer. He was at Microsoft Research, very well-respected scientist, who I think foresaw that AI is beginning to accelerate. Okay, it's no longer just an academic discipline with a little bit of application. As I forget your name, Nitin, right? Mentioned it is revolutionizing technology, not only in computer science, in various fields, whether it's aerospace or chemical engineering, material design. I mean, AI is now an integral part of the technological design process. And he foresaw this and said, how is our world going to change, right? Let us not just, I don't know, passively like observe. Let's try and anticipate, forestall, right? Be prepared for this future. So he got a bunch of us together to write a report. That was the first time, but he said, let's track it for 100 years. Okay, so there is this AI 100 center that is anchored at Stanford University, and the point of that center is every 5 years to checkmark, right? Write a report saying this is the state of AI, this is what we expect it to be in the next 10 to 15 years. So I was a part of the first study panel that published its report in 2016, and we said we are not going to look so far in the future. The crystal ball was focusing on 2030, about 15 years from where we were right now. And we were, I think there were some things we did right. We said, let's not try and predict it for the entire world. Let's predict it particularly in sort of the developed world. We'll focus, let's say, on a typical North American city. So some of the things we said, I think, are natural, that there's going to be more data that's available digitally. It's going to start making inroads into various fields. To some extent, that has happened. But I mean, some things you just can't predict, right? You could not, these are sort of like chaos, non-linear dynamic type of things. Generative AI comes, and within a matter of a couple of years, like it's taking over a lot of traditional model-based reasoning, right? Classical ways of reasoning and making changes. So that's not a part of our prediction. You can read the report, okay? But yeah, that was the first one. There's a second one a few years down the line. The other aspects, of course, it's not purely about the technology. It's also about people. Right, so why AI at all? It's because, I mean, we want to make our lives better. Maybe we want to understand intelligence, reasoning, things like this. I think maybe still there is not sufficient understanding of what as a society, right, what as human beings we want, right, what we want as a relationship to be with AI. Particularly relevant, I think, in the Indian context is we are a very, very diverse society. It's wonderful here to see teams from, let me see, there's one from Chennai. This is Kerala, we had Orissa, we had West Bengal, we saw Kashmir some time back, right? Of course, it's nice for everyone to be doing robotics, but when we go back home, we speak different languages, we eat different food, we have different cultures, different priorities, right? Not all of this is represented, right, in the digital domain equally, right? There is so much skewness in the kind of data available. And AI feeds off that. When you have generative models, right, they are built on data and they will be biased, right, based on what they have been trained. So if we really want to make AI profitable to all of us, represent us well, that's a non-trivial problem. I think as a country, right, we have like a great opportunity for doing it. It's very heartening to see so many students, right? So I hope many of you will make it a part of your journeys, right, to do AI on our own terms, right, solve problems that are of importance to us. Drones is a great example, right? There is so much going on with drones in agriculture, maybe in security applications. Apparently Kumbh Mela happened successfully because there were so many drones looking at the multitudes that were going to take a dip, right? So I think this is like a great, so many things happening here I think are a sign of the times to come and everything that we should be doing, right, to embrace AI in the right way, right, and do it for our own sake. Anything more?
I've been looking for someone who can take over from me, right, at IIT, and I've been trying to sort of reel him in slowly. He came to us to pick up a drone. Some student is doing some drone-based work with him. So now I hope you realize a very important role that you can play now in kind of turning this whole journey towards AI. It started with pure embedded systems and then robotics and control systems and so on. Now I feel that AI is going to sort of cover everything. So you can play an extremely significant role in this journey. So perhaps with the encouragement of our friends here, we can have a discussion, have a conversation perhaps. So we have Ian Page also here, and I'm going to reserve his comments for a bit later, but a few initial comments. He gave me some ideas for themes, incidentally. Reaction to him?
Well, absolutely right that AI has already changed the world and surprised all of us that have had anything to do with the subject over the years. But these core skills are still going to be important, and you must remember that when we're looking at something like this, the output is not a drone moving around, it's in the minds of those people. That's what we're producing here. And having a challenge, even an extreme challenge like this, and this is quite a difficult one, is valuable, because you only find out what your own limits are when you're challenged yourself. So taking on a really difficult engineering project like this, you learn more. It might be harder, you might fail a bit more often, but what's changing is up here. It's your ability to respond to the challenges that the world throws at you whenever you try to do anything, make anything, design anything, fix anything. There are problems that the books will never tell you about. So it's only experience that can get you through those sorts of problems. And that's what we're seeing here, live in front of us, and I think it's wonderful.
So we're here for the last team now. So I thought let's be opportunistic and get some words of wisdom from each of our friends here. So over to the team.
Yeah. Yeah. Now we can start it. You can start it. Yeah. Connected. Yeah, drone arms. Timer starts. Okay, end of the run. So they are moving towards the second run. You can place it if you're ready. Check the drone is connected. Score ready. Judges, are you ready? Yeah. Timer starts.
Shri, perhaps you can mention to the audience what is the capability of the drone in terms of sensors and what it can do, what kind of missions it can do.
Okay.
Payload.
Regarding drone stuff, the main focus is where the human intervention we don't want. There we are more focusing on implementing the drone there, and it's like most probably in sensing area, and next is which is I feel little in agriculture they mostly use for irrigation purposes.
No. This particular drone that we designed,
okay.
What are the sensors which are available on it?
Sensors you are talking. So we have a camera. We used to have image processing of the circle, which is called as Vicon. So with the help of that, we do some transformation and create an Vicon units.
No, on the platform itself, what are the...
Okay, platform...
What's the payload that it can take, all these kind of things?
Regarding payload, we can't, for this zone we are not, there's no payload capacity here. And the regarding sensor, there's two controllers. One is internal control and external control. Internal control is position control. For internal control, we have IMU sensors for doing an attitude estimation and control, end of that. Yeah.
And what's the processor?
It's an STM F405 controller, STM F405. Yeah. And we use beta flight firmware for internal loop for attitude control. Yeah, team can proceed for jury interaction.
Hard luck, fellows. So don't be too crestfallen. I'm not going to ask you what happened, maybe somebody else will. But you had, when you introduced, spoken about starting from the AI and software side, right? And then moving to this. So what were the hardest lessons from the real world? Something like this, but what did you learn? Specifically, what skills did you have to pick up to work with hardware?
I would say it's about patience mainly. So, like when coming to the hardware part, you don't know what's going to happen. In the simulation, it's an ideal world. So everything will kind of work 100% at 100% efficiency. So coming to the hardware phase, it's not like that. So it's pretty challenging. That's it.
Good answer. So yeah, the usual question. What do you think went wrong in your opinion? Not the delayed start, I'm not talking about that. I'm just talking about the 2 runs that you had.
In our part, like in the code, we had a logic to hover over the origin. So, like after that, the initial wave, like when a drone starts, like it goes to 100% throttle. So it produces a wave. So we had a logic to stabilize that by stabilizing its origin, then go into the point. So it was like trying to stabilize at the origin.
I saw it moving in circles.
Yeah, it was trying to stabilize at origin to reduce that wave, then go to the targeted point. So by that time it got collided, and then that's the.
Okay. Any hardware issues you might reckon that caused this, or?
Hardware issues?
No.
But we had to. The receiver was not. Something happened to the receiver. That's the reason for the delay in the first one.
Yeah, that's okay.
Second one is not a hardware issue.
Okay. All right.
You said something just now. No, it was not a hardware issue. It was not a hardware issue probably, and you also said something before that. What did you say? I missed that point.
Oh, like stabilization in the origin.
No, then you said it stabilized and then it went.
Yeah, like after, like in the logic of the code, it was supposed to stabilize at the origin, then go to the targeted point. But here it actually happened like it tried to stabilize, but one collision happened, then like everything went wrong. That's the reason. It couldn't recover.
Bigger circle?
Yeah.
Maybe. You should have taken because bigger circle. So fix that radius.
The sticker is fixed. We can't change that. Like
not the sticker. You're talking about a stabilizing radius, right? Yeah. There's a difference between this setup and the setup at our home. So dimensions are the same, but the main difference is the lighting difference. So in that setup, this was working properly, but actually we should have taken into account that the lighting would obviously be low because it is not under sunlight, right? So we probably should have increased the distance, the radius, but we did not.
Have you considered, or would you like to consider the fact that since you mentioned at length in the beginning that you are artificial intelligence people, you are not hardware, etc. Did you, I won't say you took hardware for granted, but did you take therefore the understanding or a deeper understanding of hardware for granted. You are saying there is no hardware issue, but yet your skills could not, kind of create a result which you expected, right?
Yeah.
So is there something that needs probing internally? I think
I think we could, like, if we had time, we could do something about this, but unfortunately.
what do you mean time? You've been working on it for 6-8 months. Right?
Yes, true. But
yesterday we tried to test it here, but when we tried to fly it, the camera visual was being blurred and the icon marker was not being detected properly. So we couldn't properly test it yesterday. That is why it became delayed. No.
One opportunity, it's a suggestion, it's not a question, is there's another group also which talked about the same, detecting the marking and so on, probably some shiny or glossy this thing over the surface. And you are also probably alluding to the same thing. But there are others who probably did not. So is there, I don't know, this is also a question for e-Yantra perhaps. Is there a way where the 5 teams could now meet and do a little bit of a soul searching, if you may, in terms of what went wrong and why? Because that's where the final lessons are. Or would you just pack your bags and say, I'm done, I'll go home?
That's typically what happens. They don't want to know. It's over.
Yeah, I think, but you might actually, in the format, force
Makes a lot of sense.
In the format, you might force it.
Yes, makes a lot of sense.
Thank you.
So you guys are from artificial intelligence stream, and you mentioned initially that learning all of these things was very new to you, and even coming to the level playing field was hard. Now suppose you were to solve the same problem without using the traditional control systems approach, using artificial intelligence. How would you go about solving it? First of all, is it possible to solve it? Are you aware of people who today are doing robotics using?
We could use reinforcement learning to make a controller that could fly in this environment. I think that would be a best approach.
So what are some of the latest developments that we have seen in the industry today where AI is being used to solve robotics problems?
Nowadays, autonomous cars and other similar types of
That's been going on
systems
for a
are
long
coming.
time, but something very recent, last 3 months. There is a lot of noise right now, right? So NVIDIA recently demonstrated various products. There are a lot of humanoid companies now who have excellent mechanics and all kinds of, they are able to do all kinds of jobs that was very hard to do with traditional control systems. So are you aware of those things, being artificial intelligence guys? Right. So
are you talking about the model which NVIDIA just released, which can be used to create realistic data sets, which can be used to train models in real-world applications, right?
Have you looked at, for example, Figure Robotics, the humanoid company that is becoming very popular?
No, I'm not aware of it.
Have you heard of VLA, Vision Language Action Models?
Yeah.
So
Language
how
action
do
models,
those works? How do those work, and can that be applied to a problem like this?
Yes, it can be obviously, but at least of right now, all of those models would have the camera inside the drone, inside the system which is working. But we have a system in which the camera is on the top.
You can train it with that as well.
Yeah. If that is the case, then we can obviously do that. But we have to extend that thing to working on a drone instead of most of the data sets are for four-legged or
you can train your own model with the data from
data
this
set,
camera,
yes.
and then see implementing that methodology or that approach where you're using vision and action to basically train your model.
Yeah.
Okay. Thanks.
Thank you.
Thank you.
Thank you.
So thank you very much, guys. This is where it's my happy task to kind of
request you to sum up what you saw. And Daipan, perhaps you can start first. You can face the audience, perhaps. And Romesh, you after that.
Yeah, so I've been coming here for the last few years. I think even in the middle of COVID, you had something arranged.
Yes, online.
Through the hard times, online, yeah. And I've been seeing all these events. I think this is the first time I'm part of a drone show of this sort. And this, of course, adds to the level of complexity and the difficulty of implementing this. As a result, I'm thankful you have this net, because on one of these occasions, it might have hurt somebody in front here. But yeah, all said and done, it just shows that you've really scaled up the level of difficulty and really ramped up the challenge. And therefore, the teams that have participated, they shouldn't feel crestfallen or down about the fact that some of their schemes didn't work. But rather, what's more important is that you carry this thought forward, that why you have failed. So if I may pontificate a bit, this is one of the things I tell all my PhD students, not that everyone pays attention, that you should always have a note, whether it's in your computer or hard copy or up here. This is something that is not very reliable, you might forget, but it's always good to keep a note of all the ways in which you've failed, all the things that did not work.
In life also.
True, true. It's a good practice. But particularly in research, if you want to really do something meaningful and really learn things, right? A few things will work, but most of the things don't work. So it's those experiences that teach you most about how you should go about things, and that's a database. It serves as a database of things that you shouldn't try later because it didn't work for such and such reasons. Of course, when you say something hasn't worked, you should be sure that this is exactly the reason why this didn't work. So that's one of the great lessons that I think kids as young as those in second year have had exposure to now. So I think with this experience, if you really take the lessons from it, it would help you mature into really perhaps even researchers in the days to come. I mean, I know a lot of you are interested in probably recruiting some of them because they are really well trained here. But let me say this, that I'd be happy to have some of them as budding researchers in our groups here, right? So I think there's something in it for everybody, I'd say.
Thank you. By the way, it's very difficult to get even one IIT faculty into a room to kind of talk to them. Getting two is a kind of bonus, and often we have 3 or 4 also. So it's an ode to the fact that they find this activity meaningful, and which is like a big ode to the spirit that you guys bring to it, and subject yourself to the rigors of this 6-month-long experience and come here. And that's what we appreciate, and that's why friends from industry also come. Raghunath, who just went off now, Professor Ian Page, who's a big fan of what we do, and Madhura here, and Romesh, and Nitin Gupta is the first time he's come here. He didn't know what to expect. He was reluctant at first, thinking I don't want to waste time with students, because he's seen what students do, but he had not seen what eYantra does. Right? Am I right? And I hope this has convinced you. I want to know about that.
Actually, I was a student at IIT Bombay almost 20 years ago, and eYantra was not there that time. Professor Kavi Arya was very popular even at that time, promoting embedded systems and a lot of those things. I didn't get a chance to work with you, unfortunately. Recently, last few years, we have been receiving a lot of applications from students who have eYantra on their CVs, and in many cases, students are they are able to solve problems much better than most others, and they usually end up in the final rounds, and I get to interview them. So that is why I knew that there is something like eYantra, but I did not really understand the kind of impact it is having, and the kind of things that Professor Kavi Arya has done over the last so many years. And I got a chance to speak to Professor Kavi Arya a few weeks ago, and then I understood the amount of intensity or the effort that is going behind all this initiative, and what kind of difference it is making to the country. So thank you, Professor Kavi Arya.
Thank you. So what about these eYantra students? Have you found anything interesting about them?
Yeah. So we have had several recruits. I think I don't remember which ones, but I am sure, like in our robotics team, we have people who have participated in eYantra during their college years, and then later on now they are in the industry.
So given the fact that there are lots of drone companies now, specifically apart from robotics companies, do you see any value, say, for 4th-year students who are looking for a job, even 3rd-year students who are looking for internships, to have a 3-month intense program in which we train them in the vocabulary of your industry, because your industry is growing very fast?
Yes. So actually, I have a few thoughts there because I am very passionate about kind of rethinking how we do everything right now with AI. And AI is impacting almost everyone. It's no longer just development of AI tools. It's every sector of the industry and lives as well. And it is becoming very important that we are elevating the level of problems that we are solving, because basic problems can be solved very easily with AI, and those are problems not even worth solving anymore. So we have to quickly elevate the kind of problems that we solve, and whatever used to seem very hard earlier has suddenly become very trivial. For example, now it's that in every dimension you can think of hard problems like human longevity. Can we figure out how can we extend the life of a human to 500 years, or solving global warming, or solving whatever. So there are so many tough problems to be solved, and Flightbase, we work on aerial autonomy, and for us the tough problem is how do we enable the third dimension for humanity. So today humanity is constrained on 2D surface of the earth. We hardly make use of the skies. How can we enable that with millions of drones? And where I am kind of getting to is that it is very important that we wire the students correctly, because the old ways of wiring students, so education is nothing but wiring your brains, right? So you're basically developing your own models and you're training your own models to think and act in a certain way. And now with AI, it becomes very important that we are wiring our brains correctly. Otherwise, unwiring and rewiring them becomes a lot harder than just kind of getting somebody fresh and wiring him correctly. And that is why a very important role for academia, that we start thinking in an AI first manner. What is the AI first way to solve everything that we do? Like even if we have to take notes, are we making use of AI to get all the historic data and make good quality notes for us instead of taking manual notes? Something as simple as that. But then solving these problems now using AI techniques, and there are very well established techniques now available. And I was just talking about figure robotics. So it's a very good example of how a company in 31 months has gone from nothing to having robots today working at BMW at scale. And they are being used in production plants today, and they are now setting up factories to produce 100,000 humanoids a year. And now the demand for humanoids is projected as 1 billion humanoids will be needed by 2035 in next 10 years, so 1 billion. And in another 5 years or 10 years, we will have more humanoids than humans alive.
It means one slave
per person, yes.
6 human beings.
Yes, by 35. And then within another 5 years, 5 to 10 years, we will have more humanoids than humans, right? So that's the rate of growth that is projected for humanoids, and people are already setting up factories to produce these humanoids at scale.
Will these guys have a job then?
No, so why not? Like who will be building these factories, or who will be designing? So that is why it is very important to rewire ourselves and start thinking in an AI first way. Whatever problems we are solving, are we leveraging the full force of AI to solve those problems? We should not be competing with AI, we should be utilizing AI to solve problems and do things that are 100x harder than what we used to do 1 year ago. Right, and for this needs a constant push to ourselves that whatever we are thinking, are we thinking too small? Can we think bigger? Can we think of solving much harder problems than whatever like what we used to do earlier? So that's a constant struggle that we are going through, and we are challenging ourselves, and we want anybody who is joining us comes with that sort of a mindset. That mindset, like Dr. Page mentioned, that it is the mindset that we are kind of cultivating here, not really the skills in terms of whether they succeeded in this mission or not, but it's the mindset change that happens and how they approach solving problems. And that mindset has to be an AI first mindset, otherwise there'll not be much for us to do in the society. So
that's a very good insight, thank you very much. So I'm going to now go next to Romesh, and then I'm going to save you for the last again, by the way. I want you to respond to this, and I want you to answer the question, how can we help him? Okay. Huh? Yes. Oh, he can help. Yeah, Nitin, so you have to work with us actually. Yeah.
Hi, good afternoon everybody again. So it's been a very invigorating, energizing and experience. I think it goes back to, yesterday I heard a term called retirement, and I was told it's a French word. I had never known that before. That retirement was a French word.
I don't know the meaning anyway.
Yeah. So I'm trying to come out of retirement, so to say. So I came to this campus, this auditorium about pre-COVID. We talked of having done something during COVID. So Kavi used to invite me during pre-COVID days, and it's like those times all over again. One thing I have found at a personal level, it kind of keeps you alive. It keeps my brain and my mind alive to be interacting with young people and asking questions and learning. Even today on the side, I might know very little about, little is an overstatement, about drones and so on, but I was trying to take some notes on the side, both my sides, and trying to educate myself. That said, I think applications is certainly which industry, and I used to tell Kavi even then, back then, those days, I guess, Kavi, if I'm right, the focus used to be, how do you, through this e-Yantra initiative, create a lot of startups? I'm very happy to hear today that it's not only about startups anymore, it's also about employability, it's also about skills that are missing, it's also about things which are going to be there, because 5 years down the road, the skills that people will need to have are very different from what the skills are that are on offer today. So therefore, how do you build those skills which will be used by businesses and industry, and no matter what, brick and mortar, so, and yours is not brick and mortar, or warehousing is not brick and mortar, but yet skills are required to make it happen efficiently. So all in all, I think congratulations to all the 5 finalist teams in any case. I think they have done a commendable job to have come here after a long journey, and also to those who have participated earlier and have not reached there. So there's a great life ahead. So I think I would personally, as I said, coming out of retirement, I am personally very committed to be of whatever help I can to Kavi on the side, and try and see how I can help.
Good.
Yeah.
The first stop is Jammu and Kashmir.
Yep.
Right here.
Okay. Thank you. I
Right.
saw some Jammu and Kashmir things here anyway before that.
You should talk to them actually.
Yeah, yeah.
So
Thank you. Thanks all of you.
how can you help us rewire the brains to be useful to our industry?
Yeah, I think the first step really is to understand what is going on in industry. Some of these things you've just said, I was just not aware, right? So I don't think there is enough maybe conversation between industry and academia, especially with the fast pace at which things are moving. I'm just curious, specifically with these billion humanoids, why do we want a billion humanoids? What are they doing? Maybe you can just answer this.
No, so see, the thing is, in order to interact with machines, we used to think about human-computer interfaces, right? HCI, etc. That was how we would design an interface for a machine to be able to do things. So now everything has been designed for humans, like your doorknobs, your steering wheels, etc. So the easiest way to leverage everything that is around us is to build a machine that can act like a human and interact with all of these things. So it's the same thing as like what OpenAI did with Operator. You are aware that now you can have a agent that will go to your browser and do everything for you, ticket booking, this and that. So the idea was that instead of depending on APIs to be available, to be able to interact with your code, can you have a human-like agent that can do the same thing that a human would do? And same thing for physical world. If we have a humanoid, it's like an operator for a browser. So now you can do everything that a human would do in the physical world, like you are doing in the digital world with an operator. So you don't have to redesign your machines to have APIs or interfaces for machines to be able to talk to them. You can just have a humanoid doing all of that for you.
Thank you so much. Yeah, so that was illuminating. A few things. I think with AI becoming like growing so fast and becoming so accessible, I mean, the average person can do so much, right, by just using an LLM to answer queries, like use their APIs to do things. As an IIT, right, let me say this from my perspective as somebody who's doing research, teaching students, I think there is sort of like opportunities at 2 levels. One is putting together available tools, right? There is a lot of creative development that can be done with that, which I think we should capitalize on, right? And innovatively, like think up solutions and so on. Our focus here is a little bit more the other level where, I mean, what happens if something doesn't work, right? What is the nuts and bolts? What's the mathematics, right, behind the AI itself, right? That is, I don't know, traditionally what we have been tuned to be doing. That's what mostly we are thinking about, we teach in our classes. I think we need people at both levels. Particularly, I think there is a shortfall, right, of the in the second level that I'm talking about, where you understand from the ground up the technology. That so given that there are so many students over here, is a lot of mathematics, right, understanding concepts like probability, programming, discrete structures, things like this, that I would certainly encourage, I mean, the interested student to take up. It is a little bit longer and harder journey, but we need people with that sort of skill set to also build the deep tech, right? Not just be users of tools that got built somewhere else. We need that stack indigenously built, I think, here in India. Look at China, Israel for comparison, if not the US.
We need to build the humanoids.
Yes, we have a lot of humans, maybe who can help with that effort. But yes, we need to build technology, I think, from the ground up. And I think academia can't afford to have its head buried in the sand and not worry about the real world. Industry is what I think keeps us relevant, right? We need to work quite closely with industry partners to know what the relevant problems are, where the opportunities are, and to make it happen.
Great, thank you very much. So now we made a good start, and now hopefully we'll see more industry engagement. And I think, Nitin, we should call you back on campus to have a kind of systematic engagement. Now I'd like to thank you all. There's a little gift that we want to give you. I think the other theme has already begun. It's in the computer science building, but you'll be seeing it on the video here. Yeah? Okay. Sir. Nitin. We don't give useless certificates and all that. We give stuff to eat. Stuff that matters. Thank you. Good. Thank you. Sriram? This will feed your family for a day.
Wow, thank you.
Thank you. So, the traditional hamper. Yeah. Thank you. So, has that started? And for fine, shortly we start. We have some tea outside in case anybody would like. Yes.
Just that only. So we have the tea and refreshments outside, and the next theme, which is the logistic cobot, we'll be having it in another building. So we'll be live telecasting the theme runs to this auditorium, and everyone can be seated here to watch that. Thank you.
Sir, we are taking
So 2:30. Yeah. Yeah. You can just wait.
Is it similar to something we had seen earlier?
Kind of.
Then I may not need the briefing. No, because I'll come a little later. We have a DFM, right? That's right.
Oh, we are good at doing these kind of things, so we can come later.
So I'll come around 2:30ish. Otherwise, half an hour less.
Yeah.
The DFM.
You just need to.
That's a lot of work.
Of the logistics robot, I just briefed you about the robot. So this is the eYRC robotic arm that they have used. And second is the four-wheel differential drive. So these are both our industrial robots, and that is the overall idea, to give access to students to develop algorithms on industry-grade robots. The middle on the C is the simulation environment. So the competition was held in two stages. The first stage was simulation, where they fine-tuned their algorithm in a simulation environment, and then they migrated to hardware. They got remote access to the hardware. So what we focus on is using of robot operating systems, Gazebo, Move It, Navigation 2 and computer vision in this team. So ROS2 is basically a communication medium and allows the data transmission between the robots and overall algorithm. The Gazebo is the simulation environment we are using. As for the tools, like I said, ROS, Gazebo, Python is the programming language that these students are using along with open source computer vision library and Nav2Stack. Finally, you can see here there are, so upper is the simulation environment and the down is the real world environment. So this is how the students got access during the remote runs. They used to, there are cameras set up in this room. Using this camera feed, they used to get a feedback of what, how things are going on, and they can then alter their scripts. So again, the two robots that we have. For the finale, this is the conveyor 2 and that one, the far one is the conveyor 1. So what students have to do is they have to pick up these boxes and drop it at the appropriate conveyors. The box number 2, that is even number box, will be dropped at the farthest conveyors, that is conveyor 1, and the odd boxes will be dropped as the nearest conveyor, that is conveyor 2.
How do you know which is order?
Basically the Aruko markers have a number. Oh, so right now I'll reveal the, there are 3 boxes. The first box that is kept is Aruko number 2, the mid one is Aruko number 3 and the last one is Aruko number 1. So apart from the, only the first box should be placed there and the rest both the boxes should be dropped at the nearest conveyor. So this is a short So this is a short theme video to get you an idea of the overall workings. So right now the robot is navigating to in front of the arm. So this is a pre-dock position, and after that their algorithm for custom docking takes up and it places in front of them. So as you can see here, the based on the Aruko marker feedback, the box is appropriately placed and then it is dropped. Students from all over the India got access to work with the robot, and this is the depth camera view. That is how they see the arm as a feedback. Finally, going towards the scorer part. So there are 2 aspects to the evaluation. One is the scorers and one is the judge. The scorers will mark based on the formula. This formula takes into account different activities that the robots are doing and gives points according to them. So ACI is for correct identification, correct positioning, and basically arm manipulation. And the second aspect is what correct navigation, docking, and other parts. The judges can question them based on their how they decided to design their algorithms, which sensor feedbacks they are using, and what different strategies they use to tackle the problem. Algorithm design, image processing, navigation, effective manipulation, and work distribution. But so basically navigation is for the robot, manipulation is for the arm, and the image. What other aspects and sensor design they have decided to use to tackle different problems, because there might be some tolerance issues. They can talk about how they tackle different issues here, like for example docking, how did they approach docking. Docking is a custom algorithm that each team developed on their own. So they can talk about how they managed to tackle that issue. Then there is the issue of offset. So how did they use the depth camera to precisely know the location of the box and pick it up, how they tune it for different lighting conditions, etc. So that the teams can talk about in detail.
Finally, for this theme, it was developed by Jason, me, Siddharth, and Gavresh. Also, thanks to there were past members Vimal, Madhu sir, Shama ma'am, and Rituja ma'am. So, what was developed by your team? So basically, the robots and the entire interface. So we developed a portal via which the students get access to the remote hardware remotely and then access using it. So thank you to the Ministry of Education and our Professor Kavi Arya and the entire e-Yantra team. Yes, thank you.
Can start the run. Before that, sir.
Yeah, I started. Okay, arm is running. FPC is it publishing? Out of reach. Yeah, you can.
Just come to the outfit. Come to the outfit.
I don't know. Why is it showing as already increased? Okay, can you check Arvis laptop? Maybe we can restart the arm, reset it. Libraries. No, no, no. There is some issue with the system.
hello. Hello, mic check, check. Hello, mic check, mic check. Hello, mic check, check, check. Hello. Hello, mic check. Hello. Hello, mic check. Mic check. Hello, mic check, check. Mic check. Hello, mic check. Hello, mic check.
Okay, they are 1048 Marathwada Mitra Mandal's College of Engineering. So we have Pradyumna and Shantanu from computer science and artificial intelligence data science branch. So maybe you want to introduce yourself.
So hello, I am Shantanu Ekar and he's Pradyumna Pongshe. So okay, so the journey was pretty nice as most of the things were simulation based and were easy to do on the software side as and it was nice.
Yes. You can tell how you decided on
he was.
It's working. No, they are doing the calculation.
What's on it?
So that's fine. Yeah. You're continuing with the
The calculation really is done. Now they will start with the actual.
Yes.
The arm will start moving first, but because the inward velocity is much higher, it will reach end off first, then the arm will pick the box and place it on the inward.
You can start. You can start. Arviz is ready, right? Okay. it's empty. No, it's there.
There is no.
Yeah, it will take some time. Yeah. So your objects are detected, right?
I don't think I can see the particles one.
Okay. No, the RFOs are detected.
Yeah, the RFOs are detected. I can't see the particles one for the.
Yeah, he's doing. The particle swarm is not. It's something you have to do.
Like, I can't move it. I don't think I have access to it.
No, particles swarm. But that will start when you are starting.
Yeah, it's already on the e-bot.
Yeah. But it starts when you give the push. That can be.
So then you can just zoom in now.
Zoom in.
It's working, you can run this repair. You want
You want to reset the
So do I need to
okay. That's fine, right? Now you can. Yeah. Keep checking it. It might start.
I'm waiting for the servo to down.
That's fine. Okay. Meanwhile, you can say about your algorithm.
Okay, so according to the theme, we're supposed to pick up the box. Hello, yeah. Okay. So we're supposed to pick up the box based on the Aruko estimation, the markers on the boxes. So we have a real sense camera over there. Based on that, I can get a pose of where that box is. So then I can servo the arms end effector, which is an electromagnet, to get on top of that box, which has a magnetic plate inside, probably some magnetic metal. And then the electromagnet attaches itself onto the box, which I can pick up then. Meanwhile, the eBot navigates up to the pre-docking pose, after which I have another algorithm which will dock itself parallelly to those both walls and perpendicular to the base of the arm, so that the same camera is able to detect the Aruko on the eBot, with which I'll also get the pose of the eBot and then place the box onto the eBot. After which eBot will go to either conveyor 2 or conveyor 1 based on whether the box is odd numbered or even numbered. And that's the theme, and that's how we'll go forward.
No, they are checking the argument. Yes.
I tell you when the arm part what
Started.
start.
So the arm is trying to pick the box. Is it publishing velocity? Yeah. Yes. It is supposed to do like that. Okay, it's correcting itself. It's fine. Gaurish, can you confirm ACA? So the robot is trying to dock. Keep checking for FPC. Okay, and the arm is trying to pick the box and place it on the eBot. So there are Aruko markers on the eBot as well as on the box. So the camera identifies the location of the place and then where to place. And then once it is picked up, it will drop it on that position. Okay. So there is a force sensor which is getting calculated by the current of the joint arms. So they are using that threshold value of this force sensor when they are trying to pick up the box. So once they have picked up the box, they are calculating how much they are pushing into the box. Based on that, they decide whether to stop or not. So once they have decided that it has crossed the threshold, they pick up the box and then proceed to dropping. Maybe you can tell how the inverse kinematics part. So, how did you calculate?
So the arm's entire movement is based on the servo at each joint. So we can calculate that using inverse kinematics. So now the box is dropped. I think eBot will try to get out now of the dock position because we can't really plan a global path without it being outside the inflation matrix. Just a second.
Yeah, because I guess they have optimized, trying to optimize it so that before it comes back, they are ready with the box. So they are planning that if they pick up the box, meanwhile the eBot. Okay.
Yeah.
Is there any issue?
Yeah, so the passing service failed right now because of the passing service. So the architecture of the entire code is that I have 3 scripts, 2 that control the eBot and 1 that controls the arm. So what happened right now is that the arm signals to the eBot that I am done dropping the box, you can go now. So that service call failed right now, I think because of that some backend issue. Because it's a service call fail, I can't really do anything about it. So because of that, eBot doesn't really know that the arm has told him that I have dropped the box. So I have a logger and I also have what is
Why did the vehicle not move? That's the question.
Yeah, so for a service call failure, I can't do anything.
Yeah, but now that's up to your script.
Okay, sure.
So that is an error case that they have to handle in their scripts, which they have not handled. So basically they are sending a message and it is not getting received. So how do you
We can try again if that's allowed. Because okay then.
So we can stop the timer because valid run is already happened. Yeah. So Gaurish can confirm his game. Yeah. Maybe you can go for stop that. You can go forward for jury interaction.
So why did it move now?
So they will now come for jury interaction.
Sorry?
You can take this mic.
Yeah, so that was them trying to reset the bot back to the home position.
You just reset it?
Yeah, they are resetting it. It's not me.
Okay.
Yeah.
So you're going to start again?
I hope I'll ask them just a minute. Wait. So that
But their one run is over or what?
Okay, so then that's it from
Why is it
our
a
team.
valid run?
So the condition for valid run is they should be the arm should pick up the box and should be able to pass to the input. That's it. The dropping is the extra point that is the bonus part of the valid run process. But that is the entire task. So they did not complete the entire task, but they did the valid.
So that same question that was asked about the script failure, right?
Yeah.
So what exactly was the failure you said?
So we're using ROS2 as the backend, which has a service client architecture. So what happened is that my server function returned the response, which is that which conveyor the eBot is supposed to go to now, and that the arm has successfully dropped the box. So a server has an acknowledgement on the client end as well that yes, I have received the request, I have addressed it, and now I am returning the response. So that returned response wasn't received by eBot. I got a log of the same on my script. So then, yeah.
How you will, normally you are calling an action claim, right? You got it. Somewhere you will be reading the feedback of it.
Yeah.
So you are waiting for a response,
Yeah.
which was not coming. That is your. So whether you got your feedback?
No, I got the feedback, but it wasn't valid. So it was caught in an exception.
That means that exception has to be handled by you, right?
Yeah. So
Like anywhere, any program, what you write has to be like the fail-proof mechanism is what the robustness, what we are like, it's what trying to hear, right? So it's like anytime any action client in RAS will fail.
Yeah.
Even in industries, it will fail. So it is you have to create a recoveries or a timeout based recovery or a response based recovery. It has to be like that loop has to be done.
yeah,
Like
that
keep a note
wasn't
of it.
yeah
Keep a
that
note of
wasn't
it.
implemented because I'd never faced it before, so I didn't really realize that's a problem.
So what he's saying, I want to say differently. Most developers start life building success path, happy path code. By the time the product really starts working, 75% of the code is failure path code.
Yeah.
25% is success path, right? So lessons of the real world,
Yeah.
that failures are common of all kinds. Then the second part, I wanted to ask you, I mean, is the speed of the arm only this much or it can go faster?
Yeah, that's limited from their end.
It's limited from e-Yantra.
Yeah, yeah.
You give only the destination coordinates or you move every
So we can do two things. One is that give velocity to the end effector, or we can calculate inverse kinematics to move each joint independently and then go pick the box. So we did inverse kinematics. So each joint's velocity is restricted from their end. So the maximum velocity at which one joint can be moved to reach the end goal is restricted.
Is it limited? The velocity, why is it so slow? I thought the first time when you did it was faster.
Exactly. I had the same question. The first time when it picked up, it moved faster. But in real run, I saw it was moving much slower. So I was wondering, why is it
You
so?
were doing a calibration run when it was very
Yeah, so that again depends on the backend that they're running on the ARM. As we could see, it stopped after some time. So that's the RTS CP that the ARM has, which addresses both, either end effector velocities or joint velocities. And if it's not, it continuously keeps checking whether the user.
It is from their presentation. Their SAS question is about if you have been the speed of the robot has been optimized to some percentage.
Yeah, we have limited the speed of
We have limited the speed. It is not like they don't have a control on what part or what.
They are saying the velocity is not controllable.
The maximum velocity is capped. There is only a max speed I can reach.
maximum velocity is capped provided you reach the destination.
No, provided.
So every time you are giving 1 mm, obviously velocity is what your control.
Yeah, so I was continuously giving the velocity based on a P controller. It is the addressal of the published velocity on the topic that the ARM addresses. So,
See, overall velocity depends on how fast you are communicating and what is your delta.
yeah.
Right. So delta is very small. Obviously, you're going to wait, see whether it has reached, and then you do it again, see whether it's reached. So if you're going to do it that way, it's obviously going to be small. So you cannot put the blame on them.
No. So the delta is directly, I mean, the error is directly calculated by goal pose to what my current pose is. So there, I'm not taking a path that I'm planning it step by step. I'm directly giving the servo velocities based on the direct goal where the arm is supposed to be, where each joint is supposed to be.
Okay, see, when you picked up the box,
Yeah.
so there was this hurdle, right? This one.
Yeah.
This height, right? So if you calculate the box height, that it should not collide with that.
Yeah.
You
So,
calculate that.
yeah.
So
it
then
did-
you couldn't have given a final destination, right?
No,
might have given an
because
iterative delta.
that destination is fixed, it's hard coded into the code.
It's hard coded.
Yeah. Because the baffle is fixed, there's no need to kind of estimate where it is. It's going to stay there. So that's why that value was hard coded.
So so there is no delta, you only give the initial and final destinations.
No. There is no delta. Yeah, pretty much there is no delta. There is just that my arm will pick up the box first, which is the box's TF coordinates. So wherever the end effector is now, from there, based on P controllers, my end effector will reach there, grip it, pick it up to the hard-coded location because in order to avoid that baffle. And then, based on the Aruko of the eBot, yet again the P controllers will take my arm's end effector above the Aruko of the eBot.
Okay, let me restate the question.
Yeah.
Between the time it picked up and it dropped, how many times you would have communicated to the controller from your...
So that's at a fixed sampling rate of 50 hertz.
50 hertz?
Yeah.
No, that is sampling hertz is your camera.
Yeah, no. At what rate I am publishing the velocity to the arm. So because we don't have direct control of the servos of the arm, we just have a ROS2 topic where we can publish the X, Y, Z or the joint value. And then the actual servo part is handled on their end.
They publish the goal, the target. They are publishing at a fixed rate what goal it should go to.
Yeah, we are publishing the velocity in order to reach that goal.
And then where it is coming back as a topic back to them.
Yeah.
How do you rate this run? Like, what is your mistakes or what was your maybe looks and bad of your run?
So I
completed 2 runs, right?
No, just
one run, valid run, so there's no second.
So I should have added some more error handling. So I didn't think of doing that in my accept block other than just logging that there was an error to this service. So I should have implemented something more in order to handle that.
And you have hit this, right? Collider.
Yeah, again, so then that I don't know why, because that's also happened for the first time. That maybe had to do something with the ultrasonic sensors.
I'm very happy he said that in my accept block, instead of just logging, I should have recovered. That I'm happy to hear. At least he had identified where he has to do what change. You had a collision when you went in.
Yeah.
Why was that?
So that's just, I just check whether the eBot is at a particular distance away from the baffle based on the ultrasonic sensors. So if the ultrasonic sensors don't give me a value that is below that particular threshold, at that moment the eBot won't stop.
So you mean the sensor fail?
If it fails for a particular moment, yeah, then it will collide.
But you know at some point of time you have got the distance.
Yeah. So the eBot keeps going back till it reaches that threshold distance, at which it will stop. So if the...
So when it was here, didn't you get a digital estimate?
Yeah, I did. And then
You already know your destination and you decided the velocity, so you should stop, right?
Yeah, so that is a good idea. So I just went with, if I've reached a particular threshold that is close enough to the baffle, by continuous ultrasonic feedback, stop. So instead of that, if I had implemented that I know the pose and I have to go back this much, I'd have maybe stopped a bit earlier and not close enough to the baffle. So then that's why I didn't really do that. I tried that before.
Basically, he didn't take a early distance measurement and then accelerate to that point and then slow down and ramp down slowly.
Yeah, so because
he went in always expecting threshold will be reached, and by the time that threshold feedback came, it's already too late.
Yeah, so I did try that in practice runs where I already have the distance from the baffle when eBot is right here. But then what would happen is that the further the ultrasonic is from a baffle, the more noise there is. So what would happen is when I plan the velocity and stop the eBot based on the distance from the baffle over here, it would always stop a bit to the a bit further or a bit before the ideal location. And with the continuous ultrasonic...
There's an error estimation. Of course, there is a noise, there's an error estimation. You should stop much before the error and re-estimate. Anyway, so you said you will handle the error better, but is there any other way that you can think of that you will move your bot without handling errors? Is there any other way that you can do it? Any other sensors that you can use to move the bot without waiting for your arm to say that I've dropped it?
Yeah, so currently there's no such sensors on the eBot. There is the camera to see whether the Aruko of the eBot is covered by the box on top. But then that also happens when the arm is hovering over the eBot. So we could have, I mean, we can implement a sort of just a laser sensor or such on the base plate of the eBot, which will look above. If a box is dropped on there, it will see that, yeah, I have a box now.
So you don't get a video feed, not image process that the drop that's been dropped on your.
Yeah, so if I do that, when the box is hovering over the eBot with the arm, the box's Aruko is also covered and the eBot's Aruko is also covered. So that's not enough to gauge that the box is on the eBot or is it still hovering over the eBot, which is why I had communication between the arm and the eBot.
You have the complete image processing. You can do whatever you want with that. So you have the entire image or you have only the Arco?
Sir, they are not doing with the CV. They are using not with CV. They are doing it with Arco markers. Whereas this Arco markers positions, they will get the depth data from the thing. That's it. Real camera.
I thought you were using CV.
Not CV. Not CV.
Yeah, I mean, Aruko estimation is part of OpenCV, but that's the extent of using CV. We are not really having models to detect boxes and such.
So they are using Arco markers. This real sense camera has a capability that instead of RGB data, it will give you one more parameter of depth. So every RGB pixel will have a depth data associated with it. So just they are calculating the centroid of the Arco markers. From that they will get the depth, and then they use the depth using this angle of sight and other things. So they know the position from this to that and things. Maybe any of your runs throughout your trials, you have completed fully?
No, we never reached fully. We could do one box.
Why is that because?
So that's because the pose of the robot in the entire arena, which is done by the global planner. So I took a lot of time and it was too late where I finally found the solution that to localize the bot in the arena. So I was too late in figuring that out.
What could have been best in localizing that?
I mean, currently I'm doing that whenever I reach there, I know exactly where my eBot is. So there I set the initial pose yet again, because what happens is that the IMU that is on the eBot, if the velocity of the eBot is too low, the IMU discards it because of EKF. So then what would happen is the entire map would rotate.
You would have used encoder, right?
Sorry?
You would have used encoders, right?
Yeah, so then again, we didn't really have access to the actual hardware. We just had ROS2 topics.
Encoders will be there, no?
No, we don't have it.
Should be there.
We just, yeah.
You are ready, yeah? They said you are ready. If you are ready, we can stop and we can go for it.
After this calculation,
Yeah. Okay, thank you.
We have one more team, right? Okay, so while we are getting ready, let me introduce our illustrious jury members, colleagues of mine from IIT Bombay. We have Professor Sunthar, a bow, please, who is from IIT Madras, and he did his PhD in IISc Bangalore, and he's been a research fellow here at Monash University and visiting fellow at Stanford University. And he's a chemical engineer, but most of our chemical engineers at IIT Bombay prefer to do computer science or become directors, one of the two. So it's no coincidence that he's a head of department of the application software development, two chemical engineering directors. So he's HOD of Application Software Center, which runs all the software that runs the campus at the moment. And his research areas are things like drug delivery, polymer physics, computational flow modeling, fluid mechanics and stability and colloids and things which are nothing to do with computer science. Right? So he's not alone. There's another colleague of mine who's very keen on pursuits other than chemical engineering. We have Raghunath Iyer, who I have not introduced earlier, IIT Bombay alumnus from electrical engineering here, and lots of experience in industry, and he's been CTO of a networking company called Qualys. But what we respect and admire him most for is his profession as a tinkerer, and someone who loves getting to the bottom of things and taking things apart and being the kind of engineer that we want to see more of. So he's a kind of role model, but his main expertise is in embedded systems and hardware, firmware, networking. His earliest job was in Godrej, building dot matrix printers, right? So he's been there and done that. And then he's been engineering director and head of India office for Kuo Networks. I discovered that only today. And he's been with Switch On Networks as an engineering director. And we've had very interesting conversations. And we even took him to Bhutan with us for a very memorable trip to Phuntsholing University there of engineering, where we have a lab. Then we have Muthu here, who is our alumnus, and he's an example I hold up a lot. So Ian, he's the guy I was speaking to you about, who did a robotics company in Coimbatore. They had about 100 engineers. So he's e-Yantra alumnus from 2013. And he's a CEO and co-founder of Goat Robotics. And he founded an earlier company called Catamaran Robotics. That robot there is built by his company. And he's worked for Bosch for a couple of years before he saw sense and became an entrepreneur. And he was our original intern at e-Yantra in 2013 I think, right? 2014. And I remember being very inspired after his journey, because I told him that time, Muthu, no job, right? You do either a higher degree or become an entrepreneur. He worked for 2 years for Bosch and jumped into entrepreneurship. And they are doing mobile security robots for companies in Singapore. They're doing bellboy robots for 7-star hotels in Singapore, Marina Bay Sands and so on. They're doing warehousing bots. So we are very proud to be associated with him. Right? So good to have you around. And he gives very, very good talks, very inspiring talks to our students. Right? And so he's a bachelor from PhD, the College of Technology in Coimbatore. Incidentally, that's also the alma mater of the Tata Sons boss, Chandra. Right? So you got very distinguished alumni there. And MSc from BITS Pilani. When did you take that? I didn't know about that. Okay. 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 Anyway, so a few words from him before I hand the mic out to the other jury members. Are we ready to start, by the way? So let them start, and then we'll have the words at the end.
Maybe you can introduce.
So we are the team from KIT Kalinga Institute of Technology at Coimbatore. So with me I have Ajay Balaji from the Department of ECE and Abhinesh of Mechanical Engineering, and myself Gladson from Department of Biomedical Engineering, and other teammate from Department of ECE who couldn't join us today. Myself, Gladson Paul, and Kishore couldn't join us today. We have Ajay Balaji with us.
220. Last one.
Yeah.
This will be a official.
We need to start the timer. No, that thing. Start. Sending values. Timer stop. The bot is supposed to move.
This time more final. This time more final. Normally we see first year, second year also. This time we see more final. One feedback is don't waste your 30 minutes or make 30 minutes. I know so and so things. Will you take me or not? That is how the interviews are being done. Literally, things are now, it's other way around. So we are not taking interviews. They are taking. They are testing. They are taking. Trying our patience to the core. If you, actually, literally, the whole day was upset after this interview. I personally felt very bad on myself.
They have picked up the box. Easily, like they are waiting for the bot to come.
Is the script working? You want to opt for a rerun?
Yes.
Okay, timer stop. They are opting for a rerun. We'll reset it. Yeah. Can reset it. while we set up, maybe the team will be explaining the algorithm of their flow. So yeah. You want to- What is the idea?
Hello, sir. Hello. Good afternoon, everyone. Like, we are team from KIT, and then, like, I don't know why the e-bot is not moving now, but we made an algorithm for servoing. Like, first of all, we used in the stage 1, we used. No, sir. They're just setting it up. Like initially we used X goalpost, which will be using IK and FK, that is like manipulating the arm. But in the later stages, they instructed us to use the servoing method, which is we'll be publishing the joint velocities and twist velocities. Like we created an algorithm. First, the arm will pick the box and wait for the e-bot to call the service. So, like we created an X servoing as a service.
Yeah, so basically the manipulator will be collecting a box and wait for the e-bot to go to the docking post. When the bot reaches the docking post, the arm will be placing the box over the e-bot. And if the box is even number, it will go to odd conveyor. Let's say if it is odd box, it will goes to even conveyor, which is 1, 2. So when the odd box reaches to the e-bot, it will goes to the even conveyor and deed of the boxes to the conveyor. So let's see how our robot will be functioning right now.
No, sir, we didn't complete it fully.
One second. Okay, just wait. Please stop. Yeah, stop.
Talk to you. I'll come there.
Siddharth, it might start. It might start now.
Yeah. I think I probably need to go back because I was kind of like a huge situation. It's rubbing very badly on my junction. I need some shoes and socks. So the next thing is beginning at the place at 2:30. Right. 2:30 to 1:4. And then the one that I wanted you to be there is the FPJ one. Is at 4:30. So anybody can just come back to that when you are. So you have about a couple of hours, 2.5 hours to rent there. Okay. I'll perhaps do that. Yeah. So one of these team members will accompany me. I'll back to you. Fine. Yeah, I'll come.
Waiting for server. Just the arm part. Still waiting for this. Timer start. FPC. E-bot.
Can you do one thing? Given as it is the remote is not
We should end it. Do you call it end of the run? Okay, we can call it end of the run. End of the run. You can stop the timer. You want to try? Now, give the answer.
gold and dry. The problem is the ultrasonic and data scale is going nicely to so even if these guys are facing latency, the system
Okay, maybe you can go for the jury interaction and then we can have a rerun later.
you won't be taking the previous test and anything.
Yeah, that's what. We will decide on that and we'll play that.
Stop the script.
Good afternoon, everyone.
Yeah, so what failed?
Like the ARM script is working perfectly fine, but I don't know why the...
Drop it. Could have at least shown us drop it, no?
No. Once the eBot goes over there, then only it will stop. It will drop in the eBot. With the Aruka marker placed in the eBot, it will identify the coordinates, and according to that, I will manipulate it and I will drop the box above the eBot. Once, if the eBot is over there, then only it will call the service. I'm just created a Xserver as a service, which I created a client in that script, which will call the service, and then only it will drop the box in the eBot.
Suppose they navigate the robot and keep it there.
Then when I call the service, it will drop.
Can you demo that at least?
Yes, I can do that.
Because we're not able to evaluate you without any. Is that allowed, guys? If you can move the bot there.
So, what we will do is we will play the video. We have a backup.
No. Like, we don't have that valid instance.
So, sir, just the service call, if you even call the whole drop. Like service call, you wanted to see that it is whether it is getting dropped in the...
Like, if and only if it gets the data of the bot, then only it will drop.
Is that allowed? I mean, I don't know. What's the competition rules?
We can do that, but it won't be counted as scoring.
But then we can't score anything then, right?
Like, we can ask on what was their algorithm and
It's just a theory, no?
We are arranging the backup track so that we can ask questions.
What is backup track?
So yesterday we had a
Video?
Yeah. So we can see
I have one question
Yes,
on the
sir.
robo.
Yes, sir.
You know, we asked the previous team why theirs was slower, and yours is even more slow than the previous team.
Like when it get nearest to the box, there is two things which we are seeing. One is the pressure. In that end effector, there is a NetWinds topic which will publish the pressure, how much it is putting above the box. Like it should not cross the box.
Going up to the box is
like they restricted some speed limit. Like,
but yours is slower than the previous team.
Okay.
The previous team was slow. Yours is almost 5x slower than theirs.
I can increase the speed. Like,
so I think it's not them limiting the speed. Their speed limits are probably much higher.
Okay.
And your
like they told the maximum speed limit is 1.5 meter per second, and they also reduced our speed by 20%.
1.5
meter per second.
Minute.
Like for the arm, they told that is the maximum speed.
Meters per second.
Yes, that's what it.
1.5 meters per second. That's a rocket.
Okay. Okay. Sorry, my bad. Okay. I think.
So I think calibration somewhere is off totally. That's one part. I mean,
I calibrated correctly. Now it picked at the center. I think so. Okay.
I mean, your estimation of what it is doing.
Okay.
That closed loop is not delivering the results. That's all I can say. I mean, it is moving much slow. I mean, I'm sure that those motors can perform much faster.
Yes.
Okay. Second, are you moving each appendage independently, or you just say move this end point?
Like there are two things which we can do using the servo. One is twist commands and one is join commands. Join commands works like using like turning the each nodes, like each wrist joints and then shoulder pan joints, and like another one is twist commands, which will be giving the taking the end effector's position and and we can manipulate it to go to the position which we need. And then
so which
I'm using
one do
both.
you do?
I'm using both.
You're using both?
Yes.
Why can't those independent, there are 5 joints.
Yes, sir.
Why can't those 5 joints be manipulated concurrently? I see them all moving sequentially one after the other.
Yes, sir. Like.
Did you get my question?
It can't be.
What you are asking is concurrent and all these velocities are moved in sequence. But since the end effector moves that way, it appears to be like that. As a whole, they don't have a control on independent individual joints now. They are setting the final end effector. These are all will be calculated in the movement itself.
Yeah, but no.
Yes,
so,
sir.
but if they, that's the reason why I asked this question. Are they setting the end XYZ? If they're setting the end XYZ,
with the velocity they can set.
With the velocity, then the implementation here, I'm surprised that it is.
They said that they can control individual. They can set, but normally what the service call they have made is the last XYZ points with the velocity. What it has to do.
Like we used both of them, sir. Like
Yeah,
for
yes,
rotating
they use both.
Yes, like for each time, like for rotating the end effector, we used twist commands, and then for rotating the arm towards the box, we used join commands for rotating the shoulder pan joint by 90 degree, and then we are using twist commands to go towards that, and then reducing the Z, and like these everything are different things which will do.
So like there is a plugin to control the motor, but as a whole, easiest method is to give everything to that.
But then that implementation cannot be so inefficient that it is moving one after the other. I mean, in an industrial robo, obviously time is.
Seeing the speed there, and it is nowhere it is imaginable.
I don't even want 1/10 of that speed. Okay, I'm not expecting 1/10 of the speed. I am expecting concurrency. I am expecting all joints to move concurrently. I don't see that concurrency. That's what I am saying.
What are your
Did you understand the point what he's saying? Concurrent movement. Why should you do concurrent? What is the advantage?
Like it won't go to singularity, I think so.
No. So if I am here,
okay,
and if I want to go here, what all moved? My wrist moved, my elbow moved, my upper shoulder moved.
Okay.
Did it go like this? It didn't go like that, no? I just did like this.
Yes, yes, sir.
3 joints moved concurrently. 1, 2, 3. It was a smooth motion.
Yes, sir. We can. We are.
Whereas if I do 1, 2, 3.
No,
That's not what I did.
No. That like we did it to make it robust, but we can directly rotate the. Like we can take the arm towards the box directly, but it won't be robust. Like it will. It may take another. Like we can. Like it may collide. Like sometimes it is.
I can do collision avoidance here also. I mean, I can look at what's happening around.
Okay.
Yeah.
What is the main reason for robo not moving?
Like AMCL, that is not working, sir. Like it is not publishing data.
Maybe. What is your shoes answer for that? Like robot is not moving. Why it has not moved? Exact root cause.
That AMCL is not working, sir. That is the problem.
Why AMCL is not working?
Like we didn't that much worked on that hardware. Like we couldn't do it. No, sir. Like
No, ma. See, hardware data are coming. It is ensured here. AMCL failure. AMCL is like, what is the purpose of AMCL?
Like it's a filter for localization.
Localization. It's say why. What could be the reason for localization failure? Why it has failed? There can be so n number of reasons. Whether your ODM is not publishing, or your script itself you are not running, or some XYZ reasons. Maybe what things comes to me is like ODM would have not published in a proper way, or the map data would have not been in a date where you can able to localize or something like that. So what is your exact root cause failing? Because failing is not a problem.
Okay.
See, failing, we are tend to fail. Okay, that is part and parcel. I personally want you to understand the core fonda, why it has failed. Because that is where you can move forward. Because if you simply restarting the script for 1,000 times, will not help you with the results. That is what you are all doing at the last moment. Restart. At any one restart, it is like boarding the bus and going. So you should know where to stop and where to board, right? So you cannot, like, I want you to understand from your perspective what went wrong exactly. You are getting my context, right? What
Yes, I can. Like
AMCL not working is a meta reason.
Okay.
There could be thousands of reasons for why it is not working. I want you to personally understand from your shoes to explain me why it has failed.
Okay, like we can get the ODM data and IMU data, that is working fine. Then
ODM and IMU data are coming means sensor wise data are given. Later data are coming. Scan data is coming. I am seeing scan data in Arvis. That means scan data is also visible. So that means all 3 data are coming in. Then what is the problem with your AMCL? See, AMCL is like, assume that I understand that you would have not gone through the algorithm, or you do not know what is the logic behind AMCL. I wanted that you think that is a black box, you give some inputs, you get some outputs. So you give some ODM data and other parameter data into this black box, you get a final output saying that this is the map file and your robot is in that point. So that means literally ODM with respect to map, you will be getting it as an output. Am I right?
Okay, sir.
So what went wrong? You are cross-checking all these input data are correct.
Yes, sir.
Why the final data was not coming?
Don't know, sir.
Okay. What was your roles? Like, what were your contributions between your teams?
Like I worked on every 3 things, like computer vision and then ARM and then navigation. Like and then he worked on.
So I'm basically from mechanical engineering department. So coding is new to me. I'm basically deep interested in design. So this was my first time to go depth into ROS, and I assisted him using eBot algorithm thing, how to navigate using nav2. The first thing is it is a really challenging thing because it was very interesting as well, because mapping the arena and moving the bot like gaming thing was really motivated me, so that I involved in eBot programming, the algorithm thing, how we can move the bot to the destination post as well as docking post, all these things, sir.
What is your role?
So as he said, myself I'm new to the Aurover stuff. So I tried to work with both, and I was more in helping with the logistics, with the documentation in the college and all those stuff.
Have you ever completed one full trial runs? No.
Like I went to 3 courses in the task,
Okay.
task 4, but like I navigated to 2 conveyors and went to receiving post. I didn't go to the 3rd conveyor. That is.
Okay, that means at least the core fund of the task you have completed.
Ah, yes, sir.
So why from there to now, what's the problem?
Like the problem is not from the script. Yesterday also I worked on that, but it was working fine. Now it is not working. I don't know.
See, only one thing, as a basic engineer guidelines, always we work only for positive test cases.
Okay.
We never work for negative test cases because we are made to think in a positive way, not in a negative direction. So as a good programmer or good context setter, please ensure that you set the negative test cases, fail for the worst case. Plan for the worst.
Okay, sir.
So that mentality we can see. We are winding up with this, or we are going for next session? How it is? Like we are having a next team, or we are?
Yeah, we are having next team.
So they can set up. No, until then you can. Until then you are there for grilling. So you can.
No, but that's good.
Okay, okay.
You can wind up.
So please try to understand, and maybe we will be around for next 1 or 2 days. Like we will be there. Like, try to understand and come forward. See, I understand. If that is the error, means what is the error? What you was expecting, what did not well. It could be there are multiple systems involved. I'm not saying everything is robust here. Everything everything is made in a very fragile way. I understand. So, which is what is making you failure? So exactly we wanted you to understand where is that fragile part is. So either it's your part or the team part or which, because simply error not able to run is a meta word.
Okay, sir.
So we cannot take meta as your answers. If you see, even it correlate with your life, if you take something in a meta way, you will not understand or pass through that problem. You have to drill, at least dig deeper. At least you should have your logs enabled, stating that I've sent a data, at least last team said, I've sent a request, they did not give me back.
Okay.
So for that the response would be like, you should wait for a timeout. If not, you have to retrieve back again. You cannot say, I have called one time, it is not coming back to me. So that is what the meant for action client and servers. So all these infrastructures are well implemented in ROS. See, one good thing or comfortability is like, everything is established and everything you have it in an API format. Everything is like, only thing is the way you put in effort. Whereas if you start from scratch or the 10 years down the line back, say it is in 2015 or sometime like that, building this robot was a very, very nightmare. Now everything is given on your plate. It is up to you to fix. It's like you have reached some 90-95% and then the rest 5% is based on the extra effort what you put. So basically everything is established. So thing is, you have to think it little logically. Putting a blame or putting something on other side is easy, but understanding the vertical, like try to understand. It's not like I'm not forcing you or something, like make it.
Okay, sir.
Thanks. All the best. Thank you. Thank you.
Yeah, since we are running a bit short on time, what we'll do is we'll play their final submission video, which was their task 6. So based on the video, you can take the Viva, and later after lunch, we will do the scoring with their runs and everything, so that we can wind up on time. They don't need to be there. We'll do the scoring according to the run and we'll complete it. This was in task 6.
Yesterday, yeah. So basically, yesterday they had to do an official run as a backup. In case anything fatal happens with the hardware, we took a backup run yesterday. So these videos are of the backup runs from yesterday.
Now then, are we giving equal opportunity to others to show their video?
Yes.
Sir, so the 2 teams who have completed, we'll take that for scoring. This video, we are not taking it for scoring. It's only for you to see and take the Viva. Scoring we will
They are saying that they will complete the scoring
later. After this, we will take their runs like the other two teams.
Already biased that something didn't work. Right? Unless you're willing to come back.
if we are ready to spend the day.
Understand that. But the thing is, everybody is there in the same thing. Now we are already biased that something didn't work. We don't know whether it didn't work because the system was down or if yesterday everything worked. So then our question should be slightly different. You suggest I don't think it have a class. No, but they are
I am there for the day, sir. I have surrendered myself to Kavi sir for 2 days. It is like yearly 2 days I contribute for Kavi sir.
Maybe if we want to give everyone an equal opportunity, we can ask the other two teams also to show their videos. I think in best interest of time. We will take that, but the thing is, next theme we have it scheduled at 2:30. So by it's in VMCC. So next theme. There are 4 themes today. So.
Actually, yesterday we faced some issue with the arm, so because of that we couldn't be able to operate the arm. But if you consider our past runs, the arm was working perfectly fine.
Today, what is
Yeah, today we haven't tested, like we haven't got the final run.
So even in this video, they are saying the arm has not worked.
Yeah, but the previous runs, in the taxi submission, the arm and the e-bot was working fine.
Is it slow down motion or real time?
It's a real time.
Yeah, it's real time.
Like if you have a look, it just went to the first arm receive pose, and when it reached out, if you see, then we just align or orient with the receive pose of the arm, and after the alignment, there is a sensor, ultrasonic sensor. With the ultrasonic sensor, I aligned with the wall, and after the alignment is complete, like if you see in this video, like the alignment is complete, then I was docking the bot linearly, and after that run, I was like, there was a service client structure where I request the arm to request the box to be kept it on the bot, and the next on, if the request is the sent to the arm, and then
Okay, so basically when the bot reaches the first arm position, so what it does is basically it sends the request to the passing service that I have created. So the passing service, when it gets the request, it takes the Argo transform. Basically, what I've done is I've created a scheduler. So what it takes is it takes the number of Argo transform that are being published. So based on that, it creates a task, like a set of intermediate poses that it has to traverse. Like first it will orient 90-degree anti-clockwise, then it will go on top of the box, then from there it goes to the box position, and then when it pick it up and then just place it on the e-bot, and when it places on the e-bot, it just gives the as a string, it gives the box name which it has picked, and if the box is odd, then it will go to the even conveyor number.
This is the process statement. We know the process statement.
Yeah.
So that's okay. Now we understand. Yeah. Now, why this bot did not go to the center? I have the same question.
Yeah, because sir, if we see, if we take in the consideration of the ultrasonic sensor, like it have the minute errors, like just a 2 centimeter and the 3 centimeter, that error, and I can really reduce that error to just 10 to the 0. Yeah, just a minimum threshold. Like it was around 2 cent. Yeah.
What does the sensor give you? Does it give you distance or you have to compute the distance?
No. It just gives the distance.
Did they give you what is the error estimate?
Like the error estimate was around it to, I have given the error estimate about the 3 centimeter. So, okay.
When the sensor says that the wall is X centimeters from my sensing point, that X centimeter, how much percentage plus minus,
Okay,
how much
okay.
percentage error
Like
will have?
it, 2 centimeter. It will be around plus minus 2-3 centimeters. Okay. Actually, on the e-bot, on the front side and the rear side, there are 2 sensors. Means 2 at the front side and 2 at the rear side. So while at the docking,
Sorry, nothing on the side?
yeah. If we see nothing on there on the other of the side, and actually,
No, sensor may not be on the side, but does it give you distance on all directions?
It gives the distance on the direction. If you see, it has the ladder. Like it gives the distance in the 180 degree. Like if we see, it just get docked, it will give the distance around the 180 degree. It will give the distance whole area about. It will cover up area about the 180 degree, and it will be giving us the real time distance with
So
the ladder.
it gives
sensor.
you on that plane,
yeah,
all the distances from 0 to 180.
Yeah, 0 to 180.
So which means the sensor on the front.
Yeah.
Can you show me where the sensor is?
Yeah, like this. Like this one, sir. This one is the LiDAR sensor.
Okay.
Yeah.
So that gives you all 180 degrees.
Yeah, it is on the front side, so
Okay,
that's
so-
why it's give the distance around the 180.
So which means you know what is left, what is front, and what is
left,
right.
Yeah.
So now tell me why it didn't align.
Actually, sir, when I totally figure out when I was working in the hardware, like it was we have the Revon slot, and we really have the time consideration. Like we have the time limits. We were given only 1 hour slot, and these were like 10 to 12 slots, and we have to test the both, like both the e-bot also and the arm also. So while the consideration of the time and tune the parameters, like it was really hard to tune that, and also as it is a hardware, so it will be definitely having some errors. And
The thing is, when you started going from here to there,
Yeah.
already it went straight.
yeah,
So how did it compute how much I should back up and then turn and go?
yeah, it was about the
It didn't go and correct itself.
Hmm.
Right? It went there and it didn't correct itself.
yeah,
What
it
was
don't
the
correct itself because, sir, if you see, it has the IMU, like BNO, it gives the orientation with the fixed axis. Like it tells about that from the starting point, the bot is initially facing at 90 degree, 180 degree. So my algorithm was that like it just came to the pre-docking pose. When it pre-docking pose, I have given that this should be a bot orientation, and like we see in the video, it just got orient. And after that orientation, like I have used the ultrasonic sensors and get their feed and try to align the ultrasonic sensor and take their error, and just by taking their error, I just change the orientation of the bot regard to that, and I just kept that offset I just told you before. And after that, the like the error is accumulated, and like it's fine that it have been orientated. After the orientation, I am just giving the linear dock. At that time, I can change the like orientation, but it will be giving this issue, like it will be just tilting, and it will be not correcting down. So it will just giving the fluctuation, like that will be the behavior. Yeah.
No, so I mean, you know, it's just the same question that I had, that why was it close to one wall, and I still don't get it. You came here, the bot came here under your command, and then it turned, and after that it never recorrected and moved away to the center. It just went along where it had oriented once. And once it oriented, it went straight confidently.
Yeah, that was my algorithm that like I have planned it.
So then,
the initial delta that you came was sensitive.
Huh.
So that could have been pre-programmed. You know the map of the room.
Yeah,
You
like
don't need a
no, sir.
You know the path.
Yeah.
Once you reach this distance, you say calculate. So you know the path and distances, right?
Yeah.
Now once you come here, so I'm not saying that's wrong. So you could have come here, and the distance delta that you moved here and rotated, that you could have aligned so that it comes, the center of mass is center of this line.
Yeah.
But so I'm saying without
using your ultrasound sensor, you could have done it and gone. You could have used ultrasound just for stopping.
Yeah.
I think it stopped nicely.
Yeah.
We didn't collide, which is okay, which is good.
Yeah.
But so the initial orientation is not based on any sensor. Am I right?
No.
So
It's
then why did
totally
you
on
say
the-
that?
Yes.
No, hold on. Your claim was that the sensor was giving you errors and that's why it went one side. So it's not the sensor error. It's your predetermined path which was in error. Am I correct?
Yeah. Actually, he was
So
saying
explain the algorithm what happened. So when it came here, what was the logic that you used?
Sir, actually, when it came here, in the nav2 planner, like it plans the path, and in that part, I have given the threshold, like in this X threshold and Y threshold, that it should be around 3 centimeter or 2 centimeter. That should be a threshold, because it can't be just like that accurate. Like it should be perfect at the, like the error should be around the 0, 0. Ekdam, it should. Like I said that if we are working on the real-time bot, then there should be a minute error. So that minute error was about the 2 and 3 centimeter. And just you said, like, why didn't I can't align if I have the pre-map? So that was the point, because like
you didn't answer the question.
Yeah, because
So it was not because of sensor.
No, it was not because of the sensor. Like
So
in
you
the
had a-
controller, like in the controller planner, I have given the threshold in the X and Y distance about the 2 to 3 centimeter. That's why it has that error.
It's not 2 centimeters. It's much
Another
more than
issue
that.
we were facing was that the odom was shifting. That was another issue, that the odom was shifting.
What does that mean? What does that mean?
The odometry, that's the transform that publishes, the ROS2 publishes, the odometry transforms. So that was shifting. So that like there was some errors because of that. So
we
because
can't-
of that, it doesn't go to the exact location where it's supposed to be. Other way around, we can do that. We can just we can just put it here. We can just plan a path till here, and then we can use an ultrasonic sensor to align with this wall and with a threshold, and then we can just rotate it, and then we can align it with the center line, and then we can just go there and pick up the box.
I mean, we have seen the other robo which moved. It came right to the center. Its problem was different. It centered properly.
Yeah.
It positioned itself correct. Same.
Yeah, I saw their run, but I think they have used the ultrasonic sensor to like reach the minimum distance over here and then rotate.
What
and then
was your what was your yaw tolerance and XYZ tolerance at this point? That is the question sir was trying to ask. So
I
you are
think sir was only saying.
no sir. There is a parameter for every goal position. You can set a point how much tolerant it can stand. So yaw tolerance is nothing but the angular tolerance at which it can say. For example, you wanted to stand it at 90 degree. You can give tolerance because the PID controllers and the mechanical constraint, it will not allow you to stop at that precise. So there will be some tolerance you can give. What it can do is either it will stop or it will fail. The whole controller will get failed. So they have to put some recovery for that. So what was your tolerance? If they kept, say for example, if they kept 4 degree, 5 degree tolerance, over the span, the distance got increased.
No. It was perfect 90 degrees. The angular orientation was perfect.
So only
But
the
then
delta, initial delta
XYZ position offset within this alley was wrong.
No sir, once this...
So what basically happened, it rotated. We had some kind of tolerances, but after that, we forgot to align it with the baffle there.
You just watch.
My understanding is wrong.
Yeah, let's see. So it's doing all this adjustment?
Yeah, it's all.
Yeah, only it is. At this point it is finished.
Yeah,
Now,
at this time
wait. Now it corrected itself.
Yeah.
See the distance, it is going straight. See this left side distance, see the right side distance.
Correct sir.
Yeah,
The problem is when there is two parameters to have a tolerance limit. There is a parameter called XY tolerance and there is a parameter called yaw tolerance. So if the parameter of XY tolerance is bit huge, say example you wanted to stand at this point, you can give a tolerance like 10 centimeter or 5 centimeter. This will count a radius of 5 centimeter and within that 5 centimeter, if the robot's center points get aligned, it will get stopped. So that is like, these are all the parameters, like a trade-off parameters, they have to tune it based on the acceleration, velocity, position feedback, all these PIDs they have to ensure.
So
that is their task. These are all available ready-made.
So, by the way, I can tell you what the issue is. When it reached there, when it aligned with the center line, and then it used the ultrasonic sensor to align with that baffle, but when it went to that baffle, it didn't continuously align with the baffle. So, maybe there was some kind of error.
See, aligning it with ultrasonic sensor is first of all, it will not work.
Yeah, but we were not doing it parallelly.
It will not work.
As
it
we
has
were
to be,
traversing this.
you have to align it front. Say when you are starting a linear movement, say you are blindly going to move. Say from here to there, it is a blind movement. You are going to give forward velocity, the equal RPM in both the motors. That is the only thing you are going to give. So that means you have to 100% ensure that you are in a straight alignment. So that alignment check you have done with the tolerance of the nav2. So now you have to do with some more additional extra features. I understand nav2 tolerance will have some tolerances will be there. That how you will get offset. So for that only we have ultrasonic sensors. For that only we have ARCO markers or so many things are available.
Yeah, like for that, as you said, we can have the multiple correction. Like with the LiDAR, if we have the pre-pose, and with the pre-pose we know that the from the wall it should be at the bot should be at this much distance, like this much distance, like this minimum distance. And with the as I said, with the LiDAR and with the multiple sensor fusion, like we can have that much accurate position and that much accurate location of the bot, and with that we can
So basically, while we are moving linearly, we can try to correct it using the ultrasonic sensors while we are moving linearly. So that way it won't like collide with the side boards.
They went 2-3 steps again.
I think we have to close here.
So you're which college?
From
Vishwakarma,
VIIT, Pune, Vishwakarma Institute of Technology.
Is there another team now? Yeah, one more team. We'll do one more team and close. So, while we are scoring you, we are passing time, so stop anyone, stop us anytime. Question was when you, done. You answered it perfectly. Well done. 80 kg,
There was some issue with the arm yesterday, so we couldn't have a backup. But before that, we was working perfectly fine. So, like, if you have any questions regarding arms, I can answer it.
Like in simulation, it works so perfectly fine that like.
Yours didn't go. Line of investigation was Centurion.
See, I think the e-Yantra team has to take a fair share of our shall I say complaint that
So you didn't
the team
encounter
has
any of
not
these problems in simulation?
prepared them
Like nowhere, sir, because the
make
issue
sure
which
that
we faced
all
in the
these
simulation were
challenges
not kind of like this, because the ultrasonic sensor readings that were
But then you didn't get this problem.
Just go. Just go.
that in this particular project, most likely a lot of failures are happening because there is code implemented by the e-Yantra team on one side and there is code that these guys are implementing, and both have to talk to each other and get the job done right. And there are lots of failures happening on both sides.
Yes, sir. So good afternoon. Shall we start?
Yeah.
Yeah.
You're from?
So my name.
First one, right?
2742.
Yeah.
2742.
Yes, sir. Yeah.
So you go in the bot first, is it?
Like the back that day, we were not focusing on moving the bot first. Actually, the main motive is to move the arm first, because the bot takes a.
Yeah, that's okay.
less
Moving the bot first. So you mean the arm first?
We are moving the arm first. I mean, both are running simultaneously, sir. It's not a problem.
Is the bot going to come or?
Yeah, it's will come. I told you, right? According to, we are considering the time factor, right, for the competition. So I'm starting the bot a bit late because the arm is slow.
It's very slow.
I will tell you the reason for that.
Well, this one is at least concurrent. Left skew. No, so then they have to be coached to reduce the tolerance.
That is their work. So with that tolerance is running, and from here it is like a blind robot. It does not check for
I fully agree with all this. The crux of the problem is the initial XY offset is wrong. And that's what both of us are trying to ask about. As to why is that XY offset wrong?
the exact answer to this, the tolerance from now to.
That didn't come out.
Not just tolerance, no, even the XY value itself probably.
No, it's tolerance because there is an API call. These guys all operate on API calls. No low-level details. So that API call says go to this XY offset with so much degree of freedom.
Freedom tolerance.
So much tolerance on both directions. Then the other side implements and says, I have reached there. Now what do you want me to do?
But my suspicion is, this is not tolerance, different runs will not give different behaviors. Systematically are going left. No, that's what it's a problem of calculation.
No, it is going left because that's where it came from. As soon as I am within the zone of...
Every run that happens, then it's a systemic error, not a...
But it is always to the left. It is always to the left.
Yeah.
And it is to the left because as it's approaching from there, I came within the zone of...
what we are talking about?
Should I stop it?
Yeah. It's delivered, right?
Yeah, delivered. We'll come back to the receipt.
It has to come to
No, it has to come to the receipt post.
It has to come to the...
Yeah.
Okay, play it.
You can start explaining.
Okay, so the first thing we are doing is calculate the position of the Ruka marker.
No. This point that we are discussing now is
Okay.
why is it not aligning to the center?
Okay, I will tell you. The thing is that, the first thing is that we are not with map.
How many deliveries you have?
2 deliveries it has to do.
Oh,
3.
Let's wait. So you did all 3 deliveries yesterday?
No sir, there was only one delivery and then another one gets stuck on the conveyor too.
No, it's systemic error, I can see, because there is not enough gap. You know,
But it is...
I could have fixed it.
Why?
No, the thing is, I am using LiDAR to fix the data, to make it more closer, right? But the thing is that, when we ran, it was working all fine for a lot of days. The thing is that I just reduced the LiDAR, increased the LiDAR a little bit, because the LiDAR...
This wall?
Yeah, for this wall.
This wall?
Actually, it's for all the walls, sir.
I know, but you said you would have corrected, what you would have corrected?
Yeah, I would have reduced the distance value of with the LiDAR from the wall. That way it's fixed, and I'm aligning it with respect to the LiDAR also. So that's why it's always perfect 1.57.
Or you could have made it move not straight line, but little scout. That is what we do when driving. Keep the distance. Who says you have to follow straight lines? Dynamic path planners.
The thing is that
What is it trying to do there?
this is where, sir, the goal tolerance, the goal value, the goal tolerance of the XY goal tolerance basically, that went too high. Okay.
So why didn't you come back all the way and move? Why didn't you do that? This is a predetermined path. No, there's nothing dynamic about it. You know this path. You have so much space here. You could have reversed all the way here and gone forward.
Reverse all the could have done that, but then
What was the last error? Can you play it last?
It was not able to rotate.
It was not able to rotate and go into the alley.
The problem was this time. I will tell you everything.
See, it could not go in.
The question is, are you given this? You know the map, right?
Yeah.
So this path, there is nothing dynamically calculated.
Sir, as per the logic, they are calculated dynamically.
Do they calculate dynamically or
It's dynamic. It's dynamic.
Why is it not predetermined?
Sir, if you will do it predetermined, then it will be like just coming there. It will be hard coding, sir.
Predetermined is a path. Like I want to go from here to that building. I know this. Of course, there's some roadblock. I will take this and but I know that I need to go roughly there.
Yeah.
Right. So in this case, you could have come probably somewhere. This predetermined is a what do you call the dominant path.
Okay.
So dominant path should not be aiming to go there.
You are telling that I should have come from there to here.
Not
Something
here,
I'm
maybe
saying,
somewhere there.
where you
Somewhere
have
over there.
Yeah.
Where you
But
have
then
sufficient
I
place.
have to, eventually I have to go there only, sir, to drop the box.
I know, but you don't have time, place to rotate there, no?
You came out
I
very
could have done that. I will
little.
tell you why I am doing that basically. Now, there's a thing why I am doing that. So as I told you, everything, OpenSea, everything is working. We have worked a lot on that task 1B, like basically detection of the Aruka markers. It works every time very fine. And talking about the arm, right, there's a feedback thing also in that. So what it is doing actually is, it will go and pick the box, right? So we are using two things in that. First thing is net range. That is basically the pressure sensor that is used to detect how much pressure is on the box. But that sometimes doesn't work fine. So we are using force status also. So force status is something that calculates the singularity level, right? So what is that? Like if the motor of that arm is not able to move any further, okay, the force status value increases. So that's how we are stopping. Those two factors stops the arm from moving any further, like pushing the box downwards, right?
There is no vertical distance sensor there, is it?
No, vertical distance sensor is not there. No, distance sensor is not there, sir.
From the camera, you don't know how much distance you should
I
put
know,
the
sir,
arm.
but the thing is that is not very accurate. Okay? The thing is that I know where it should go, but if it won't push that, no, right, a little bit more.
I don't know. So once you get dominant to this, and then you can do small. Why do you go slowly like that? You can just come like that. and then
There is a problem with that, sir. If we go fast, no, the net range value won't increase nicely. There will be a sudden increase in that, and it will push for a lot.
No. I didn't mean that. See, if your camera can give you the distance.
Yeah, it can.
If the camera can give you the distance, you just need to go within a tolerance and don't stop there.
Yeah, we did that actually, sir, initially. What the problem was, no, it was going nicely. We were not using any net range, nothing like a force status, just going down. But for some reason, again, the arm was going into tolerance, singularity. There was too much pressure on the box.
No, but you stop it.
No, we were stopping it.
And then how can singularity come? There are two different commands.
Just
One is
that
that
there is
reach that point.
Okay.
That's done. After that, you do the sensing. Why shouldn't
There is
singularity
error,
come?
sir. Like there is always an error in the TS a little bit over here and there. It goes, although we are using depth values.
Okay, let's say error says 2 centimeters. You stop 3 centimeters above. All I'm saying is you don't need to do, you just do like that and maybe stop at 3 centimeters, maybe it doesn't work, stop at 4 centimeters.
Within that only it goes to singularity, sir. It's
Yeah, okay, fine. Yeah, no, that's good. So,
shall I tell you about the e-bot now?
the path,
Yeah, how it's going closer and all
so
that.
why didn't you turn it there?
Yeah. The thing is that I'm using LiDAR to maintain the angle as well as the distance, right? So it goes over there. It uses that thing to maintain the angle, be perfectly perpendicular to the wall, right? And maintain the distance also. I could have make it more closer. It's just that I was not doing it. Anyways, but after that I will rotate 1.57. That will be perfect rotation every time, no matter how many times I come over there. Okay? Because it doesn't matter how much error is accumulating and all that. Now when I was going...
Very, very broad question. See, you know navigating labyrinth?
Navigating?
Labyrinth.
A maze.
Yeah, a maze, okay.
You know that, no?
Yeah.
If you are navigating like this, you don't know where you are going to go. Right? You have to always go and figure out. But if you have a top view, you know where to go.
Yeah, right.
Correct?
Right.
It seems that you are not using the top view at all. You are using only the lower view.
Sir, we can't use the top view because there will be a camera on top.
You have been given the.
You have been given the map, no, of this entire
They've
thing.
been given the map or
Yes, they have been.
They have.
Sir, they will be, they will not have the top view.
No, not top
They don't
view.
need
What
the
I'm
top
saying-
view. They know where they are starting from, and they have the full map. They have the XY coordinate starting point. They know the destination XY coordinate where they have to come, right? So they don't need
So
the
these are
camera, no?
predetermined things,
These
right?
are predetermined, no?
Is
There
that
is
been
input.
given? I don't
There is an
know.
input configuration,
They
right?
have the map. They have the map and they know the coordinates. They know the absolute coordinates. Of course, they know because they can. So then why not use it?
Sir, actually the nav2 thing, no, that works dynamically. So there is always a tolerance a bit on that. Okay. So when it goes there, it's not able to go exactly at that point. Okay. That is the reason why that is happening.
Do you have a map of your absolute coordinates? You do have.
We have the map, yeah.
You know the absolute coordinates.
Yeah.
So all I'm trying to say is you have an absolute path, predetermined path. So there's a known job, na? Like think a person is doing it. The person is interesting in this class. I don't know.
It's not.
No. Just suggestion. You did a very good job. It's interesting, so I'm asking. So, how will a person do it? He's not going to sense like, should I go there? No. I'm not going to do that. No, I have a top view of this. Okay, I know I walk 5 steps. Okay, and suddenly something comes in the path, I will stop. That has to be your fundamental logic, is what I'm trying to say. I don't know whether it's possible to implement. So you determine the speed determined path, that will be very quick. From there to here I come, somebody comes and puts here this one here, then okay, I stop slightly different and make corrections.
Okay.
So if you're going to use only local path, then you are not even using this map. That's what my...
No, sir, they are using with the maps, they are, whatever your approach and what they are doing is almost 95% similar.
I don't think so.
It's the same, sir. It is the same. That is how the nav2 planner operates.
Okay.
So it is with the map, every 15 seconds, that means close to per second, 15 times, it will try to align it with the map.
No, with the map, but my question is, why did they stop there and not come here all the way to turn?
That is, we wanted, that is our approach, sir. That is our approach, sir. We wanted to just stop there, because if it come all the way there, no.
When the robo picked up.
Yeah. We are using controller for that, sir. I mean, if you want to hardcode, I can.
He has gone there, sir. So that can be a
This
point.
is not hardcoding. What I'm saying is the map is a solution. Why don't we come back in the afternoon? No, I don't.
Muthu, he is asking after picking up the package.
The thing is that there is one more controller, rotation shim controller. We can.
He went in and tried to go in and could not turn. He could have come further out, gone there, turned and gone in, no? That plan was not correct.
Like the decision, there is
e-Yantra complements the higher education system by bringing in a component of practical exposure through project-based learning. The e-Yantra lab setup initiative helps a college to set up a robotics lab and also trains the teachers and the students. Our unique lab in a box speeds up this entire process. e-Yantra provides training and a powerful network rooted in the innovation ecosystem of IIT Bombay to address issues related to training to build startups. The goal is to create a global community of innovators who collaborate to solve real problems in society in partnership.
This XYZ point, they have given a very high error margin within which it must reach. Because there is such a high error margin, it comes within the circle of that error and says, I have reached.
Exactly.
So now, because it has come from there,
No.
Thing is, come from this, it would have hugged the right one.
Yeah, so basically what happened was...
this is the arm started, right?
Yeah, arm has started. Thing is, we have reached the nav2, reached the region where there is under nav2 tolerance, and it started angular docking. But it got stuck over there, and there was some jitter where the velocity that we were passing was very low, that it couldn't change. So we are trying to increase it for every run. The thing is, it started working, like it works for first 2 runs, and then like hardware behaves like hardware. So it again started calibrating differently, and then the last 2 runs that we had was like this.
Whether you are reaching there or it is up to this one?
No, it is up to this one. It's like,
when did you get a successful run?
Like yesterday first few attempts we got the successful run, but the thing is...
so they have no way to test it in a digital twin or something?
Gazebo, we did it in Gazebo, yeah.
There is an environment called Gazebo where the whole map is created and everything can be simulated.
That is stage 1.
Yeah, they did it in stage 1. During the stage 2, they had multiple slots. So they had 1 hour slots for at least 8 1 hour slots to do the complete run. So that time they used to get...
Why if it works in the digital twin, Why is it not working?
Because, and this is so this is something that I have been wanting to talk about throughout this particular session, as well as there in the first theme. This digital twin has to be very faithful to all the errors that happen in real life. If the digital twin does not mimic and induce failure conditions, like for example, the team there said, we made the API call, didn't get a response, and we collapsed. So the digital twin also has to provide all these error situations.
Gazebo lacks with the real physics.
Yeah.
Gazebo lacks with real physics.
So these failures
all
are
the
not
frictional coefficients, like everything you have to model it. Like it is not like impossible. Bringing to the reality with the real physics quotients, everything is a bit harder. Like very few people have done it.
What this means is that we have to also introduce noise.
Sir,
You can call it noise. It's not noise. It's all kinds of real life errors in friction, in movement, in offsets, in distance sensing. So it's not randomized noise. It is controlled error that can happen in a sensor, controlled error that can happen in a motor. These have to be introduced in the digital twin. Otherwise, all these students are succeeding with the digital twin, but when they move to the real one, time is at a premium. They're not able to finish because of all the failures that they run into.
So I acknowledge, in fact, this is a better thing, that I acknowledge this is part of our issue also as teachers, but we'll come to that.
So now, the digital twin you ran, and then how much time they are given with the actual model?
So each of them has approximately about 20 to 25 hours to work with the hardware.
But then there's only one hardware, no? How will
so
They time slot.
They have slots.
We got slots of 1 hour each for the past 2 months, and we were trying to
this lab is
calibrate.
fully internet enabled, and they have a system. Like this, similarly, they can sit from their college. They can upload whatever things to this robot. Everything
is given 1 hour time.
Yeah.
They can book a slot, so that is why they have created a dashboard to reset everything.
Okay, so let me ask you this. From your best digital twin simulation or gazebo simulation to the first, this one, how many changes that you made?
The changes were mostly about changing the nav2 parameters.
The first hour that you ran,
Yeah.
right? You were 25 hours. How many hours did you use in that?
We used all the 25 hours. The thing is, like, we basically got, so we had multiple rounds even in the hardware round. So the last round that we had in task 6, which is where we had our best run, and in that we were able to dock, come back, and then go to the pre-dock question over there and then push the box. So even yesterday, the thing was, we were able to do all the e-bot related things properly right before, like even he would have seen. So we didn't change the script, just that the calibration of hardware keeps changing like as the run goes by. So the last run we couldn't change it, and it was not allowed to do so because we didn't have enough time. So that was the major
The
thing.
thing is, during simulation, we have IMU and everything.
Yeah.
There is some sensor noise and everything.
Yeah.
But the sensor noise is very random in the real world. So what happens is when they are using an IMU, it undergoes double integration. So basically they are integrating the yaw values to get the current angular orientation. And because everything is digital, the errors get accumulated. So over time there will be drift in digital sensors. So there will be a drift in
Real life
scopes and other digital sensors. These sensors, these should be filtered out. And there are other filtration techniques, which that is why we gave them the hardware slot. So they realize that the real world sensors are not as perfect as the simulation sensors. And you need to fine tune your filtering algorithm so that your robots work nicely in every run.
But that is difficult for them because they don't have sufficient time access to the physical variations.
Yes, so
and
there
all
are
that.
two aspects to the robotics
Right?
development.
That's true. Yeah. It's like life.
No, that's... Maybe, Kavi, you should give a project to set up a digital twin that mimics this.
In fact, that's the next step. In fact, that's what we do when we get the interns in summer. We, one problem we used to have in the past is resetting the entire theme. One problem we had in the past was resetting, and everything was done manually. So it was one internship project to make it automated, that it goes and resets. So next step can be to introduce noise in the simulator. So that can be done as a project over summer. Bringing the simulator to the real world by introducing noise in controlled ways, taking your feedback also, right? So we do accept it's not your fault, right? We have a responsibility as teachers also to create an environment where we bring you all to the finishing line, right? So don't take it hard on yourself. It is our responsibility also. We are also learning in the process, right? So anyway, maybe this is a good point to stop, right? Since you have to run first. Any other question? Since you have to run first, maybe you can give us your feedback as to what all this means.
Oh no, those things no later. Yeah, value is done, right? No,
This is important work for us because it's on record.
Until come. Your questions done?
Then maybe
you can leave. Thank you. All right. Good job.
So the guys in the audience are...
Yeah. No, so actually my feedback this time is actually to the e-Yantra team. You know, in this, I mean, I have come here probably now the 5th or 6th time I have come. These guys rely on the infrastructure you provide. And this has been the most complex infrastructure, I think, because they are communicating with something that you provide, and your code has to do all the actual measurement and feed them back to them. So your code also has to be robust. It cannot have, I mean, I saw one case where you said it crashed, right? So their reliance on you, it's like a library provider. Library providers have to be super robust. So every competitor, the bot came and it always hugged the left wall. This is something that you guys should have caught earlier and figured out what advice you should give them to make it center. The last one was where he struggled to get in because he had chosen, his strategy itself was incorrect. So what I'm trying to...
Here they cannot bias with their strategies.
No. So they cannot bias certain things, I understand. But they'll have to say that you have to do your path planning where you have all these options which you can use. So I understand they should not give them spoon feed all the steps. But they have to be cognizant that at a certain level, those guys do not know all the possible variables that they can control and get better. Or they should at least say, see, you're hugging the wall, please correct it.
Sir, I agree with the point, both the points. Was the infrastructure wala thing, yes, that is a major challenge because students are reliant upon us for working with the robots properly, and that's why we are trying to rectify via iterations. And there was one instance where the robot had an issue from our end and we fixed that, and that we will definitely improve. The second point was, so this was our way, which obviously lacked something. So the idea was they have multiple sensors, though the robot is filled with sensors, ultrasonics, and all the feedback from all the sides. So if you look at some teams, the first team that docked...
Thank you. Nice meeting you.
Thank you, sir.
The first team that successfully docked and the 2742, the second last team that came here, we gave the same advice to all the teams that you have all this environment. You should be able to use the environment to your advantage. So that's what the first and the second last team did. They basically made sure that the robot is centered by aligning parallel to this first. And that's the same advice that we gave in simulation as well. So we deliberately provided a more complex environment in simulation where they would have to leverage that mechanism, that use other sensors to align your robot to the center and then dock perpendicularly. So that was the idea, to make them think towards using the sensor that way. Maybe it should have been more intuitive, which made it more obvious to them that, oh, I can also use these other parameters to make it at the center. Yeah, that was the thought process behind it.
Yeah, you don't have to spoon feed every step, but you have to give them enough hints that during the early stages, you have to give them hints that your strategy is mistaken. You have to rethink your strategy. Are you using all these? Ask the questions so that they get indirect hints. Anyway, one other thing that I wanted to say, in that competition first theme there, somebody made a comment that the cameras, after 1 hour of usage, its frames per second drops.
Yes.
I have CCTV camera at my house. I have plain analog sensor, CMOS sensor camera at my house. I don't see frames per second or anything dropping, right? So somewhere, either your implementation of data feed to them or their knowledge of how the data is coming is insufficient, and they then make wrong conclusions as to the corrective action that they have to take.
So that is the exactly learning that I have from this year's experience. That is, the students don't have the sufficient understanding of the problem, so they make the wrong assumptions and try to come up with the wrong solutions. So giving more clarity into the system will definitely help students get better at including it.
Yeah, so when they said there, the camera frames per second is dropping, 3 of us in the jury, all of us looked at each other and said, how can that be?
So that is a issue with this type of cameras as well, because these are very complex depth cameras which have multiple sensors and hardware integrated, and very less aeration and ventilation. So when it is running for a long time at a very high rate, then this kind of issues occur, and the camera heating up.
The temperatures here are very safe temperatures.
Yeah, so that's why we are not facing the same issue with the depth camera here.
But even there the temperature is, the hall is actually, we are not in an industrial warehouse.
Yes.
And these work in industrial warehouses.
Yes.
These Har's point is more into maybe we also, like, when it comes to reply, I can fully with you, because I know day in day out I am traveling like guys like you and I am working with them, so I know what problem you are facing. Maybe Sir is at the veteran level, he understands at the system meta level, whereas we know the ground problems. The thing is, one problem which we could say, we cannot say, similar case, almost similar logistics, we are deploying robots and things. Whatever the problem you face, we'll face in the real time. Like, I cannot say these reasons to a company, then he will say, take your shit, go out. That would be the answer to my robots. So end of the day, what I personally give a small recommendation or thing is like we are working only to the positive test cases. We are not working on to the negative test cases. Most of the cases, we don't have that big knowledge on networking. That we have to admit it. Like all of us, we have to admit on the ground that we know the concepts, we know the logics, we know the algorithm, we are the better person to implement than anyone else. But at the infrastructural level, we are a bit like that testing. Maybe you can take 1 or 2 themes as this intern this time, and then try to dump the network problem, because like this is overall reducing the core agenda of the source of e-Yantra. Because the problem you have defined, you are working for a year, you are bringing 5 people to showcase, then if they are not able to complete the task, it looks, the whole effort what we all put in, maybe since I also always associate to this theme with me always, because we also felt the same with here. So thing is we wanted to set up some rugged infrastructure, or maybe one more thing I personally felt is like little we can reduce the toughness of the competition level, because the level of people what we get previously and now it's also getting degraded. So there, like little reduce the problem toughness and make people to work towards that. Maybe we know we have set one context for this year, maybe over 10, 12 year, 13th year now, like delta increase, now it become a whole different competition in 13 years. So every year we go with this theme, we add some plus delta to it, to add, for us it is like we have done it. So now we have to move to the next step, so we have increased one step, but the participants who are coming, it is like a direct 13th step for them. So like some little onto that, so that people will feel like when we are showcasing to people, all of us, like that time it has to be like more of, they should feel wow, or that wow factor. Hopefully if you see from 10 years to now, the wow factor has gone to little down, maybe because of the toughness of the problem and the quality of the participants coming in. So this is not a new or something. So like maybe we have to give some, after final selection, better you conduct one workshop. One day, so give them what are all the, like I don't want you to give a strategic things, say to go with the fail-proof programming. Say if you do
that through documentation, through mails to them.
But that will not be more like let us handle one session together. So at least like to give a fair thing, to say the robustness in coding. Say we are saying how to code, because that is what we can teach at the front. Maybe to the final people or someone we can conduct 2-day session or 1-day session to say robustness in coding and how to fail safe mechanisms. Say whatever all these things.
Design for failure.
Design for failure. So everything, whatever he has to do, it has to recover and come back. So that recovery and fail-safe things can be added to this. This is my small suggestion that it is like.
I have been saying this, that error handling is 75% of the engineering effort. Success path, 1-day job. Handling all errors, 100 days.
And if something infrastructural fault, intimate them from the first saying that that has to be highlighted. Like with their logs or evidence, they can show that there is a latency. Yes. So like educate them from first, try to create some errors in the early stages, and then whatever the error comes, it has to be well documented. We should know either our side or their side or infrastructure side or.
So this year the finalists that we had, all of us are able to complete, do the runs nicely. They have a good algorithm. The problem is the repeatability. Like you mentioned, the repeatability needs to improve this year, I think.
Actually, one common problem is RAS2 or RAS platform itself operates on a probability. So it will not have the same run every time. Even I face the same problem. That engineer, like the site manager will ask me, your robo went this lane to now. Afternoon it is coming in this lane. Why it is coming this lane? Sir, I cannot define the path very accurately. There is its tolerance. So I agree to that, but I can more correlate the problem what you are facing and myself. But the thing is, this is the probabilistic. Yes. So we have to work with this probability.
Anyway, thanks, Muthu and Raghu. No. This is excellent. So we are also learning. We are also learning because we are playing the role of teachers. And if students are not getting it in the way that we want, then we need to kind of make some adaptations on our part. And I do agree that in order to entertain ourselves, things have been getting more and more challenging every year. But now we need to kind of define levels maybe, right? And respect that. Okay.
Give them more of hardware, introduce thousands of problems.
No. So this is the start of another conversation that we'll have. Raghu, thank you very much. And Muthu, thank you very much. Now we shall break for lunch. Thank you.
With other people of similar interests. We've established over 450 labs across India and are looking forward to establish more such labs across the world. eYantra believes that our future lies in empowering young people to solve problems. eYantra believes that startups are a potent medium to solve real problems in society. And eYantra trains young people in future skills, helps them collaborate globally on our platform, and helps them solve problems to engineer a better tomorrow.
Revolutionary.
eYantra is entrepreneurial.
For me, it's opportunity.
Living your dream life.
Accelerator. Learning by doing. Fix any problem.
Complete exposure. You get
Persistence. It helps me to see things more clearly.
This competition helps to open the minds of students. The college is all they know. Like they don't know what's going on outside the state and all the other new developments that are happening. Coming to this competition not only helps them like learn about all the innovation, but also opens their mind to new way of thinking and that might like change their career path. And the sooner that it is done, the better it is for the student. We came in our 4th year and we were thinking like if we came in our 2nd year, that would be better, because then we would have like 2 more years to like develop ourselves and like fix our career path much more better than we have now.
e-Yantra Innovation Challenge is a competition that trains students in innovation and entrepreneurship. It nurtures young minds to articulate real problems in society and to solve them using technology. It immerses participants in problem domains and helps them articulate problems which then they solve and use the solutions as a basis for startups. It's a platform to showcase solutions to incubators and to build your dream startup. Guidance is by e-Yantra engineers and industry experts. So join us. Registrations begin on the 1st of September every year. So be a part of the e-Yantra revolution. Learn, innovate, build, and transform the world. Welcome to the e-Yantra Robotics Competition, where we learn while we compete. This unique journey is unlike any other competition or traditional higher education system that trains thousands of students each year in robotics and embedded systems through project-based learning. Over 220,000 students have benefited from this experience over the last 13 years. Our theme this year is the 9th goal of the United Nations Sustainable Development Goals: industry, innovation, and infrastructure. Through hardware-based tasks, we explore various engineering skills to solve real-world problems modeled as themes. This competition is open to all college students in India and abroad, regardless of their level of experience. By taking part, you can win cash prizes, a prized internship at IIT Bombay, and most importantly, acquire the skills to engineer a better tomorrow. Registrations are open from August 1st to 25th. So join as a team of 2 to 4 members and embark on a 7-month journey guided by our team of experts. For more details and to register, visit our website at www.portal.e-yantra.org. Don't miss out on the early bird offers. So be a part of the e-Yantra revolution. Learn, innovate, build, and transform the world.
Project being done, they focused on our mental health also, so that we could have a peaceful landing in our project. If I need to start a startup and I need good people, I think I could pitch back to these people like, okay, this is my idea. Would you people like to join me? Today morning itself, I've given my interview. The e-Yantra tag in my resume added much more weightage. I think half an hour of my interview was completely dedicated on what project I did in e-Yantra and stuff related to e-Yantra, because people who are interviewing regard you at a different level. You would be a step higher than your peers who you are competing with in the placement rounds.
The e-Yantra summer internship is like no other internship I've ever seen.
Most internships want to get a project out of you. This is more of an experience. It is just surreal. You get to learn, meet a lot of people. Kaviarya sir is such an interesting person. He's always pushing us to be better.
e-Yantra is like a thali. It provides you a delicious amount of various technical and non-technical stuff. The amount and the level of which you want to consume, the knowledge which you want to imbibe in yourself is completely dependent upon you.
It's invaluable, whatever I've learned here, and can't get it anywhere else. I will always remember this experience. It will always be something that pushed me forward to become better.
Attention, teachers, parents, and school students. Are you ready for a creative and transformational journey? IIT Bombay e-Yantra proudly presents the Inter-School Virtual Museum Competition for grades 6 to 12. This is not just a competition, it's a platform to learn by doing.
Students will master graphical and analytical techniques,
research methodologies, 3D modeling, photogrammetry, and much more.
Competition is completely online, running for 7 weeks with weekly live sessions, engaging quizzes and assignments, dedicated doubt clearing sessions, discussion forums, and one-on-one connect.
Winners will be awarded with special prizes, a prestigious certificate from IIT Bombay's e-Yantra, and the top finalist will get an exclusive opportunity to participate in e-Yantra Symposium at IIT Bombay in April 2025.
All this for just ₹2,000 only. So what are you waiting for? Visit school.e-yantra.org and register for a journey that will inspire creativity, foster critical thinking, and equip your kids with the future-ready skills.
eYantra complements the higher education system by bringing in a component of practical exposure through project-based learning. The eYantra lab setup initiative helps a college to set up a robotics lab and also trains the teachers and the students. Our unique lab in a box speeds up this entire process. eYantra provides training and a powerful network rooted in the innovation ecosystem of IIT Bombay to address issues related to training to build startups. The goal is to create a global community of innovators who collaborate to solve real problems in society in partnership with other people of similar interests. We've established over 450 labs across India and are looking forward to establish more such labs across the world. eYantra believes that our future lies in empowering young people to solve problems. eYantra believes that startups are a potent medium to solve real problems in society, and eYantra trains young people in future skills, helps them collaborate globally on our platform, and helps them solve problems to engineer a better tomorrow.
Revolutionary. eYantra is entrepreneurial.
For me, it's opportunity.
Living your dream life.
Accelerator.
Learning by doing. Fix any problem.
Complete exposure. You get persistence.
It helps me to see things more clearly.
This competition helps to open the minds of students. The college is all they know. Like they don't know what's going on outside the state and all the other new developments that are happening. Coming to this competition not only helps them like learn about all the innovation, but also opens their mind to new way of thinking, and that might like change their career path. And the sooner that it is done, the better it is for the student. We came in our 4th year and we were thinking like if we came in our 2nd year, that would be better, because then we would have like 2 more years to like develop ourselves and like fix our career path much more better than we have now.
eYantra Innovation Challenge is a competition that trains students in innovation and entrepreneurship. It nurtures young minds to articulate real problems in society and to solve them using technology. It immerses participants in problem domains and helps them articulate problems which then they solve and use the solutions as a basis for startups. It's a platform to showcase solutions to incubators and to build your dream startup. Guidance is by eYantra engineers and industry experts. So join us. Registrations begin on the 1st of September every year. So be a part of the eYantra revolution. Learn, innovate, build, and transform the world. Welcome to the eYantra Robotics Competition, where we learn while we compete. This unique journey is unlike any other competition or traditional higher education system that trains thousands of students each year in robotics and embedded systems through project-based learning. Over 220,000 students have benefited from this experience over the last 13 years. Our theme this year is the 9th goal of the United Nations Sustainable Development Goals: industry, innovation, and infrastructure. Through hardware-based tasks, we explore various engineering skills to solve real-world problems modeled as themes. This competition is open to all college students in India and abroad, regardless of their level of experience. By taking part, you can win cash prizes, a prized internship at IIT Bombay, and most importantly, acquire the skills to engineer a better tomorrow. Registrations are open from August 1st to 25th. So join as a team of 2 to 4 members and embark on a 7-month journey guided by our team of experts. For more details and to register, visit our website at www.portal.e-Yantra.org. Don't miss out on the early bird offers. So be a part of the e-Yantra revolution. Learn, innovate, build, and transform the world.
We are trying to emulate the story of the thirsty crow. So this is the crow with an arm mechanism, which is a rack and pinion attached to a servo. That is an Aruko marker, which is signifying a pebble. And that is the Aruko marker, which is signifying the pitcher. The camera reads all the points in the arena, and then we apply several filters in order to filter out only the node points which are required for our application. After we detect the vertex points, we calculate the shortest path from the bot Aruko to the pebble Aruko. The bot will follow left or right turns based on where its next path point is, and upon reaching the destination pose, it will servo forward and pick up the pebble and deliver it to the pitcher location.
We are presenting our bot Spotter Snake. The spot we have completely designed it from the scratch.
This is the vertical joint, so it is responsible for left and right motion. This is the horizontal joint, so it is used for linear undulation motion.
This is the linear undulation movement. As you can see, the front, the horizontal joints are moving it. Now this is the side undulation towards the left side. The vertical joints are moving.
I am working on the project Mesh Solver. The bot first takes some time to calibrate all the sensor to adapt the environment. After pressing the button, the bot will start following an algorithm in which it will first give priority to the right one, and then it moves straight, then it gives priority to the left order, and eventually at the dead end it will get back. The bot have calculated all the shortest path available in that path. It will eliminate all the dead end and simply it take the shortest path that was available from the starting point to the end point to reach in the minimum time with minimum path available from the start to end.
e-Yantra made me realize that consistency is the key. I've always thought that engineering is nothing but books and grades, but e-Yantra made me realize that it's solving real life problems and making an impact in the society. If a problem was there in front of me, I would know how to solve it. I would search for the solutions. But e-Yantra made me realize how to first find out what is the problem. So my problem solving skills have improved greatly. We are from different backgrounds. We came here with different views, with different technological expertise, and we learned how to exchange knowledge, information. The first question every day morning, whenever our mentor came and interacted with us, was more like, what did you eat? How was your day? Is everything fine? Rather than only focusing on our project being done, they focused on our mental health also, so that we could have a peaceful landing in our project. If I need to start a startup and I need good people, I think I could pitch back to these people like, okay, this is my idea. Would you people like to join me? Today morning itself, I've given my interview. The e-Yantra tag in my resume added much more weightage. I think half an hour of my interview was completely dedicated on what project I did in e-Yantra and stuff related to e-Yantra. Because people who are interviewing regard you at a different level. You would be a step higher than your peers who you are competing with in the placement rounds.
The eYantra summer internship is like no other internship I've ever seen.
Most internships want to get a project out of you. This is more of an experience. It is just surreal. You get to learn, meet a lot of people. Kaviarya sir is such an interesting person. He's always pushing us to be better.
eYantra is like a thali. It provides you a delicious amount of various technical and non-technical stuff. The amount and the level of which you want to consume, the knowledge which you want to imbibe in yourself is completely dependent upon you.
It's invaluable, whatever I've learned here, and can't get it anywhere else. I will always remember this experience. It will always be something that pushed me forward to become better.
Attention, teachers, parents, and school students. Are you ready for a creative and transformational journey? IIT Bombay eYantra proudly presents the Inter-School Virtual Museum Competition for grades 6 to 12. This is not just a competition, it's a platform to learn by doing.
Students will master graphical and analytical techniques, research methodologies, 3D modeling, photogrammetry, and much more.
Competition is completely online, running for 7 weeks with weekly live sessions, engaging quizzes and assignments, dedicated doubt clearing sessions, discussion forums, and one-on-one connect.
Winners will be awarded with special prizes, a prestigious certificate from IIT Bombay's eYantra, and the top finalist will get an exclusive opportunity to participate in eYantra Symposium at IIT Bombay in April 2025.
All this for just ₹2,000 only. So what are you waiting for? Visit school.e-yantra.org and register for a journey that will inspire creativity, foster critical thinking, and equip your kids with the future-ready skills.
eYantra complements the higher education system by bringing in a component of practical exposure through project-based learning. The eYantra lab setup initiative helps a college to set up a robotics lab and also trains the teachers and the students. Our unique lab in a box speeds up this entire process. eYantra provides training and a powerful network rooted in the innovation ecosystem of IIT Bombay to address issues related to training to build startups. The goal is to create a global community of innovators who collaborate to solve real problems in society in partnership with other people of similar interests. We've established over 450 labs across India and are looking forward to establish more such labs across the world. eYantra believes that our future lies in empowering young people to solve problems. eYantra believes that startups are a potent medium to solve real problems in society, and eYantra trains young people in future skills, helps them collaborate globally on our platform, and helps them solve problems to engineer a better tomorrow.
Revolutionary. eYantra is entrepreneurial.
For me, it's opportunity.
Living your dream life.
Accelerator.
Learning by doing. Fix any problem. Complete exposure. You get persistence. It helps me to see things more clearly.
This competition helps to open the minds of students. The college is all they know. Like they don't know what's going on outside the state and all the other new developments that are happening. Coming to this competition not only helps them like learn about all the innovation, but also opens their mind to new way of thinking, and that might like change their career path. And the sooner that it is done, the better it is for the student. We came in our 4th year and we were thinking like if we came in our 2nd year, that would be better, because then we would have like 2 more years to like develop ourselves and like fix our career path much more better than we have now.
e-Yantra Innovation Challenge is a competition that trains students in innovation and entrepreneurship. It nurtures young minds to articulate real problems in society and to solve them using technology. It immerses participants in problem domains and helps them articulate problems which then they solve and use the solutions as a basis for startups. It's a platform to showcase solutions to incubators and to build your dream startup. Guidance is by e-Yantra engineers and industry experts. So join us. Registrations begin on the 1st of September every year. So be
There will be two types of obstacle. One will be the speed breaker, that will be this one, and another will be the ramp obstacle, that will look like this. This will be the manufacturing zone, and this will be the deposition zone. So the hardware that has been implemented in this thing is the servos, then the HC05 Bluetooth model for the communication, and 6DOF IMU with N20 motor with encoders, and the development board that has been used is Arduino Nano. So let's see the theme video now.
coming to the score, so there will be the final score will be addition of formula score as well as the judge score. So formula score will look like this. So there the formula score will be consisting the penalty as well as the bonuses that will be found in the run. So and the time taken for the team, a particular team, to complete the run. And judge score will be Viva questions including the topics that are been included in this theme particularly. So the controls, then the dynamic response of the bike, and designing. So designing aspects will be considered. So yeah. So now and the credits for this particular theme. So the theme developers are Jerish and Sahil. So a special thanks to Isha, Abhishek, Paras, Madhu, Jason and Shama, Rutuja, inventory and office team for helping us. And we appreciate the Ministry of Education's help for us. Also our beloved PI, Mr. Professor Kavi Arya sir, and our team. So now let's enjoy the show and let's see how the balancing bot gives us the entertainment and the balancing. Thank you.
So now we will be starting with our first. Yeah.
Little interrupt here. Okay. Hi everyone. So this is to just introduce the jury members here. So like I said in the morning, getting one person, one faculty member to a meeting is a challenge at IIT Bombay. Here we have 3, so we should be given a prize for it. So I'd like to welcome you all. You met Professor Doipa and Mukherjee in the morning, so I won't introduce him again. And he's a prof in the electrical engineering department. We have Vivek Natarajan here. You can take a bow, from Systems and Control Department. And he's a PhD in mechanical engineering from University of Illinois in Urbana, Champaign, and a BTech and an ME from IIT Madras in mechanical engineering from IIT Madras. And he's faculty here since 2021, so fairly recent in a way. Okay, 2015. Okay, sorry, you've been coming here. Okay, 2015. I'm sorry. And his area is adaptive control, multi-agent networks, nonlinear Schrodinger equations, periodic systems. So all the hardcore control systems work that goes on. In fact, if you want to fly a rocket or do something cool with robots, at the heart you'd have algorithms which he would have some knowledge about. So just earlier on we were talking about this whole thing with Nitin Gupta, who's an IIT Bombay alumnus and runs a drone company where they're doing swarming of drones and all that kind of stuff. He was arguing for the case that we need to do something special with our students to go beyond the usual way we teach them, to kind of rewire their brain to be able to use AI in everything that they do. So what AI is doing is that it's making a new tools and possibilities available to us as to how to solve a problem. And there's a case for a deeper layer, the ones who will come to IIT Bombay to do cool stuff. That means that you have humanoid robots who you have to program to do stuff, and AI systems that you have to work with to solve problems. But then who will build the systems themselves, the humanoid robots themselves, all the control systems that go there to make them move around in an effective manner and things like that, building all the materials to make the robots with, building the motors, right, highly efficient electric motors and things like that, which can do that kind of work, and then the control systems that make them move in a manner that is consistent to getting work done. So that's Vivek Natarajan. And Professor Paritosh Pandya is with us in eYantra, and he is a former professor and dean of computer science in TIFR, and his interests are logics and automata, formal methods and stuff like that, and also eYantra kind of stuff. And he's a great believer in eYantra because he realizes that this is where the rubber hits the road with engineering. And just formal methods by themselves and all that need to be married with all this work that we do here. So very, very important inputs. So that's your jury, and I'll hand you over to the team here. Thank you. Big hand.
Yeah, so let's start with the team run. So the first team who is going to perform will be the team ID BB2976 from Krishna Institute of Engineering and Technology. Okay. Okay, judges ready? Okay, what are scorers? Ready, okay. When the buzzer beeps, okay, time starts now.
Start of the team run, and we are going towards O4 obstacle.
Okay, obstacle
O4 cross successfully.
Okay, obstacle O4 plus 1. CP plus 1. So the bot has
Bot has successfully picked up the block from B12. And now we are going towards R1 ramp obstacle.
The bot processed the ramp successfully, so ramp obstacle RB, R1 plus 1.
And now we'll be going towards the deposition zone, D1.
CD plus 1.
So the block is correctly deposited. Slowly.
Okay, the bot is going for the next pick. So it encounters an obstacle, so it's trying to cross it. So the bot crosses the obstacle O2.
Yeah.
So O2 plus 1.
Now we are going to pick up the next block, which is B6.
So bot is aligning to pick its second block. Oh, it picks its second blocks correctly. So CP plus 1.
Stable.
Once again it tries, it successfully crossed the ramp. So R1 plus 1, RB, R1 plus 1.
Yeah. Slow turn. Take the
So it's going to deposit the second block to its corresponding location D2.
Slow turn. Slowly.
Now it's going to cross its next obstacle.
Slowly.
Yeah, it successfully crossed the next obstacle O1. So O1 plus 1 obstacle, O1 plus 1. Okay, so CD plus 1.
Slowly.
So it's going to have its end of the run. It's going towards end of the run. Okay, so there will be 2 runs given to the each team. So they are going for their second run. So judges ready? Everyone? Scorers? team, ready?
Yes.
Yeah. Judges, ready? Scorers, ready? Okay. Okay. So on the sound of the beep, the run is going to start. Start.
So now we are going towards O4.
The bot is going on its way, so it encounters the obstacle O4. So it successfully crossed its obstacle twice. So O4 plus 2.
Now we are going to pick up B12.
So the bot is okay. CP plus 1. So the bot is going to deposit the block it has
Now we are
picked.
going towards the deposition zone. We will be crossing R1 ramp obstacle.
The bot crosses
R1 is
plus
crossed.
1. Ramp obstacle R1 plus 1.
आराम से हाँ drop.
So CD plus 1. So the bot is going for its second block.
Slowly, slowly. Slowly, slowly. Slowly.
So it's on its way to the second block.
Slowly, slowly.
Okay.
Slowly.
So it's going for the ramp, second ramp.
Slowly. Control. Stable.
Okay.
Stable,
It's on its
stable.
way to.
Okay.
It
R2.
successfully crossed the second ramp R2.
Yeah.
So R2 plus 1.
So now we are going towards B6 block. Slow run. आराम से. उधर. हाँ ठीक है उधर. ऊपर हो तो गया है.
So bot is on its way to pick its second block.
O2. Slowly.
The bot is going to cross the other obstacle.
Slowly.
The bot crosses the next obstacle O2. O2 plus 1.
Slowly.
Okay. So one manual intervention. So MI plus 1. The bot picks the second block, so CP plus 1.
So now we are going towards the deposition zone.
Okay. So second manual intervention, so MI plus 1. So bot is going to deposit second block. The bot is going to cross the next obstacle. Okay, it successfully crossed the second next obstacle. So obstacle O1 plus 1. So it places the blocks correctly. So CD plus 1. So it's going towards end of the run. End of the run. So now the team can go to Viva. So, okay. Total. Both two. Okay. Okay. So second run time, 4 minutes. 21 seconds. Okay. Anything else? Huh? Okay, now we will be going with the second team. So the second team will be team 2402 from NIT Roorkela.
Slightly non-technical question to begin with. How important is the skill of the operator to the success of this motion of the robot? Yeah.
So I would say that skill of the operator is like as important as balancing the board, because if the operator isn't skilled enough, then how the bot will even like move a step forward. Like गाड़ी वही चला सकता है जिसके पास लाइसेंस होगा, नहीं बिना लाइसेंस के भी गाड़ी चलता है, लेकिन जो what like आप कहीं भी like एक्सीडेंट्स का तो खतरा हो ही सकता है, तो proper training is like very important.
So what would it take to automate this?
So
have you given it some thought? Because that's just the next step. Problem,
Yeah.
I mean, problem-wise, that's a whole new scale of problem altogether.
Yeah.
But now that you've come this far, you've managed to learn. I guess you're second-year students, right?
Yes.
Yeah, and in my second year, I had never heard of things like LQR. So now that you've learned things like these in your second year, you still have 2 years of engineering to go after this. I would expect that you would invest a significant amount of thought behind. Like in the morning, we are talking about AI and stuff. So you have to learn about this model, and if you know more about it, perhaps there is hope that you'll be able to automate this whole thing.
Of course, sir.
In order to optimize, even like I saw you do this, you used your own brain to sort of maximize the number of points,
Yeah.
go over and over again across the obstacles
Yes, sir.
to just gather more points. So subject to all of these constraints and optimization, right? You should be able to also automate this program, isn't it?
Definitely, so we have thought of it, like we want, after this, we want to apply path planning and image processing, which can, which it will make it automatic.
Any rudimentary idea as to how you could possibly keep it on track?
Sir, we have applied the yaw control to,
How are you going to track it?
So the white lines can act as a guide for tracking, and yeah, the borders as well. We can.
What if there are junctions?
If there are junctions, then we can like choose a path, optimal path, and use computer vision using cameras.
I mean, suppose if there's a
Yeah.
single track, you keep tracking that path and you'll
Yeah.
be on the correct road. But now you have two. So of course you can toss a coin, but the vehicle cannot.
Yeah.
How does the vehicle decide which way it is going to take?
maybe we can use color sensor, like there is the, where we have to pick the block, they are of red color.
Yeah. Like in the junction, there are colors that here's the block and there's the block.
Okay.
We can implement that.
Okay.
Yeah.
Keep thinking about it.
Yeah, definitely.
So, can you explain your the construction of your bot?
Okay, sir. So this bot is made up in 3 parts. This is the base area. So this is the base area. The base contain all the components. Like there is the battery inside the base, and this is the body of the bot, the whole body, and this is just the upper cap of the bot.
Okay.
And these, it contains this is one part, and this is the arm is this another part, and there are then grippers.
Okay.
So it is in again 3 parts.
Okay.
So we were having so much of constraint of the length and width of the bot, so we have to make it like this.
All right.
And one more important part is this sensor mount. So we don't have an option to put screws in the base because there is battery in the base. So we have made this mount especially for the sensor MPU.
And this actuation, you're giving the same command to both the wheels or independent commands?
No, sir, same commands to both the wheels.
Okay, but the operation is, you can rotate them independently?
Yeah, rotate them independently.
So could you have used that to perform better?
Yeah. So for your control, we have like programmed the wheel independently.
So you have done that?
Yeah.
Okay, so when it rotates, you are using differential to rotate the thing. Okay.
Yeah.
And how did you go about the controller design?
So we have implemented LQR control.
So you developed the model first?
Yeah, mathematical model.
Actually, we have changed our model one time before because it was not working.
So how did you get your model?
So we have made it by ourselves only, like given constraints and whatever parts we were having. And then when we applied that initially, it was not working because its center of gravity was somewhat up, and the motors were not that much supporting it. So then again we have to change the model, and now it works.
What was the order of your model?
Yes, sir.
The order of the model differential equation, right? Or the order of the differential equation?
So
the mathematical model you had, right, for doing your LQR?
Yes, sir. So it's first degree model.
First degree?
Yeah. First order. Sorry.
Order.
Yeah.
Okay.
No. I think it's a proportional control. LQR is
because you developed LQR, right?
Yeah.
So then you must have used a model to develop the controller, right? The gains.
MATLAB.
Yes, so MATLAB will ask for the model of the system, no? That you.
Also, we have calculated the mass and that.
Yeah, actually we have designed everything in Fusion 360. So we have assembled all the part and calculated center of mass and moment of inertia and everything. And then we have put it in a predefined script in MATLAB, and then we found the gains.
And that script develops, thinks of it as an inverted pendulum. Is that what
Yeah,
it is?
yeah, it is of inverted pendulum.
Okay.
Yeah.
Okay. All right, nice. Yeah.
Yeah.
I think
that's
yes. So, what was the most challenging part of this design?
Sir, the most challenging part was the placing of the components. Like we were having so many different components, and the most important part was this gripper. Because if we are not doing it like this, so it will not work. It will not be able to pick up the blocks. That was the most challenging part.
Yeah, if the gripper,
yeah.
If the gripper is too short or too long, yeah.
Okay.
Yeah.
So, associated question is, when you do this model the dynamics, be non-linear, but with gripper, it's working in two modes. It's kind of adaptive. With the gripper down, it is for. Do the equations change continuously, and did you have to change the controller when you were gripping the block and moving with the block?
So
the same set of equations
there was a story behind it. Like one of our prof in college said that we should implement dynamic control system in this model, but we just explained him that the gripper is not in the balancing axis. So
yeah, it is not.
So it won't interfere much with the model.
That's a good. I saw that it was in this. Okay, thank you.
Thank you so much, Judy.
So now we have our second team, 2402 from NIT Rourkela. So teams ready? Okay. Judges ready? Scorers? Okay. Yeah, we'll see. Start.
The beep has started. The bot will now cross obstacle number 4.
So the bot is.
After crossing obstacle number 4, it will go to B12.
Obstacle 04 cross, so 04 plus 1.
It will now pick up box number 12 in M2. सामने 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 थोड़ा पीछे 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 आ जा pick up.
So the
bot has picked up box
picks
number
up blocks
12
correctly. So
Bot
CP
will now
plus
cross
1.
R1 up Shima up Shima पीछा go from O2 then go from O2 go from O2
It's in the manufacturer, so no penalty with that. So
go from O2. It's okay, it's alright.
yeah, so it just pushed the
Okay,
block
so
inside the
now-
manufacturing zone, so there is no penalty for this actually.
The box will now cross ramp 1.
So it's going to climb the ramp.
The box will now deposit B12 in D1.
So ramp obstacle crossed successfully. So R1 plus 1.
Turn easy.
So one path penalty. No.
Easy.
So no path penalty.
The box will now deposit in D1. Valid
So
deposition.
correct deposition. So CD plus 1.
Now come to O2.
Bot is on its way to take his second block.
Cross O2.
The bot crosses the second obstacle.
Now it will
so
pick up box number
O2
6.
plus 1.
It will now pick up box number 6. You have to tilt a bit. Okay. Go forward, and then turn a bit. Not like that. Ulta turn.
Bot is going for second block.
हाँ थोड़ा सा आगे जा हाँ पीछा ऐसा नहीं पीछा pick up हाँ pass
So
बढ़िया
correctly
Cross
picks a
ramp
block.
1.
So CP plus 1.
Cross ramp 1 again. Deposit
so block
in D2.
cross the next
Come
one
close
more
to D2.
obstacle.
Come close to D2.
So
Bas,
obstacle
turn.
O1 plus 1.
Bas down and then open. Bas come to S1.
So correct deposition. So CD
Come
plus
to S1,
1.
come
So
to
it's going to the end of the run. End of the run. Okay, 3 minutes 36. Teams ready? Judges ready? Scorers? Okay. Ready? Judges ready? Okay. Start. Time is
The starting time beep has been buzzed. We are going to cross obstacle number 4 first. Obstacle number 4 cross
Obstacle
successfully.
cross successfully. So O4 plus 1.
We are going to cross obstacle number 4 again.
So
Obstacle number
once
4
again
crossed
it cross.
again.
So O4 plus 2.
Turn, turn. Easy turn. Easy, easy.
So, one manual intervention. So, MI plus 1.
Chill, chill. So, number 4 crossed. Go to
The bot is going
B12.
to take his first block.
Turn, 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 Shimon. Come back, turn. Turn, turn, turn. Yes. Come forward. Up. Up.
Okay, correct pick. So, CP plus 1.
The bot will now cross ramp 1.
The bot is going to cross the ramp obstacle.
The box will now be deposited in
The ramp obstacle
D1.
R1 successfully. So, R1 plus 1. So, correct deposition. So, CD plus 1.
The box will now come to obstacle number 2.
The bot is going to pick his second block.
The box will now cross ramp number 2.
So, it's going for the second ramp obstacle. So, it's going to. So, ramp obstacle R2 cross successfully. So, R2 plus 1.
The box will now
bot is on its way to pick the second block.
pick up.
Second block pick successfully. So, CP plus 1.
पीछे आके जा
So, obstacle O1 cross successfully. O1 plus 1. Correct deposition. CD plus 1.
The bot will cross O1 again.
So, the obstacle O1 crossed again. So, O1 plus 1. Okay. So, manual intervention. So, MI plus 1. So, it's kept in the successfully crossed checkpoint. So,
turn. Front and turn.
Okay, the bot is going to have its end of the run. Team, you can go for your Viva. Okay. So then. So the next team will be team 1256 from Dr. Vishwanath Karat, MIT World Peace University.
Alright, so we can probably discuss the design later. Let me ask you about this controller design. So your bot looked quite stable, but were you trying to rotate it well to cross obstacles?
Yes.
What was the algorithm? What were you trying to do there?
Sir, actually, sir, if it is simultaneously crossing on both the wheels, actually the tilt inclination is more.
Okay, yeah.
So if it is crossing through both the wheels, the tilt inclination is more, so it is more unstable. and it tends more to falling. So like if I cross using one wheel at a time, so basically the angle of inclination is less, so it is less prone to falling. So like that's why I was.
And so do you control the wheels independently throughout, or what is the algorithm like?
So like in the forward and backward control, both the wheels are given the same, and like there is also an yaw PID, basically the rotational PID, because due to the imbalance in the center of mass along this axis, so there is an unwanted turning. To prevent that, we have implemented rotational PID, so that is automatically giving differential voltage to both the wheels to somewhat nullify the unwanted turning effect. And also an
So how did you figure out the gains of all this? So you are a PID controller?
Sir, actually the balancing is done through LQR control. For the yaw control, we have implemented rotational PID.
I see. So how did you design the LQR control?
So the LQR control matrix, actually, first we tried out the one given by e-Yantra, which we like tried to understand, but that did not work very well for this. Like we did not have like good results with the implementation. So then we researched online. We got some research papers. So from one of such research paper, we took an A and B matrices for the LQR. So A is 4x4 and B is our 4x1. So the states are linear position and linear velocity, and tilt angle and tilt angular velocity.
Okay.
So.
And so these matrices you got from the papers, the values, where did you get the values?
So the values are actually, he designed the whole model in SolidWorks.
Okay.
So, and we went to a lab in our college. From there we measured every individual part's mass. We put that in the software and we got the center mass and moment of inertia.
Oh, so the matrix was given in terms of the mass and inertia.
Yes, sir.
That's
Yes,
what
sir.
you used. Okay, I see.
Yes,
Very
sir.
nice. Okay.
Also,
and what is the yaw control? Can you explain that again to me? That LQR is for control balancing.
The LQR is for this angle balancing.
Basically, due to this manipulator attached on one side, the bot, when we try to move it in a straight line, it tends to turn on this side because there is a more mass on this side. So to avoid that, we have implemented rotational PID. Basically, we took the error as the difference in the displacement of the two wheels, and then we applied a rotational PID.
But do you expect it? So you are giving the same command to both the wheels. So are you saying it slips on one side?
Oh, yes, sir. It might be so, and also due to the imbalance, like there would be a rotational torque. So naturally, it would tend to like move on one wheel. And one drawback, as you said, is that if the wheel slips, like we might get an erroneous error. So like that is not reliable error. That's why we also try to integrate the yaw angle data coming from the MPU. But the problem with the MPU data is that it is MPU 6050, so it does not have a magnetometer. So actually the accelerometer calculates the angle with respect to the gravity vector with the earth. So that value is not reliable when you are taking the rotation along the gravity vector itself. So it's not reliable. So basically when you only have the gyroscopic data. So that tends to drift when you integrate it because it gives the angular velocity. So that drifts over time. That was drifting very quickly. So that's why it is somewhat erroneous. The implementation. Sir,
I'm done with
Sir, it's simply the difference in displacement of both wheels.
You don't have position encoders on the wheels?
Yes, sir.
You have?
Yes, sir.
Okay, so you know absolute rotation in terms
Yes,
of
sir.
position encoders?
Yes, sir.
Okay, that's fine. Can you explain your mechanical design? Why is your battery at the top?
Sir,
how did you design these things like that?
Sir, actually first at the very beginning, the battery was in the lower part. So basically it was balancing in a single point well. But the problem with the obstacles is that the angle changes rapidly. So it needs to react that fast to make it balanced. So we imagined it in this way that if we have a stick and there is a mass attached at top of it, we can move our hand, which is placed at bottom of the stick, more quickly to react to the falling of the mass at the top. So by shifting the center of mass to the top of the bot, it like the actuator, I mean the motors were more free to move and react to the rapid change.
You are saying that by raising the CG up,
Sir.
your system is becoming more
Yes, sir,
stable
yes, sir.
and easier to control?
Yes, sir, it's a bit counterintuitive. At first we thought that if we put the mass below, basically, yes, sir, but basically, sir,
if it's too low, then it's also difficult for the system to balance itself with the disturbances.
So when we increase the center of mass a bit higher, yes, sir. So
Does it show up in simulations or?
So like basically what we did, we thought the same at first. We put the battery below and then we made the entire design. That's what most of the teams here have done. But then we just find out by experimentation that when we increase the higher center of mass, basically the rotational inertia of the bot increases. So it's more like it's less susceptible to changes in angle. So when it's crossing obstacles, it's basically the changes in angle are happening more slowly. So the motor attached to the motor is basically able to counteract these changes and it's able to balance itself.
It's also like if the base is free to move, then it can like react more quickly.
And one last question, then I'm done.
Sure.
So when climbing the bumps, the speed breakers, I found your bot had difficulty. Usually one wheel would go first. Why do you think? And do you think a better mechanical design would help there?
Actually, I was doing that on purpose because at first, like the bot fell at 04. So basically, I don't know why. Maybe due to the friction, like less friction or something, it fell. So to avoid that same happening, I tried to like take one wheel first.
You tried to rotate at that you were doing by the control.
Sir.
And how would that help?
Sir, like if it goes like this, there's more change in angle, more disturbance. If it goes like this, there's less.
Like this.
Then basically one angle is higher.
Yeah. And then you are just gonna, maybe that's easier to control. Okay, that's fine. Yeah.
So like it can cross obstacles normally, but like we chose a safer approach for our run.
Thank you.
Do you remember in what manner you chose this Q matrix for the LQR control? Like what are the relative values at least? Which one was the largest?
Yes, sir.
Which state corresponded
Yes,
to the
sir.
smallest? And in what
Sir,
order? And what's the logic?
Yes, sir. So it was like the highest value needs to be for the angle because it is most prioritized. So the value was 1000 for that, and the next most crucial thing is the linear position. So 500 was assigned for that. Then
Would you say the next most crucial is the linear position?
so like if I'm balancing the bot but it is like drifting all over the place, then it's of no use basically for this arena.
But why would you say that the position is going to be more important for balancing than, let's say, something like the angular velocity?
So the angular velocity, actually we found that if I increase the angular velocities like value more, then
The weight on the angular velocity.
Sir, the weight on the angular velocity, the oscillations increase. So like the bot tends to become unstable because the angular velocity we get from the gyroscopic data and that is also quite unstable.
Thank you, sir.
Okay, so now we have our third team, 1256, from Dr. Vishwanath Karad, MIT World Peace University. Team ready? Are you ready?
Yes.
Okay. Judges, are you ready? Yeah. Scorers?
So we will be starting our run now.
Start of the run. Yeah.
We will be taking the path through 04. O4 passed successfully.
Okay, 04 successfully. So obstacle 04 plus 1.
O4 for the
crosses-
second time.
Okay. So 04 plus 2 obstacle. 04 plus 2.
Going for block B6. Slow.
So bot is
Perfect
going
angle.
for the first block.
Align. Can pick. B6 pick successfully.
So CP plus 1.
Going through ramp R1.
Ramp obstacle cross successfully. So R1 plus 1. So the block is, what is going to deposit its first block?
Going through O1, O1 successful.
So obstacle O1 plus 1.
Dropping at D2. Stable.
D2 placed successfully. So CD plus 1.
Right. Going for obstacle O2.
Obstacle O2 cross successfully. So O2 plus 1.
Going for O2 once again.
Okay. Obstacle O2 plus 1.
Going through ramp R2.
So the bot is going to cross the ramp obstacle. Bot crosses the ramp obstacle successfully. So ramp obstacle R2 plus 1. The bot is on its way to its second block.
Going for pickup at B12. Good angle. Align. Pick.
Correct pick. So CP plus 1.
Going through ramp R1 once again.
The bot is going to cross the ramp once again, R1.
Slow, slow. Easy.
Ramp R1 cross successfully. So R1 plus 1.
D1 drop. You can drop. नहीं मत, okay? ठीक है ठंडा धीरे.
The bot is on its way.
R1.
Correct deposition. So CD plus 1.
Going for obstacle O1 once again.
Obstacle O1 cross successfully. So O1 plus 1.
Going to take exit from S1.
End of the run. So the team is going for their second run, right? Yeah. Okay. Yeah. Team, are you ready for your second run?
Yes.
Okay. Judges, are you ready? Scorers?
Yeah.
Okay. Yeah. Okay.
Just 1 second. Go through here. B12. D1. Sorry. नीचे आना है O2. O2 लेना है. B6. U-turn. बताएंगे ठीक है? टेंशन मत ले. Yes, we are ready.
Okay. Judges, ready, right? Okay. So the team is going for their second run.
We are ready to begin.
Start of the run.
Going through obstacle O4.
Obstacle O4 crossed successfully. O4 plus 1.
Going for block B12.
So it's going for its first block.
Good angle.
So correct pickup. So CP plus 1.
Forward. Going through R1 ramp.
So bot is going to climb the ramp obstacle R1. The bot crosses the ramp obstacle successfully. So R1 plus 1.
Drop.
The bot is going to deposit. So correct deposit. So CD plus 1.
इधर बीच में से.
So the bot is going for its second block.
आराम से. O2 double.
The bot is trying to cross the obstacle O2. So O2 cross successfully. So O2 plus 1.
O2 for the second time.
So they are planning to cross the obstacle once again. So O2 plus 1 again.
Going through ramp R2 now. Good.
They are going to cross the ramp obstacle. So ramp obstacle cross successfully. So R2 plus 1.
Big block B6.
They are going for their second block.
Turn. Forward. Turn. Forward आजा. Align. You can pick. Take.
So correct pickup. So CP plus 1. So it picks the second block successfully.
R1 once again.
So they are trying to cross the obstacle R1. R1 cross successfully. Ramp obstacle R1 cross successfully.
Going to O1. Turn.
So they are going to cross one more obstacle. So O1 cross successfully. So O1 plus 1. Obstacle O1 plus 1.
Turn, turn.
So correct deposit. So CD plus 1.
O1 come back.
So they are planning to cross O1 once again.
Turn. Saved.
O1 plus 1.
Go through middle line. Taking ramp R2 once again.
So they are going for the ramp obstacle once again R2.
Nice.
So R2 cross successfully. R2 plus 1.
Turn. ठीक है ठीक है. Taking obstacle O4 once again.
Obstacle O4 plus 1.
Taking the exit from S2.
So they are going to end their run from S2. End of the run. For what? 4 minutes? Okay. Okay. Team? Team, you can go for your Viva. Yeah, okay. Okay. So the next team will be team ID 2359 from NIT Rourkela.
Okay. So can you tell us who did what in this? Of the four of you, who was responsible for which components?
So the main designing part was done by Vijit and Sanskriti, and the overall the logic part was done by me, Vijit, all four of us did the logical part. So the final the MPU thing, the PID controlling and all, the tuning part was done by me. Most of the tuning part, the changing the all PID and D values, and
Now, so you have a PID controller for this,
Yeah.
For both the inverted pendulum part as well as the. So how does the gripper work? I think that's one of the things we are curious.
Okay, so there are two servos that eYantra has provided us. So one servo works for the manipulator arm closing and opening part, and the other servo is working for taking the arm up and down. So what we did is, in our logic, while writing the first iteration of our code, the opening and closing part was done by one button, I mean 2 buttons, and the up and down motion was done by another 2 buttons. So we had actually 4 buttons for it. But then we had to optimize it, and overall we have to make our run shorter. So we merged everything, and now the pickup and down, like drop off, is done in one single button. So we have only one button for pickup.
That's the whole thing, one soup.
Yes.
Okay. Okay, I see.
Yes.
Right. And so did you do any modeling for this? Because you did PID, so you just tuned it. Yeah. So did you have a model that you tuned with, or you just did the tuning right on the hardware?
No, we tuned it right from on the board.
Okay.
We did not have any modeling to do. We did the trial and error method.
Okay, fine.
Yeah. We had for the software round, we had the Copilia sim in which we did the. Yeah.
I see. Okay. And what are the challenges you had in tuning? Was it how long did it take you? Because you didn't do LQR.
No.
You just did tune. So how long did it take you to tune it?
So initially, in the middle of the competition, around in December, we finally found out the correct value. So it took around a month to tune. We did a lot of iterations of the body, different weight distributions, where should we put the battery and where should the main PCB should go, and the MPU 650 to get the accurate results, accurate angles, and reduce the noise.
And your design were kind of
parallelly.
in parallel.
Yeah.
Okay. All right.
So
Nice.
just one more thing about this. We are not running our bot on pitch PID. What our model does is, first it takes the error of the position error. It takes the position error, and after that it gives it to the pitch PID. So R is as a set point. So that's our cascade PID, and we have set a off limit. And also one more thing about this is, while we were driving, we noticed that if we keep on spamming the forward button, keep on setting up, it will go to a certain point, and after that it will fall off because the velocity is too much. So we also implemented a safety feature in our code. So if the derivative of the change of the pitch, so the rate of change of pitch is too much, then it will just safety out, so it will stop itself and then again start. But we can keep on spamming, we don't need to do anything else. So it does it automatically.
So, see, there are two things to control here, One is to balance the bot, you will have to change the two motors, forward or backward, so that it remains balanced. The other is to move forward or to move in a certain direction. When you press forward button or backward button, I noticed that your motion was a bit jerky there. Going fast and then stopping, fast and, the starts and stops were very, very. So what do you use? Is it an open loop control there? Is there any feedback there? How is the motion?
So the thing is, we use the encoder pulse counts, so that we use that as a set point for the position PID. So we told it how much we want to go, and according to that, it adjusted the set point pitch and then started giving the actuations. So of course, when we started coming closer to the
There is
position,
no pitch. You're moving forward.
yes,
Suppose you want to move forward.
Yes.
For 2 meters, you just press forward button for some amount of time, right? How is the differential drive control? There are 2 separate motors, right?
No, actually, sir, it's not about how long we press. On each press, it tells us, it tells the robot that it wants to go this much distance forward. That's why you see it slowing down, slowing down. Yes. Yes, sir. That's why we.
How much to move you count by the position encoder on the wheel. Okay, that's your approach.
One more thing. That's why we had to implement 3 forward buttons and 3 backward buttons. So depending on how much we want to move, we added more precise control on that. If it's a small movement for adjusting of pickup, and for ramps and obstacle, we added a boost button.
Also the jittering part you asked, we kept the KP a bit high to like not that much high that the bot starts oscillating, but since our bot stops after some time, we kept the KP high so that it does not fall. So that was the reason for the jerking. So it gave us more speed, but in trade to some jerking of the bot.
So you think increase in KP gives you faster sensitive control, is it?
Not that much higher. I have tried a lot of different values of KP, and also.
But did you keep it high or low? You chose more higher value possible.
Yeah. Also, we have a position PID that has a lower KP value, so that it does not. So if we give some amount of set point, it does not just keeps moving and falls off.
Okay.
Yeah.
Okay. I think I'm done.
Fine. So did you keep when you're doing this heuristic design?
Sorry?
Heuristic kind of a design that you're doing for the PID controller, did you keep a tab of the kind of values that work, the kind of values, so sort of like a exercise notebook or whatever? Digital format or hard copy, where you're just noting on these different values.
We wrote in a
writing your
notebook.
inferences. So you have a whole logbook, I presume, of this.
Not a complete logbook. I took ranges. In ranges, I used 30 to 40, 50 to I chose.
So I would just like you to, because the reason I am asking this question is I would like you to then quickly summarize what your observations were. Like increasing KP, you just said about it. What happens if you play around with KD by keeping the others fixed? What happens if you play around with KI by keeping the other 2 fixed?
Yeah, so if I increase the KI too much, it starts okay, it will not jitter at first, but when we keep on spamming, it will fall after some time, because due to the in accumulated errors, it will keep on adding up, and it will fall after some time. So our our KP and KI are around. So the KI is 10 times the KP. So also increasing the KD, it starts to jitter at its place. So I also kept the KD a bit low to dampen the the oscillations. No, not that much.
Do you know any standard prescription of how these 3 parameters are tuned?
Yeah. So we
what
start
is
with
prescribed in sort of method?
Yeah. So start with KP.
Yes.
Until it oscillates.
Okay.
Then when it starts oscillating, we increase the KD value so that it dampens the oscillation.
Okay.
Then to reduce.
So higher KD reduces oscillation.
Yeah, but not the. The tuning part I was telling that I did not keep the KD that much high. Then to reduce the steady state error, I use the KI value.
That's the prescription, right?
Also, we did not
we don't calibrate our MPU
before each run. We just have some offsets according to our bot, according to the weight distribution, so that we do not have to keep doing the calibration of the MPU.
Because in real life, we can't do that.
Yeah.
Each and every time.
One question: when you go up the ramp, now the perpendicular to the ground is inclined, right?
Yeah.
Your bot will balance at what angle to this perpendicular?
I haven't tried that. Like,
What do you think will happen? You think it will?
No,
where would the bot balance? I mean, with respect to vertical, when you're playing, ground is inclined.
I think like
30 degrees or 20 degrees.
I think it can balance that. I have.
But balance where? Either like this or vertical
No,
or how?
no, like on the incline, like it will balance like straight, like this.
So what with respect to this as a vertical line?
Yeah.
If it's inclined, will you balance at this position or will you balance at this position?
This position.
Thank you.
Just one background, we are all from CS core, so this thing is not in our domain. Yeah.
No.
So we found the SQL file online and we found the.
This is metal bender's question, mechanical engineering question. You used gears at the back, gear sectors. So whose idea, how did you think of that?
So first.
None of you has that background, right?
No, sir. So that's why we found this. We experimented with multiple 3D grippers, and like we searched around for some STL files which could be useful for our application, and we realized that this would have the best reach while also. Yes, so we also explored a lot on YouTube, and we found that this design is very popular for this kind of gripper. So we searched for an STL file.
Quick second question to that. You are handling a soft material there. So the gripper pressure may or may not matter that much. So a little overdoing the pressure will grip the plastic flexible part easily. What if it was a hard part? If it was a solid hard. This is not hard,
Yes.
right? This is not solid. What if it was a solid part like a box, for example?
So that's it's a bit similar to a situation.
So how would you control the gripper pressure? You are not controlling gripper pressure here, right? Are you? No, you are not, because you are letting it be and taking purchase over the soft part.
Yeah, so our answer would be, according to the theme, we adjusted our, because if we were going to adjust our pressure, then it will take us more time. So what we traded off with a bit of that is time. We can easily control our servo motors over there to adjust how much we want.
But
The
that's
thing,
another precision then, hard surface, it doesn't slip, friction of the surface. This is easy to handle. But
Yeah.
Anyway, compliments, good work.
thank you. Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Where should we take this?
So now here we have our fourth team from NIT Rourkela, 2359. Okay. Team ready? Okay. Judges? Okay. Okay. Scorers ready? Okay.
So
Start
boat
off.
has started moving from S2. It's going towards the obstacle O4.
Board is going towards its first obstacle.
Obstacle
board
crossed
cross-
successfully.
It crosses twice the O4, so O4 plus 2. Once again, so O4 plus 1.
It goes towards the block B12.
It's going to pick his first block. So the first block picked successfully, so CP plus 1.
It's going towards the ramp R1.
So board is trying to cross the ramp obstacle R1. So it crossed successfully. So ramp obstacle R1 plus 1.
It's going to drop the box at D1.
So the correct deposition. So CD plus 1. Bot is going for its second block. Let's see.
It's going towards the obstacle O2, sorry, ramp R2.
The bot is trying to cross its second ramp obstacle. So R2 cross successfully. So R2 plus 1. So the bot is on its way to its second block.
It's going to pick the block B6.
So the bot is going to pick its second block. So the second block picked successfully. So CP plus 1. So it's going to cross the ramp obstacle R1 once again. Ramp obstacle cross successfully. R1 plus 1. So it's going to deposit its second block. So the bot crosses the obstacle successfully O1. So O1 plus 1, and it's going to deposit its second block. So correct deposition. So CD plus 1. So it's going for its end of the run. End of the run. Second. 21 seconds. So the team is going for their second run. Judges ready? Okay. Scorers? Okay. Okay. Team, you can keep your bot on the start location. Okay, fine. Yeah. Judges ready? The scorers? Okay. Start of the run.
So bot has started moving. It's going to cross the obstacle O4.
Bot is going to cross his first obstacle. So O4 cross successfully. So O4 plus 1. It crossed once again. So O4 plus 1. Once again. So O4 plus 1. Okay. Actually the box are not kept. Okay. So no. So this won't be a run. So we need to restart. These blocks are not kept. Teams ready? Ready? Judges ready? Ready? Scorers? Okay. Start of the run.
So the bot has started moving. It's going to cross the obstacle O4.
So the bot crosses the obstacle O4 successfully twice. So O4 plus 2. So it crossed once again. So O4 plus 1.
It's going to pick up the block B12.
So bot is going to pick its first block. So the first block picked successfully. So CP plus 1. So the bot is trying to cross the ramp obstacle R1.
It's going to drop the block.
Ramp obstacle cross successfully. So R1 plus 1. So it's going to deposit its first block. So it's on its way to deposit its first block. Okay, the obstacle O1 cross successfully. So O1 plus 1. So it's going to deposit the first block. The correct deposition. So CD plus 1. The bot is going for its second block.
Going to cross R2, ramp R2.
Ramp obstacle R2 cross successfully. So R2 plus 1. The bot is on its way to its second block.
Going to pick the block B12.
So the correct pickup. So CP plus 1. The second block has been picked successfully and it's going for its deposition. It's trying to cross the ramp obstacle R1. So R1 cross successfully. So R1 plus 1. So correct deposition. So CD plus 1. So bot is going to cross the obstacle once again, it looks like. So obstacle O1 cross successfully, so O1 plus 1. So it looks like it's going for like bonus points.
It's going towards R2.
So it's going to cross the ramp obstacle R2. So ramp obstacle R2 cross successfully. So R2 plus 1. So it's going for like more bonuses, obstacle bonuses.
Going to cross O2.
So it's going to cross the obstacle. So it crossed the obstacle O2 twice. So O2 plus 2. Cross once again. So O2 plus 1. End of the run. So now the team can go for their Viva. So in the meantime, Okay. So now we have our last team, 4076 from Symbiosis Skills and Professional University.
Not attached. Yeah.
These we have met from Android Studio.
Mobile app.
हाँ या मतलब सेंटर ऑफ मास को नीचे रखने के लिए ये यहीं पे हाँ
We tune like that. वो ऊपर रहे तो like better tune होगा सेंटर ऑफ मास एग्जैक्टली बैटरी में
हम लोग इसको
सेंटर ऑफ मास के ऊपर थोड़ा सा ऊपर में बेटर ट्यून होगा देन वी डिसाइडेड टू डू सो
और उतना नीचे ऊपर में कुछ ज़्यादा इम्पैक्ट नहीं पड़ा तो ऊपर में रहेगा तो तार भी कम रहेगा वायर्स एंड ऑल PID
So what was your basic guideline behind choosing the parameters of the PID controller? P large, P small, D large, D small, I large, I small. What kind of basic?
PID ट्यून कैसे हुआ ये पूछ रहे हैं P मतलब P तो P वही मतलब पहले P को बढ़ा रहे थे जब तक वो अपना उसके पास फोर्स ना हो जितना मतलब स्टेबल करने के लिए जितना फोर्स चाहिए वो देने के लिए पहले P बढ़ाए तो जब उसको फोर्स मिलने लगा तो फिर D उसको स्टेबल कर रहा था
नहीं तो P से क्या कमी महसूस हो रही थी? What did you go for?
खाली P रहेगा तो वो फिर गिर सकता है ना मतलब
थोड़ा हायर रेस्पॉन्स
क्या दिक्कत हो रही थी?
सर पहले P कम रहेगा तो वो बैलेंस ही नहीं कर पाएगा
ठीक
P एक ऑप्टिमल तक पहुंचा तो वो जस्ट बैलेंस कर पाएगा बाकी वो ज़्यादा मोशन होने से गिर जाएगा या फिर थोड़ा देर बैलेंस करेगा गिर जाएगा
तो आपने P थोड़ा सा और बढ़ाया तो
और बढ़ाने से वो फिर ज़्यादा रेस्पॉन्स करेगा तो आगे पीछे ऐसे ऐसे होने लग जाएगा
ओके तो तब आपने अगला क्या लगाया?
फिर I आएगा
I लगाया क्यों लगाया?
तो I वो जो रेस्पॉन्स है उसको कम कर रहा है वो इट्स जस्ट एरर को जो जितना
किस चीज़ की एरर है?
जीरो से जितना एरर आ रहा है वो प्लस हो या माइनस हो वो उसको कम कर रहा है
ओके तो कितना आई कितना बढ़ाया
तो
घटाया क्या किया?
आई एक ऑप्टिमल तक पहुंचेगा तो ठीक रहेगा अगर आई भी बढ़ाएंगे तो उसमें भी वो एक ऐसा मतलब ग्राफ ऐसे हो कि वो गिर जाएगा आई ज़्यादा
ऑसिलेशन
हाँ ऑसिलेशन बढ़ेगा विद टाइम बढ़ेगा और गिर जाएगा
तो आई को वहाँ पे रख दिया
हाँ वहाँ
तो फिर डी लाने की ज़रूरत क्या थी?
डी वो मतलब माइन्यूट्स जो रहता है ना थोड़ा बहुत उसको क्लिप कर देता है ख़त्म कर देता है स्मूथनेस लाता है
जिटर कम करने
हाँ
के लिए
वैसा कुछ
ओके ठीक है
इसमें 3 PID है ऐसे एक फॉर नॉर्मल PID टू कंट्रोल द पोजीशन
लीनियर पोजीशन
हाँ MPU
पेंडुलम का पोजीशन मतलब
MPU का डाटा से चल रहा है वो एंड दूसरा है एनकोडर से बैलेंस के लिए एंड दूसरा है एनकोडर का डाटा लेके स्पीड को कंट्रोल कर रहा है अगर स्पीड बढ़ रहा है तो वो उसको कंट्रोल कर रहा है मतलब पोजीशन PID है वो बहुत माइन्यूट सा सिग्नल्स दे रहा है मतलब उसका PID 0.00 समथिंग है उससे वो स्पीड जो अचानक से रैंडमली बढ़ के वो गिर जाता था कभी वो कभी ऑब्स्टेकल या रैम्प क्रॉस किया तो वो स्पीड अचानक से ज़्यादा होकर गिर जाता था तो वो अपने आप खुद उसको रिकवर करने लग गया एंड हाँ वो वेलोसिटी को कंट्रोल कर रहा है वो इट्स जस्ट कंट्रोलिंग द स्पीड ऑफ द बॉट हाँ
स्पीड कंट्रोल तीसरा
और तीसरा ऐसे बॉट कभी अगर अपने आप एक व्हील स्पीड था उसका तो स्ट्रेट में जब चलाता था वो थोड़ा सा टर्न अपने आप ले लेता था तो वो दूसरा वाला क्या कर रहा है दोनों का स्पीड को बराबर कर रहा है एक का स्पीड ज़्यादा एक का कम हाँ वो कहीं टर्न में जब फॉरवर्ड सिग्नल दे रहा हूँ तो वो थोड़ा सा जो टर्न होता है माइन्यूट सा वो ना हो इसीलिए हाँ वैसा कुछ उसका खाली हम लोग P को यूज़ में लिए हैं IND हाँ IND उसमें हाँ बस IND नहीं है
But the other two had all three.
और टर्न मारने में क्या करते थे आप?
टर्न में बस हम लोग एक तरफ जो कंट्रोल सिग्नल्स आ रहा है, एक वन व्हील में प्लस कर दे रहे हैं समथिंग, दूसरा व्हील में नेगेटिव में समथिंग कर दे रहे हैं, तो वो टर्न हो रहा है ऐसा।
तो मैं छोटा सा सर्कल दूँ 6 इंच रेडियस वाला, उसको स्मूथली फॉलो कर पाएंगे?
हाँ, हो जाएगा।
ऐसा जाएगा फिर टर्न मारा?
नहीं, हम लोगों के पास एक बटन है जो फॉरवर्ड के साथ टर्न करता है।
हाँ, because I saw that.
हाँ,
That was my question.
नहीं, अपना लाइक दिस कंट्रोलर
implemented 2 buttons.
सर, ये कंट्रोलर में ये 4 बटन है ना कोने वाला, ये स्मूथली टर्न करने के लिए।
So this thing you are saying about just the P controller, right?
Rotation.
That is because there was some mismatch in the motor speeds. So did you try to calibrate and correct for that?
वो हो जाता था करेक्ट, बाकी विद टाइम वो कहीं ना कहीं फिर से आ जाता था कोई सा मोटर
again. I see.
Due to hardware problem or something. फिर से आ जाता था.
Okay. And so you did not develop a model for this mathematical model. You did tuning. So how long did it take you to tune the gains? The 3 PIDs.
पहले तो खाली नॉर्मल PID था, तो उसमें हम देखे बहुत इश्यूज आ रहा है, एंड फिर उसको बहुत फिगर आउट करने के बाद हम लोग पोजीशन PID फाउंड आउट करें। तो
पहले जो हमारा जो लाइक PID था वो सिंपल एक पर्टिकुलर एंगल पे उसे बैलेंस करता था, नॉर्मल PID, बट व्हेन वी इम्प्लीमेंटेड पोजीशन कंट्रोल विद सो अ ड्रास्टिक चेंज इन कंट्रोलिंग, बिकॉज इट कंट्रोल्स एट अ पर्टिकुलर पोजीशन, इट कंट्रोल्स द एंगल. सो व्हेन द फर्स्ट नॉर्मल PID इज देयर, then if down slope changes slightly, then it will fall, because it can't manage angle. For managing the angle, we implemented the position control.
Okay. Now, so how long did it take you to tune the gains?
That's a very long time.
Very long time. Okay.
Yeah.
And then what is your gripper? You have this rack and pinion mechanism.
Rack and pinion. This like we saw multiple models on internet.
Okay.
But
I expected you to.
So we saw multiple models on internet, but we find that this, by implementing this, we can open our gripper so much. So when it's open wide, then it can grab the box. So like while grabbing the box, it can minimize the error. So at first we thought to open largely.
Okay. All right.
Practically a good solution.
No, then we find this is practically not a good solution.
Why?
Because
Not a good solution practically.
because here only one thing is moving. If both
No, but what will it do? You're telling me the what?
इसका आइडिया ये
What is the impact of that? Only one side is
when
moving.
one side is moved,
What is the effect of that?
then if box is here, then it will slightly drag the box, and it
Will
and
it drag the box or will it make the robot unstable? Suppose it's a very heavy box. Imagine
if
a huge box.
if there is very
much smaller in size, bigger in size than
Yes,
the
sir.
ये
robot.
सॉल्यूशन है कि हम
दोनों
उंगली
पार्ट को
एक साथ
मूव
पास
करेंगे. That is better solution.
तो वो वहीं पर उठाएगा, आगे पीछे नहीं करेगा वैसा, बाकी अब फिर टाइम नहीं बचा
Yeah,
था।
because this will have the weight concentrated on this side. It's a light box, it doesn't matter.
But
It's
it
feather.
takes it to center it finally when it picks up.
Suppose you have an object.
हाँ, बड़ा
long
ऑब्जेक्ट रहेगा
object.
तो
Suppose you have a 6-inch width object to handle
problem
this.
आएगा।
It will
Then
tilt on this side.
then this will cause
And
unstable
that is heavy.
in the box.
Yeah, then it will not.
Okay.
Yes, sir.
With the load and without load PID का constant बदला क्या?
सर
Slightly.
कैसे किया?
सर ये होता था कि जैसे अब मैं एक उठा रखा हूँ,
Moving with the load, sometimes without load.
सर अभी जैसे हाथ नीचे है इसका, लोड नीचे में पिकअप हुआ है, तो ये ज़्यादा ऐसे झटका नहीं मारता, एंड हाथ ऊपर रहेगा तो वो ऐसे ऐसे होकर चलता है, मतलब लाइक दैट।
किया क्या उसके लिए कंट्रोलर में कुछ
हाँ, मतलब PID को थोड़ा सा ट्यून करें तो वो मिनिमाइज हो पाए, बाकी अभी भी वो है।
बट एक ही सेम कांस्टेंट यूज किया था।
हाँ, मतलब ऐसा कि जो ऊपर जाने से भी थोड़ा सा मतलब मिड वाला PID दोनों के बीच वाला,
बैलेंस लिया,
हाँ वैसा,
कॉम्प्रोमाइज,
हाँ वैसा।
अच्छा
वैल्यू कांस्टेंट ही है।
हाँ, कांस्टेंट ही
जो अच्छा काम करता है, नीचे अच्छा काम करता है, उसके बीचों बीच।
हाँ,
we find a better solution for both of them. Thank you, sir.
Thank you, sir.
And lastly, for the designing part, we thought if it looked like a real mini bot, and it would be better, then we find put this so it will like cute.
It is cute.
Yeah. Thank you, sir.
Yeah.
Okay. So team, you can go for your exit interview. Exit interview. So we have our final team, 4076 from Symbiosis Skills and Professional University. Okay. Team, are you ready? Judges? Judges, are you ready? Okay. Scorers? Okay.
Run start.
Yeah. Timer starts.
The bot is going towards O4.
So bot crossed the obstacle successfully.
Again crossing O4.
So O4 plus 2.
Again crossing O4.
Okay. O4 plus 1 again. So it's going to pick its first block.
Moving towards B6.
It's going to pick its first block.
Picked up the box.
Correct pickup. So CP plus 1.
Going through R1.
So the bot is trying to climb the ramp obstacle. R1. So R1 cross successfully. So R1 plus 1. So it's going to deposit its first block to D2.
Going towards O1.
So bot crosses obstacle successfully O1. So O1 plus 1.
Box deposited.
Correct deposition. So CD plus 1.
Going towards O2.
Obstacle O2 cross successfully. So O2 plus 1.
Going towards B12 to pick up a box.
It's going to pick its second block. Correct pickup. So CP plus 1.
Going towards O2.
So obstacle O2 cross successfully. So O2 plus 1.
Crossing R2.
The bot is trying to cross the ramp obstacle R2. So it crossed successfully the ramp obstacle R2. So R2 plus 1.
Going towards ramp obstacle R1.
The ramp obstacle crossed successfully. So R1 plus 1. So it's going to deposit. Correct
Box
deposition.
deposited.
CD plus 1. So bot is going to cross the
Crossing O1.
O1 cross successfully. So O1 plus 1. It's going for its end of the run. End of the run. The team is going for the second round. Team ready? Judges ready? Scorers? Okay. Start of the run.
Run start. Going towards obstacle O4.
Obstacle O4 cross successfully. So O4 plus 1. Okay. Crossed again. So plus 1. O4 plus 1.
Picking box B6.
Correct pick. So CP plus 1.
Crossing R1.
Okay, the bot crosses the ramp obstacle successfully. So R1 plus 1.
Going towards O1.
Obstacle O1 cross successfully. So O1 plus 1. Correct the position. So CD plus 1.
Going towards obstacle O2.
Obstacle O2 cross successfully twice. So O2 plus 2.
Going towards ramp R2.
Ramp obstacle R2 cross successfully. So R2 plus 1 and 1 path penalty PP plus 1.
180.
So they are going to pick their second block.
Picked B12.
So correct pickup. So CP plus 1. Obstacle O2 cross successfully. So O2 plus 1.
Crossing R2 again.
Ramp obstacle R2 cross successfully. So R2 plus 1. They are going to deposit the second block.
Going towards R1.
Trying to cross the ramp obstacle R1. R1 cross successfully. So R1 plus 1.
Box deposited.
Correct deposition. So CD plus 1. Path penalty PP plus 1.
Crossed O1.
Obstacle O1 cross successfully. So O1 plus 1. Okay. You're going for the end of the run. End of the run. Team, you can go for your Viva.
You can just explain the construction here.
Tell us something about your design, mechanical design.
So we actually built the bot around the PCB that was given to us. We had to make sure that there was enough space for the battery, and we had to make sure that the COM, the center of mass, was lower for the stability purposes.
You can come slightly this side, so camera's there.
Okay.
Yeah.
And then this is our gripper, which is used for pick and place. We used gears here, the principle of gears, spur gears, and then we used a string mechanism for the up and down. This is where the IMU is placed.
A string mechanism for up and down.
Yes, sir. And we have the Bluetooth for the remote control, and this was for the servo so that there was less jittering. There was enough current supply.
So why is it taller on the top? Like, is it for the string? You could have made it shorter, right?
Yes, sir.
What was the reason for?
So actually we made it a bit taller because if it was shorter, the spring may or may not get enough tension and it might break off. So we needed enough tension for the string as well. and we had to make sure that there was no interference between components because we are using capacitors here. So if there was any interference in and around, it could cause issues.
So we wanted space between components.
Where is your IMU?
It's at the top, sir.
Far away from center of mass, is it?
Yes, sir.
So how correctly does it give you the actual dynamics of the bot? You know, you are trying to predict where the bot is. Now, bot is an extended object. You are lumping it, you know, somewhere, and you have to control it by your equations. How faithful would the IMU readings be to the motion of the bot? That's the question. What do you think?
So the point is if we change the position of the IMU, especially to the below portion of our bot, so we experience the difference in the PID values, especially due to the motor noise. So that was the reason.
Interfering with the.
Yes. So we were getting differences in the values. So when we tried playing with the values and shifted the IMU to the upper portion of the bot, we experienced a much better value in control.
So you used PID as well, not
Yes.
LQR. PID for what all controls?
So we have used 4 PIDs.
4.
Yes.
Okay.
4 PIDs, okay.
So
Okay.
one is for position, second one is for velocity, then it's for pitch, and one is for yaw.
Okay. But position and velocity, don't you think there's a relation between the two? So why would you need PID for both of them? Like one is already a derivative of the other, isn't it?
Yeah, so actually while moving we turn off the position PID. So the position PID gets activated only when the bot stops. And for that compensation we also included velocity PID. So
PI.
PID.
So not PID, not all 3.
All the 3. So actually it is to make like control the speed of the bot. So like it may not overspeed and fall off.
What I'm still not clear on is this is P and there's the position and the velocity, right? So you already have the position and its velocity available with you. So then why would you need a separate PID for position and a separate PID for velocity?
Yeah, so that
because the velocity itself is the derivative of the position, isn't it?
So while moving we turn off the position PID. Like we make the KP, KI, KD 0. So it's not like working while moving.
Oh, so you're switching between these two PID
Yes.
controllers. No, 2 of them are not active at the same time.
Yes.
Okay. So effectively there are only 3 PIDs working at any
Yeah.
time.
So you wait for the so when you switch, how do you switch? So once it stops and the velocity is 0, you go on to the other PID. That's where you switch.
Yeah.
Okay. And I see. And what are the other 2 PIDs you had for? You had totally 4, right?
Yeah. The third one is the pitch PID, and fourth is yaw.
Okay. And you are giving equal inputs to both the wheels.
Yeah.
Okay. And at all instances, including when you are going over the bump, it's the same thing.
Yeah, it's the same.
Okay.
Just while turning, we increase the speed of one wheel while decreasing the speed of other wheel.
Okay. Now other teams had some issues that there were some differences even when you are going in straight line, right? They felt that there is a turning effect that comes in because of some mismatch. Do you have the same problem?
Yeah, so that's why we implemented the yaw PID.
Okay.
So basically it corrects the like drifting, like bot drifts to the one side. So
Okay.
it corrects and make the bot go straight.
Okay.
So what is the error signal for your PID? What sensors give you that value?
It's the same MPU sensor.
So everything works with MPU. You are
Yeah.
not using position encoder. at
For
all.
position PID, we are using encoder.
Okay.
MPU.
I see.
Yeah.
Okay. So now you know you've got this pitch PID, which is you know for balancing and all, and then there is a separate position PID, right?
Yes.
Of course, when you're trying to balance the pitch, you will have to move the bot forward or backward in order to balance, right? If it's falling this way, you'll move backwards. That's going to change your position. So how are these 2 PID loops going to interact?
Yeah. So we are controlling the bot by changing the target angle. So initially the target angle is 0, and if we want to move forward, we set the target angle 1.5. And while like pressing the forward button, we turn off the position PID, so it won't interfere. And then the bot moves forward. according to pitch PID.
Oh, I see. So you are actually moving it forward by sort of setting the
Yes.
set point to be 1.5 degrees from the vertical.
Yeah, and while like crossing the ramp, we set additional 1.5, that is 3 degree. So it smoothly like goes up the ramp.
Yeah, this is a different way of.
So why do you choose this way of doing things? Because this actually mimics how human beings walk, right? They
Yeah.
walk by leaning into the
Yeah.
direction that they want to go. But why did you choose this?
Like it was easy for us to visualize. So like if you want to move forward, it's the only logical way. Like we find it more logical to set the tilt angle forward.
Don't
So
say only logical way. That's your way of doing it.
Yeah.
There must be hundreds of logical ways to do it, right? So you should be a bit more open-minded about it.
Yeah.
Say that
And
you got
also-
this idea and it worked for you.
And also the gravity also acts. Like if we set the board forward, so gravity acts and it moves the board forward also.
So I'd like to ask our friends from control systems here as to if they've encountered things like this or situations like this where this kind of technique is used.
Forward kind of where you're anticipating something and making changes a priori, sort of pre-adjusting.
I think folks who work on biped may be able to answer, who build bipeds, right, biped robots. Maybe they, because they try to mimic what, like what you said, human locomotion. So only that's where you find these.
Yeah, somebody told me human beings when they walk, they're permanently falling forward.
I see.
One more thing is when people grow older, the sensors in the feet get less accurate, as a result of which they cannot anticipate the right amount of movement to make and they fall.
Yeah.
That's another thing I read recently. Okay, anyway, interesting.
So one phenomenon I noticed with many of, not only your bot, certainly in your bot, but others, when going up the ramp, the bot will go up the ramp and then it will go back a little bit.
Yeah.
Why does that happen? Can you explain it somehow?
So like it's because of the manual control. So like I have to press.
Bring it back?
No, like there are two buttons, one to move forward and one to add the boost, like boost angle. So I initially like move the board forward with the forward button, then I take a pause, turn on the boost button, and then climb the ramp. So it's because of the manual intervention.
So how long did it take you to tune these PIDs again? Say you had 2, there's 3, now you have 4.
Yeah, it definitely took much time. Like because in the simulation we only use 2 PID, pitch and position. But while working on the hardware, we realized that it is not enough.
Okay.
So we had to introduce 4 PID, then tune 4 PID. So it took a lot of time.
And that's by trial and error.
Yeah.
You just use the, okay. Nice.
Thank you, sir.
So it's a tradition at the end of a theme run, we ask our jury members to comment on what they saw. So, Vivek, can we start with you?
Yes, yes, sure.
So a little bit of gyan for the
No,
assembled audience.
not too much, just 2-3 sentences. And first of all, congratulations to Professor Arya and his team. Okay.
Congratulations to them.
Yeah, meaning it's like team, all of you for this one more round of competition successfully held. Okay, and this time I was very happy that all of you had successful runs. Okay, so I don't know if the team was simpler or the teams were better. Maybe the latter, right?
Both, because every year we learn how to do it better.
Right. So that was very nice that there was no team which could not complete. All of them were able to complete this. And when we were having these discussions, this Viva question, there's so many nice, interesting ideas for everything. I mean, there's so many ways just the PIDs have been implemented. Right. The last person for the last team for. So all that is very nice. So on the designs were also a lot of creative designs, a lot of nice controller designs. The one thing I felt that was lacking was the modeling aspects. I think except one team, the rest of them did not try to develop mathematical models, it would make it a lot easier and lot more efficient, okay, if you had some simulation models that you could work on. So that's one thing I would say you can focus on to develop mathematical models for these systems. It will help you with your design, troubleshooting, okay, and also improve your control algorithms going forward.
So why don't you help us with that?
Well, let's see. You approach us and we'll see how it works.
Yeah, I think that's what we need.
Well, we can talk about it, sure.
Thanks, because this is something, is partly what you guys have achieved and partly what the team, because this is, we do it in the last few years because we realize that control systems is a core skill. And this balancing board thing is just, our challenge is how to pitch the difficulty at a level that is difficult enough but not too difficult and gives you enough design flexibility. So you see all these different kinds of bots. And something too easy also is no fun, right? And now you are giving some other core ideas that your mathematical modeling should be good. And I think that's where we need the help of our colleagues at IIT Bombay to get more of that theoretical flavor into this thing, so round you off to become even better engineers, right? Great, I think that's great insight. We'll take it on board. Thank you. Our other friend from control systems.
Yeah, I completely agree with what Vivek has just said. I mean, that's one of the things, right? If you have done a course on control systems, you would see the way we proceed with the courses. First, we have these modules on modeling, right? And once you have an idea of how to model a system, and then we go into this controller design and synthesis and analysis tools and other things, right? So of course, if you have a better model, if you have at least a better model than just a model-free approach that many of you have adopted here, you'd definitely be able to narrow down the control design to a much more feasible problem than just say throwing a dart in the dark and hoping that it lands you. I mean, some of them, like for example, one group probably said it took them some 5 to 6 months to design the right parameters for the controller, right? So that's one thing definitely. The other thing is I was really impressed. I've been coming here so often now, so every year I see this. It's really impressive, like, second year and third year kids here, they're just getting familiarized with, at an age when you'll probably just learn your first lessons in control. You're actually learning about LQR control, right? I remember the first time LQR control was probably introduced was during COVID, when we didn't have the hardware facility, so we said maybe we can ramp it up on the theory front a bit, and so we had this LQR. So yeah, I mean, and as far as your offer goes, like, if you need our assistance with any of those parts, I'm definitely up for it, right? I'm definitely interested, and it's fascinating for me to come here every year and see the way it has developed over the years, even during the last 7 years that I've been around. So it makes me really happy, and I'd be happy to contribute whatever little bit of gyan I can to these students here.
So I think this is an important point. Our style of teaching is different in the sense that in 6 months we got to cram all this experience. And that means that we've found that the most effective way is to throw a problem at the students, and they have to just get enough of the gyan to solve that problem, as opposed to learning control systems in a course and then, doing all that kind of stuff. So I hope this has motivated you guys now to learn more about the mathematical modeling part. How many think this is the way to go now, after having done all this, hit and miss, and so on? So you got some takers here, right? So hopefully from this bunch and the ones who passed stage 2, we'll try and get some interns across who can maybe work in your labs also, right? And see where it takes them. So Paritosh, perhaps?
Everything I wanted to say has been said. I can't agree more with my colleagues who said that, even for a problem which we in the lab thought was a fairly routine, straight-jacketed design, the variety and the innovative, breadth of solutions that people have come up with have certainly amazed me. I've been associated with this competition now for maybe over 10 years, and yet I keep getting impressed year after year. So I think you are all doing tremendous things. Can't agree more with the fact that, this kind of design, this kind of experience of doing things should drive you towards the more engineering-oriented principles by which you can make these designs more robust, more optimal, better functional. So this is your entry into the world of engineering. doing it like a coursework alone is not enough. You know, it's a very dry subject, exam oriented, raw feeding of information, not knowledge. This is where the knowledge begins. So I'm very happy you participated in this. The last thing I wanted to add was that, you know, it is not just the product that you exhibited here which is the outcome, it is the journey. And I think we didn't have that much chance to learn about your journey, although there is an interview afterwards, so we'll find more. Yeah, so I'm sure you have stories to tell about how you reached here, and I'm sure without passion, without involvement, you know, taking time off from your curriculum, from your social life, you know, interacting with all your colleagues, you know, I'm sure there were heartburns, there were fights, and then you came together. I think you have learned life lessons which are invaluable. So I think I envy you. That is what I would like to end with. Thank you.
So tea and snacks are available outside. So by 4:45 we'll start with the next theme probably.
eYantra complements the higher education system by bringing in a component of practical exposure through project-based learning. The eYantra lab setup initiative helps a college to set up a robotics lab and also trains the teachers and the students. Our unique lab in a box speeds up this entire process. eYantra provides training and a powerful network rooted in the innovation ecosystem of IIT Bombay to address issues related to training to build startups. The goal is to create a global community of innovators who collaborate to solve real problems in society in partnership with other people of similar interests. We've established over 450 labs across India and are looking forward to establish more such labs across the world. eYantra believes that our future lies in empowering young people to solve problems. eYantra believes that startups are a potent medium to solve real problems in society, and eYantra trains young people in future skills, helps them collaborate globally on our platform, and helps them solve problems to engineer a better tomorrow.
Revolutionary. eYantra is entrepreneurial.
For me, it's opportunity.
Living your dream life.
Accelerator.
Learning by doing. Fix any problem. Complete exposure. You get persistence. It helps me to see things more clearly.
This competition helps to open the minds of students. The college is all they know. Like, they don't know what's going on outside the state and all the other new developments that are happening. Coming to this competition not only helps them like learn about all the innovation, but also opens their mind to new way of thinking, and that might like change their career path. And the sooner that it is done, the better it is for the student. We came in our 4th year and we were thinking like if we came in our 2nd year, that would be better, because then we would have like 2 more years to like develop ourselves and like fix our career path much more better than we have now.
Part of the eYantra revolution. Learn, innovate, build, and transform the world. Welcome to the e-Yantra Robotics Competition, where we learn while we compete. This unique journey is unlike any other competition or traditional higher education system that trains thousands of students each year in robotics and embedded systems through project-based learning. Over 220,000 students have benefited from this experience over the last 13 years. Our theme this year is the 9th goal of the United Nations Sustainable Development Goals: industry, innovation, and infrastructure. Through hardware-based tasks, we explore various engineering skills to solve real-world problems modeled as themes. This competition is open to all college students in India and abroad, regardless of their level of experience. By taking part, you can win cash prizes, a prized internship at IIT Bombay, and most importantly, acquire the skills to engineer a better tomorrow. Registrations are open from August 1st to 25th. So join as a team of 2 to 4 members and embark on a 7-month journey guided by our team of experts. For more details and to register, visit our website at www.portal.e-yantra.org. Don't miss out on the early bird offers. So be a part of the e-Yantra revolution. Learn, innovate, build, and transform the world.
We are trying to emulate the story of the thirsty crow. So this is the crow with an arm mechanism, which is a rack and pinion attached to a servo. That is an Aruko marker, which is signifying a pebble. And that is the Aruko marker, which is signifying the pitcher. The camera reads all the points in the arena, and then we apply several filters in order to filter out only the node points which are required for our application. After we detect the vertex points, we calculate the shortest path from the bot Aruko to the pebble Aruko. The bot will follow left or right turns based on where its next path point is, and upon reaching the destination pose, it will servo forward and pick up the pebble and deliver it to the pitcher location.
We are presenting our bot Spotter Snake. The spot we have completely designed it from the scratch.
This is the vertical joint, so it is responsible for left and right motion. This is the horizontal joint, so it is used for linear undulation motion.
This is the linear undulation movement. As you can see, the front, the horizontal joints are moving it. Now this is the side undulation towards the left side. The vertical joints are moving.
I am working on the project Maze Solver. The bot first takes some time to calibrate all the sensor to adapt the environment. After pressing the button, the bot will start following an algorithm in which it will first give priority to the right one, and then it moves straight, then it gives priority to the left order, and eventually at the dead end it will get back. The bot have calculated all the shortest path available in that path. It will eliminate all the dead end and simply it take the shortest path that was available from the starting point to the end point to reach in the minimum time with minimum path available from the start to end.
e-Yantra made me realize that consistency is the key. I've always thought that engineering is nothing but books and grades, but e-Yantra made me realize that it's solving real life problems and making an impact in the society. If a problem was there in front of me, I would know how to solve it. I would search for the solutions. But e-Yantra made me realize how to first find out what is the problem. So my problem solving skills have improved greatly. We are from different backgrounds. We came here with different views, with different technological expertise, and we learned how to exchange knowledge, information. The first question every day morning, whenever our mentor came and interacted with us, was more like, what did you eat? How was your day? Is everything fine? Rather than only focusing on our project being done, they focused on our mental health also, so that we could have a peaceful landing in our project. If I need to start a startup and I need good people, I think I could pitch back to these people like, okay, this is my idea. Would you people like to join me? Today morning itself, I've given my interview. The eYantra tag in my resume added much more weightage. I think half an hour of my interview was completely dedicated on what project I did in eYantra and stuff related to eYantra, because people who are interviewing regard you at a different level. You would be a step higher than your peers who you are competing with in the placement rounds.
The e-Yantra summer internship is like no other internship I've ever seen.
Most internships want to get a project out of you. This is more of an experience. It is just surreal. You get to learn, meet a lot of people. Kaviarya sir is such an interesting person. He's always pushing us to be better.
eYantra is like a thali. It provides you a delicious amount of various technical and non-technical stuff. The amount and the level of which you want to consume, the knowledge which you want to imbibe in yourself is completely dependent upon you.
It's invaluable, whatever I've learned here, and can't get it anywhere else. I will always remember this experience. It will always be something that pushed me forward to become better.
Attention, teachers, parents and school students. Are you ready for a creative and transformational journey? IIT Bombay eYantra proudly presents the Inter-School Virtual Museum Competition for grades 6 to 12. This is not just a competition, it's a platform to learn by doing.
Students will master graphical and analytical techniques, research methodologies, 3D modeling, photogrammetry and much more.
Competition is completely online, running for 7 weeks with weekly live sessions, engaging quizzes and assignments, dedicated doubt-clearing sessions, discussion forums, and one-on-one connect.
Winners will be awarded with special prizes, a prestigious certificate from IIT Bombay's eYantra, and the top finalist will get an exclusive opportunity to participate in eYantra Symposium at IIT Bombay in April 2025.
All this for just ₹2,000 only. So what are you waiting for? Visit school.e-yantra.org and register for a journey that will inspire creativity, foster critical thinking, and equip your kids with the future-ready skills.
eYantra complements the higher education system by bringing in a component of practical exposure through project-based learning. The eYantra lab setup initiative helps a college to set up a robotics lab and also trains the teachers and the students. Our unique lab in a box speeds up this entire process. eYantra provides training and a powerful network rooted in the innovation ecosystem of IIT Bombay to address issues related to training to build startups. The goal is to create a global community of innovators who collaborate to solve real problems in society in partnership with other people of similar interests. We've established over 450 labs across India and are looking forward to establish more such labs across the world. eYantra believes that our future lies in empowering young people to solve problems. eYantra believes that startups are a potent medium to solve real problems in society, and eYantra trains young people in future skills, helps them collaborate globally on our platform, and helps them solve problems to engineer a better tomorrow.
Revolutionary. eYantra is entrepreneurial. For me, it's opportunity.
Living your dream life.
Accelerator.
Learning by doing. Fix any problem. Complete exposure. You get
Persistence.
It helps me to see things more clearly.
This competition helps to open the minds of students. The college is all they know. Like, they don't know what's going on outside the state and all the other new developments that are happening. Coming to this competition not only helps them like learn about all the innovation, but also opens their mind to new way of thinking, and that might like change their career path. And the sooner that it is done, the better it is for the student. We came in our 4th year and we were thinking like if we came in our 2nd year, that would be better, because then we would have like 2 more years to like develop ourselves and like fix our career path much more better than we have now.
e-Yantra Innovation Challenge is a competition that trains students in innovation and entrepreneurship. It nurtures young minds to articulate real problems in society and to solve them using technology. It immerses participants in problem domains and helps them articulate problems which then they solve and use the solutions as a basis for startups. It's a platform to showcase solutions to incubators and to build your dream startup. Guidance is by e-Yantra engineers and industry experts. So join us. Registrations begin on the 1st of September every year. So be a part of the e-Yantra revolution. Learn, innovate, build, and transform the world. Welcome to the e-Yantra Robotics Competition, where we learn while we compete. This unique journey is unlike any other competition or traditional higher education system that trains thousands of students each year in robotics and embedded systems through project-based learning. Over 220,000 students have benefited from this experience over the last 13 years. Our theme this year is the 9th goal of the United Nations Sustainable Development Goals: industry, innovation, and infrastructure. Through hardware-based tasks, we explore various engineering skills to solve real-world problems modeled as themes. This competition is open to all college students in India and abroad, regardless of their level of experience. By taking part, you can win cash prizes, a prized internship at IIT Bombay, and most importantly, acquire the skills to engineer a better tomorrow. Registrations are open from August 1st to 25th. So join as a team of 2 to 4 members and embark on a 7-month journey guided by our team of experts. For more details and to register, visit our website at www.portal.e-yantra.org. Don't miss out on the early bird offers. So be a part of the e-Yantra revolution. Learn, innovate, build, and transform the world.
We are trying to emulate the story of the thirsty crow. So this is the crow with an arm mechanism, which is a rack and pinion attached to a servo. That is an Aruko marker, which is signifying a pebble. And that is the Aruko marker, which is signifying the pitcher. The camera reads all the points in the arena, and then we apply several filters in order to filter out only the node points which are required for our application. After we detect the vertex points, we calculate the shortest path from the bot Aruko to the pebble Aruko. The bot will follow left or right turns based on where its next path point is, and upon reaching the destination pose, it will servo forward and pick up the pebble and deliver it to the pitcher location.
We are presenting our bot Spotter Snake. The spot we have completely designed it from the scratch.
This is the vertical joint, so it is responsible for left and right motion. This is the horizontal joint, so it is used for linear undulation motion.
This is the linear undulation movement. As you can see, the front, the horizontal joints are moving it. Now this is the side undulation towards the left side. The vertical joints are moving.
I am working on the project Mesh Solver. The bot first takes some time to calibrate all the sensor to adapt the environment. After pressing the button, the bot will start following an algorithm in which it will first give priority to the right one, and then it moves straight. Then it gives priority to the left order, and eventually at the dead end it will get back. The bot have calculated all the shortest path available in that path. It will eliminate all the dead end and simply it take the shortest path that was available from the starting point to the end point to reach in the minimum time with minimum path available from the start to end.
e-Yantra made me realize that consistency is the key. I've always thought that engineering is nothing but books and grades, but e-Yantra made me realize that it's solving real life problems and making an impact in the society. If a problem was there in front of me, I would know how to solve it. I would search for the solutions. But e-Yantra made me realize how to first find out what is the problem. So my problem solving skills have improved greatly. We are from different backgrounds. We came here with different views, with different technological expertise, and we learned how to exchange knowledge information. The first question every day morning, whenever our mentor came and interacted with us, was more like, what did you eat? How was your day? Is everything fine? Rather than only focusing on our project being done, they focused on our mental health also, so that we could have a peaceful landing in our project. If I need to start a startup and I need good people, I think I could pitch back to these people like, okay, this is my idea. Would you people like to join me? Today morning itself, I've given my interview. The e-Yantra tag in my resume added much more weightage. I think half an hour of my interview was completely dedicated on what project I did in e-Yantra and stuff related to e-Yantra, because people who are interviewing regard you at a different level. You would be a step higher than your peers who you are competing with in the placement rounds.
The eYantra summer internship is like no other internship I've ever seen.
Most internships want to get a project out of you. This is more of an experience. It is just surreal. You get to learn, meet a lot of people. Kaviarya sir is such an interesting person. He's always pushing us to be better.
e-Yantra is like a thali. It provides you a delicious amount of various technical and non-technical stuff. The amount and the level of which you want to consume, the knowledge which you want to imbibe in yourself is completely dependent upon you.
It's invaluable, whatever I've learned here, and can't get it anywhere else. I will always remember this experience. It will always be something that pushed me forward to become better.
Attention, teachers, parents, and school students. Are you ready for a creative and transformational journey? IIT Bombay e-Yantra proudly presents the Inter-School Virtual Museum Competition for grades 6 to 12. This is not just a competition, it's a platform to learn by doing.
Students will master graphical and analytical techniques, research methodologies, 3D modeling, photogrammetry, and much more.
Competition is completely online, running for 7 weeks with weekly live sessions, engaging quizzes and assignments, dedicated doubt-clearing sessions, discussion forums, and one-on-one connect.
Winners will be awarded with special prizes, a prestigious certificate from IIT Bombay's e-Yantra, and the top finalist will get an exclusive opportunity to participate in e-Yantra Symposium at IIT Bombay in April 2025.
All this for just ₹2,000 only. So what are you waiting for? Visit school.e-yantra.org and register for a journey that will inspire creativity, foster critical thinking, and equip your kids with the future-ready skills.
Good evening everyone. Myself Hari Vignesh. Welcome back to the last theme of today, that is Eco-mender bot. So I would be briefing about the Eco-mender bot now. So yeah, so what is the aim of our theme? It is to build an Eco-mender bot that you see in front of the stage. And that what it can do, it can smartly traverse the arena that is depicting to the left. We will also see in the screen. What it does, it will identify, communicate and resolve the problem in various units in the arena using an FPGA. Not just that, we have some more. Let's go through that slowly. Yeah. So what are the major learnings for the students in this particular theme? First thing, how to work around with the FPGA, then how to program the FPGA in the Verilog HCL, then design a RISC-V CPU design, RV32i, pipelined or single cycle, and then they need to also implement a path planner like Dijkstra, A star, D star, or whichever BFS, DFS, whichever they prefer. Apart from it, they also need to work around with how to parallel process in the FPGA so that they can maximize the FPGA's potential. Apart from it, they also design their grippers and build the board from scratch. Apart from it, we also have component interfacing like color sensors, servo motors, and then UART communication with parity for communicating through the Bluetooth module with the laptop. So these are the major learnings from the theme, and the main tools that are used is the Quartus Prime, Model Sim, and then RISC-V tools. So in terms of environment, let's first go through the arena. So what you see to the right is the arena with the finale configuration. So if you can see, this arena has 3 sectors on the top, which is called prototyping unit, fabrication unit, and waste management unit. And inside each unit there are 3 subunits where there might be problems occurring. If there are green patches, which means there is no problem on that particular subunits, and if it says red or blue, it has some problems, and the Eco-mender board should be rectifying those problems based on the Eco-center. Now what is Eco-center? We will go through it next slide. Before that, how the Eco-mender board is built. So the main powerhouse of the Eco-mender board is the D0 nano board. Apart from it, we do have a line following sensor, 3-channel line following array sensor, digital IR sensor to detect obstacle and packages, Bluetooth for communication, servo motors, and then N20 motors, and then LEDs for indications. So in terms of GUI, we have a similar structure GUI where it will basically the bot will communicate between and forth between this particular GUI. So whatever messages you are seeing over this particular area are message sent from the FPGA Bluetooth, and then whatever you would be seeing on this particular blocks is basically sent from the GUI to the bot. So these are the major things from the Eco-center to complete the task. Yeah, going ahead, let's watch a theme film. Okay, that is about the theme film. It showed one of our task 6 bonus configuration run. So coming to the scoring parameters, one is scorers scoring parameters. Those should be handled by our e-Yantra internal members. Those actually evaluates what is happening on the arena, like is it actually doing the job it's properly, like indications, MIL, SIL and RDL. and then physical events like does it validly pick and place it, those are the other parameters. And then there are message parameters also like SLM, like identification, like sustainability level message, resource pick message, and resource deposit message. So whatever parameters on green gives the marks, whatever parameters on red reduces the marks, and then the B is the bonus marks. So what is HI and penalty? HI is whenever they touch the bot to, let's say it moves out of the line, whenever they touch the bot, they will incur an HI. And then penalty, when it collides with something on the arena, they will incur an penalty. So that is about scorer score. And judges score, it should be on robot design. How did they come up with this particular grip pair or this particular configuration of their bot? And then how their understanding on the CPU design, basic RV32i CPU without memory hierarchy or OS. So that is there. Apart from it, how did they implement their theme? Basically, how did they communicate between different modules to complete the entire theme? Did they go different modules, like let's say for color sensor they are going to do separately, and then how they are going to put together to solve the task. So these are the things judges score. And then credits, team developers, myself Hari, and then my another team developer Ramdas, and then special thanks to Gaurav, Madhu, and Shama, Jason, and Sachin sir for leading eYRC, and then office and inventory team for helping us. So thank you guys. And then of course we like to thank our funding. So our Ministry of Education is funding for a lot of years, so thanks for them. And then of course our beloved dear Professor Kavi Arya sir. And then going on team e-Yantra for all our help. And then going ahead the show. Thank you guys. Let's get started. Before that, may I call upon Professor Kavi Arya sir to introduce the judges.
My pleasure again. We got some special friends here to be jury members. Jury members are less for being judge and jury than for appreciating what you guys have done, for kind of celebrating what you guys have done, right? And they are in the best position to actually appreciate, and you should thank them for that. So we have Professor Patkar, Sachin Patkar, if you can give them a bow, just show them who you are. He's an MTech from IIT Madras and a PhD from IIT Bombay in computer science, and done lots of things all over the world. He is a fellow of Alexander von Humboldt Foundation at the Research Institute of Discrete Mathematics at the University of Bonn in Germany. He is a professor of electrical engineering here now, and his research is in combinatorial optimization, high performance computing, algorithm design and analysis, and graph theory, and all these kind of things. Essentially a mathematician who's lost his way and ended up in the electrical engineering department. Okay, and we have Professor Virendra Singh. Sir, he's a prof in electrical engineering who's lost his way now and come to computer science department, so he doesn't know where he belongs, and we also don't know where he belongs. But that's the story of many of our faculty here, and his research area is cyber security, computer architecture, process architecture, microarchitectures, and all those type of things, memory system design, FPGA based acceleration, and all these things. So he's a PhD from Nara Institute of Science and Technology and Kansai Science City in Japan. And he did his ME originally from Malviya National Institute of Technology in Jaipur. So thank you, sir, for being here with us. Then we have Professor Mariam. We guide some students together. You can give us a bow. She's, I call her exotic because she's from Iran. And there are very few people here that I know from Iran, and it's a pleasure to work with her. So she's a faculty in Department of Electrical Engineering here, and a PhD and MS both in electrical engineering from Sharif Institute or University of Technology. That's Iran, right? Where exactly? In Tehran. Okay. And her research area is circuit and system design and integration for intelligent sensing, processing, and problem solving. We are guiding a PhD student in the area of pest prediction right, using embedded systems and IoT systems and things like that, which has got some interesting elements. So her area is analog and mixed signal VLSI design and related stuff, including data analytics and signal processing and all these kind of things. She's particularly interested in energy harvesting and power management circuits and systems, and high-speed data transmission and interconnects. And yesterday we had a very interesting conversation because Professor Ian Page described a company in the UK which makes sensors, temperature sensors and other things for indoor use, which harvest ambient light to power themselves, right? Which is a pretty cool idea. That means you don't need batteries, you don't need anything else, it just harvests ambient light, which shows where interesting IoT systems are going now in the future. We have Madhura Purnapragna here. Take a bow, ma'am. Who's a research associate in Indian Institute of Science some years ago. She's been a postdoctoral fellow at EPFL in Switzerland. She's a professor in the Center for Heterogeneous and Intelligent Processing Systems at PES University in Bangalore. And her research area is design space exploration towards next-gen parallel and customizable computing, novel architectures like this, and so on. And she incidentally also worked in our lab many, many years ago before she got the inspiration to go off and do a PhD. So welcome. She also works for Xilinx now, right? So I don't know where you work now. Is it PES or Xilinx? Xilinx. Okay, good. And we have Rutuja, who's our own e-Yantra alumnus. She came to us through the competition like you guys. Then she was an intern with us. Then she was project staff, and she very responsibly and capably managed a lot of things in e-Yantra, including the competition for the last 2 years, right? And she's also registered for a PhD here with Professor Madhav Desai and myself, and has done some excellent work on compiling programs in Python to RTL. That means creating hardware by writing a Python program. So building the compiler for that. And we are seeing very exciting possibilities for that because India has a huge need for chip designers. And chip designers are very difficult to train in the conventional manner where you need to make them think at the level of registers and flip-flops and VHDL and Verilog. Won't it be nice if I can take a software engineer and use software engineering principles to build a chip? And that's what Ian Page should be speaking about tomorrow, because that's what he's been doing. He's done 30 years ago, right? In a language called Handle C. But that's another story. And Rutuja's been with e-Yantra since 2014, right? And her research areas are embedded systems and compilers and FPGAs and things like that. It's wonderful to have her here with us. She's with GE at the moment in Bangalore. We are hoping that she'll come back soon and finish her PhD. Okay, so there it is. And Professor Ian Page, you briefly got introduced to him. We'll give him a long introduction tomorrow. He's my PhD advisor from the University of Oxford, and he's been a serial entrepreneur. He started a very interesting company called Siloxica, which had this Handle C to RTL flow way back in the late 90s. Work which was really ahead of its time. And he's also director of ChipFlow, a company that takes Python and gives you RTL. So we are having some interesting discussions here. And apart from, most importantly, he's a big fan of e-Yantra, well-wisher. So this year I thought, why not have him here to just experience everything, right, in detail, and then have some interesting conversations about it. So without much ado, let's launch into the theme. Over to you.
Thank you, sir, for the introduction. We would be starting with the team 4051 from IIT Bhubaneswar, Banaras Hindu University. So team 4051, please come to the stage with your bot. We will set it up quickly and start the run. So, scorer ready? Judges? Scorers? Judges? Sir? 4051. Team ID is 4051. Ready? Siddharth? Ramdas will tell 3, 2, 1 and then he will say start. Also he will press. Okay, two information more. Timer and score will not display neither time nor score. Okay, for the participants. You tell me 3, 2, 1. Ready? Judges ready? Scorers ready? Okay, I will select it. 3, 2, 1, start. So Eco-center sent the first message. It is showing on the display. It found the obstacle. It placed back the obstacle. So it detected the first color plus SAL1. Second color detected. Third color detected. SAL total count 3. First pick valid. RP plus 1. Heading towards the maintenance unit. Collision 1. Penalty. So RD valid. Heading towards the second unit. First unit resolved. So scanning second unit. First SAL plus 2. SAL plus 3. So SAL total 6. And then trying to rectify the SAL for the second unit. Second pick valid. Second deposition valid. End of run. So it is a one with one penalty. It is end of run within. Okay. Do you guys want to do second run? Okay. Keep it back. Keep your robot back. Restart the GUI. Yeah, we'll keep it back. Okay. That's right. Cool. Reconnecting through GUI. This particular GUI is made by us, and the whatever backend script is running is made by us. The messages is validated in the Eco-center, and then only appropriate messages are sent it back. So everyone ready? Judges and scorers ready? Ramdas, wait. 3, 2, 1, start. So received a valid. First color not detected. Second color detected. So restart. It does as the bot didn't detect one color. You want to restart? Restart. End of the run. So this is the end of the run. So both the runs are done. You can go for Viva. You turn off the bot and take it. Okay, thank you guys. The next team would be 1041. Please come to stage. Yeah. You want to? We will not place it, but we will not place it. Okay. Which?
No.
All right. So, what's your opinion? How was the run? First one, second one?
Second one, it was like it couldn't detect that color, green color, because of that it has stopped here. First one, the only thing is obstacle. It has to be dropped in forest area.
Yeah. So, did you realize why that happened?
Yeah, the battery is charged to the highest, and because of, it has to rotate for a certain amount of time. to drop into the forest. But due to the high voltage of the battery, it has rotated a lot.
Speak in the mic.
It has rotated a lot amount so that it dropped on the white light itself.
So why did it not detect the obstacle first time?
It has detected the obstacle, but it couldn't drop into the forest.
Why was that?
Yeah, it couldn't drop into the forest.
Yeah, why did that happen? Could you?
Actually, the battery is charged to the highest, and due to this, what I do actually is whenever it encountered obstacle, it has to drop by rotating for some amount of time. And due to the highest charging of the battery, it has rotated a lot amount of time, like a lot.
Actually, we know that the velocity of the angular velocity of the motor directly proportional to the voltage applied to it. As the battery voltage is more than the nominal, so for certain amount of time we rotated the motor, but due to higher amount of voltage, it rotated with a higher speed. So it go to a large path. So it rotated highest, and it should put the obstacle in the forest, but because it rotated a lot, so it put that in the before of the path. So why it detected? Actually, it detected the obstacle, but it put the
Tree. And for how much voltage did you check, or did you run the
actually
test?
the nominal is 7.4, but the before testing we tested with another battery which voltage is below the 8, but after charging we placed another battery which voltage more than 8 volt. So
Logic analyzer, for which we can have waves and we can check the waveforms. So it helps to debug. And regarding the hardware, we use multimeter and all these things to check whether the voltage output is correct or not. And most of the logic is written by me, so I can understand whether it happened correctly or didn't happen correctly.
So logic is one thing. Another one is the processor. Processor might not have been correctly designed.
Yeah, that was done by I use signal type logic analyzer to debug that thing.
That whether the processor is working fine or not.
Yeah.
So where you will check. So there are so many instructions, right, which are running, and somewhere it will fail, and you are not keeping any log of this. So how do you check whether that has worked well or has not worked well?
Basically, it has a output port reset. So what I used to do is I used to run the PC up to a certain value, and I used to reset again. So I used to run in a loop so that I can check each and every instruction.
You said you have designed pipeline.
Yeah,
So
right.
how many pipeline stages?
5 stages.
5 stages. Why 5 stages? Why not 3 stages? Why not 4
5
stages? So
stages, like-
was there any reason to design 5 stages?
No any reason, but I think because of adding registers, it can run at more higher clock frequency.
So at what clock frequency your processor is running?
50 megahertz.
50. Okay. So if you, so then what are those 5 stages were?
Like fetch, decode, execute, write memory and write back. Decode, execute. Yes, memory.
Okay, did you do any course on computer architecture before this one,
I
or
used-
just you learnt while you are doing this, you were doing this project?
I usually listen to NPTEL lectures, so that helps. No other lectures.
Questions? You have some questions? So my question is about how does this CPU communicate with the control center? Is it a relevant question? Yeah, how does the CPU communicate with the control center?
Here CPU is just used to fetch the path. So it will have a controller, and the controller will give the starting point and the ending point. It will fetch the path, and it will be written into a certain address in the data memory. And by fetching the path from that data memory, like we can read that from the external port of the processor itself, and by storing in the queue, we have like we have planned the path and directions that has to be taken by the bot.
So your UART is configured at what baud rate?
96.
Is that part of the design or not?
Yeah, it is.
So you said that the turning actually failed, right? And you are turning blindly. That means based on time. So if your battery voltage is high, it will turn more. Battery voltage is low, turn low. So can there be any feedback-based turning you can implement? Have you thought about it?
Actually, that motor we are using, there is no encoder. If there is an encoder placed in the motor, we can measure the position, so that we can run that in closed loop.
Okay. And the lines are also there. Everywhere it takes the blind turn, or only while putting the obstacles only it takes the blind turn?
No.
Only for the obstacles it takes.
Okay. Other way around, you don't take the blind turn. So how the turning mechanism works there?
I mean, it's node.
Yeah.
At the node, like if it encounters a node, it will move forward for some amount of time, and depending upon the direction, it will come onto the white. If it is right direction, it will come onto the white, total white from line, and again it will try to track the line.
Okay. Okay. So that is the feedback. The line is the feedback, right?
Yeah.
Okay. And the second thing you said that the 5-stage pipelining you have implemented to actually increase the clock frequency, right? So have you tried with the single cycle also? What was the frequency for that?
3.125.
3.125.
Yeah.
Last question. Why is it 50 megahertz?
Because the highest frequency that we can get in this FPGA is 50 megahertz.
In the FPGA?
I mean, if you use PLL, I think we can get, but I'm not tried to use that.
PLL?
Actually, I did not try it with higher frequency than 50 megahertz.
So you said it went up from 3 megahertz to 50 megahertz, right?
Yeah.
What changed from 3 to 50?
Clock frequency is like more than 15 times. It has increased by 15 times.
Okay.
If you make 5-stage pipeline, it cannot go 15 times. There is something wrong somewhere.
I would like that. So the D014 we provided this clock has an external oscillator of 15 megahertz, and it is not allowed to scale the frequency up. They can reduce the frequency if required.
When you make single cycle, there cannot be 15 times difference between single cycle and 5-stage pipeline.
So basically,
the max speed up that you can obtain is 5 times.
Right.
It would be less than 5 times.
So
somewhere there is something wrong.
3.125 we intentionally reduce the single cycle speed, like we gave pre-configured clock rate of 3.125. We suggested them to use from there, and you can increase till basis fails, then you can switch off the frequency or stop increasing the frequency. So 3.125 is just running on the base. If they want, they could have increased till whichever point it is. Let's say 10 megahertz it can reach. They can go till 10 megahertz for single cycle.
You should have tried, because when you synthesize it, tells you that what frequency it can run mostly. But then you need to look at it.
So yeah. Okay. Done. So done. Okay. 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 In the meantime, the next college is 1041 from BMS College of Engineering, Karnataka, right? Yeah. So GUI start. Yeah. So bot powered, connecting to the BLE and mic. No, where is one your mic? So scorers ready, judges ready. So on count of 3, update the arena. Okay. So team 1041, right? So 3, 2, 1, start. Guys, go ahead.
The obstacle is detected. It's placing it in the forest area. Place successful in the forest area. Going to scan the prototyping unit.
Valid detection SIL +1. Second valid detection SIL +2. Mess the color. What do you plan?
Restart.
Restart. Okay, restart. They opt for restart. Timer should continue. So we should reconnect the Bluetooth as well. So let's reconnect the Bluetooth and then we will restart the run. Timer will still move on. So penalty +1 for the restart. So SIL, SLM, like all the SILs will be set back to 0. It is a fresh run but with extra penalty and the timer is still gone. Yeah, update the arena, start the run. MIL +1, +2, +1, MIL +2 total. Obstacle cleared. Color detected. Color detected. So SIL +2, SIL +3.
Yeah, the resources pick.
Valid pick. RP +1.
It's going to place in the maintenance unit.
Valid deposit. RDL +1.
Going to scan the waste unit.
SIL +1, +2, SIL +3.
Going to pick the resource in the storage unit.
RP +1. RD +1, RDL +1. So end of the run. So you guys want to take the second run? Second run. Research UA. Yeah. MIL2, MIL2. Connecting to the Bluetooth. So in the meantime, you can introduce yourself if you want, right?
Yeah, I'm Rohit Kashyap. I'm from BMS College, EC department, and third year, studying in third year currently. And this is Rohit Kadak, Selokumar, and Shamant. We three are from EC department, and he is from CS department. And yeah, now we are ready for the second round.
Okay. The second run scorers ready, ma'am, right? Judges ready. So on the count of 3, 3, 2, 1, start. So sending first message, MIL +2. Obstacle cleared. First direction valid. Sorry, SIL +2. Okay. SIL +3. Okay, sorry. SIL only 2. SIL only 2. RT plus 1, RDL plus 1, even RP plus 1. I missed that. So LEDs are reset. SIL plus 1, SIL plus 2, SIL plus 3, total SIL is 5. Valid pick, RP plus 1. Valid deposit, RD plus 1, RDL plus 1. Only one note, SLM it is 5, not 6, and then no bonus, as they detected one color before they actually detected the color, right? End of the run. End of the run. Thank you. The next team would be team 3699. One more thing, after your Viva, you should go for the exit interview.
Yeah, so good, nice. Why it was stuck first time?
Sir, the map which we had used in the our house was completely different, which we had over here. So the color sensors had.
That was the idea, no? That map.
Yes, no, the color sensor
should work on other designs. Huh?
So the white color over there and white color over here was little different. So the color sensor calibration was the main issue. That's why in the second
So
time also,
how you identify that what has gone wrong?
yes, we have to debug using the signal type analyzer which we have.
This was not responding well, right? You had to reset. So then, which unit? How you check what has gone wrong? Whether processor has gone wrong, or interface has gone wrong, or your color sensor has gone wrong. What? So how do you do that?
Sir, actually the color sensor logic what we have used to eliminate the white frequency, sir, that actually what's different for the map which we have used there earlier, but here it's not reflective. What the map which we used was reflective. So that was the main issue which we faced coming here, and we tried to rectify that issue as far as possible. And you can see there's a border actually given to that color patch. If the black line is visible, then there's a transition time between white, black and the red. At that time there's a different color being reflected, or that color it detects and it emits. We have to eliminate that particular thing, which we couldn't do it due to the time and lacking thing here. That was the issue. We tried to eliminate it as far as possible.
So what kind of processor you have designed?
RISC-V
single cycle. At what frequency it is running?
3.1.
But why it is running at 3.125? That's why your this one is slower, right?
Yes, our all modules were in 3.25 megahertz, so that there won't be any.
Did you check at what frequency it is capable to run? 3.15 is the lowest one they kept, right? So why you kept at lowest one?
So because to eliminate the clock domain crossing CDC issues from all the issues, sir, the main issue was the servo motor which was running in the 50 hertz. So this was in 3.25, so we wanted to avoid clock domain crossing as far as possible. So all our controllers were in 3.25 megahertz. So even CPU we took it as 3.25 megahertz. And
but you don't need to. It can be multiple of that.
So but for
that's very easy to deal with that. And always whenever it is crossing, like your CPU is not directly talking to your servo motors, right? It is talking through some interface, and at interfaces you are having the register, so it should not create big problem. Okay.
So you took the default CPU and you implemented the line follower and the exchange of information, right?
Yes. We built the controllers for the.
Yeah. So what was the most challenging part?
The LFA tuning.
Tuning of the LFA part, which I personally felt, because I took over that particular thing, because we priorly didn't have any experience towards this line following, which was my first year I participating in this competition as well. So like the board design, first of all, we placed the line following sensor in the middle. We didn't have any idea regarding like where should be placed. Then after a failure of multiple times and weird behavior of the bot, then we came to a conclusion that placing it in front of the caster wheel can improve and increase the decision time for us to make some proper decisions to eliminate the cases. And that's where we come across some good logic, which I feel.
So it's the position of the sensor, right?
Yes,
not the line following. Line following didn't have any problem. Sensor
yes,
data
sensor.
capture.
The logic was good. Yeah.
Okay. What else? Anything else was challenging?
Actually, to debug from the controllers were most challenging. So we had to put LED, and for each compilation, it used to take like 8-10 minutes. So we have to check where the issue is coming. We used to assign each register wherever we required an LED, and if it glows, then there was an issue, something like that we had to take. So that was the major issue in controllers. And also, while going for the second unit, right, we have to reset everything. And while resetting, the old previous value will go off. And resetting is done from the servo mode. So based on that, both are different frequencies. So we had to match that as well. So that was the major issue.
Which of you were involved in the RISC-V processor design using the Verilog? Was it just one of you or all of you?
We had segregated each of us in different.
Oh, okay. Well, can you explain how you did that?
He was doing about this RISC-V and something, and he was the LFA. I did the servos thing and the integrating board and everything. He was the one who was guiding us with the path planner of logic.
Yeah, I was asking about the processor itself.
Oh,
the
RISC processor.
Yeah,
okay,
yeah. You too. Okay.
Yeah.
Right. Can you perhaps explain how you divided that task between yourself and how it went, and was Verilog a good environment to do it in?
Sir, actually, first of all, like we understood the basic concepts individually and tried to solve the problem individually, and wherever we encountered the problems, we discuss and solve the problems at that point.
Okay.
The problems what we did individually, sir, actually.
We did it individually, both of us. So whoever was getting whatever issues, we used to
discuss, yeah.
Okay.
Single cycle there is a easy partition, data path and controller. Controller.
Sir, we did the complete CPU individually, both of us, sir.
Did your designs differ very much to integrate them? Was
No,
that
sir, it was
straightforward?
it integrated. It came to the same thing at last.
Okay.
Thank you.
One question is, why did you choose this model of the grabber? It's kind of different from others.
Yeah, basically we had a different gripper also before.
Okay.
We have done a generic logic for everything, for everywhere, wherever, even in the curve path, there's very difficult time to read the IR sensor.
Okay.
So the distance is very near. The gripper was very weird way to handle. So we designed in this way at the end moment, so it can go even at the curve path and then at the nodes also.
Okay. No, I meant with respect to the length of the gripper.
Yeah, even if the far field, even if the LFA, if it fails to reach the exact point, but it reads, it still is going to fix the block.
Interesting. Okay.
Last time I asked this question about UART, so I would ask the same thing to you. So what kind of baud rate and configuration was being used for UART?
2, 3, 4.
Okay. And
3.1.
And what was the need for clock domain crossing issues?
Because servers working at 50 hertz, so our main CPU was working and the controllers, everything was working on 3.125. So to initiate that server, we have to send a signal. So it's not going to catch the signal at the same time. And whatever the signal is coming from the fast clock to slow clock, it's going to have an issue. So we had to implement a CDC there. So that's.
And the UART receiver code, did you write on your own or was given to you? It was you wrote on your own. So how much was the oversampling?
So actually, first of all, like when I did the receiver part in the simulation, I actually didn't face any issues, sir. Like because I actually sampled that point at the end of the duration, like for 23rd or 24th cycle. That was actually the end of the transition. So that I shouldn't have done, but for the sake of simulation, which I did, that passed as well. But that issue I figured out at later part in the hardware, where I didn't get the proper output in the hardware. So I figured out I had to sample the point in somewhere in between, so that I'll get the proper output. So since we didn't have any noise interference, so the issue was during the samplings, which I sorted out later. Thank you.
Okay. Cool. So yeah, then let's move on to the third team of the day, 3699 from National Institute of Technology, Tiruchirappalli. So we are connecting with the Bluetooth right now. So yeah, in the meantime, some more complication on the theme is their path planner algorithm. So basically, we only gave a memory space of 64 words. So one word is 32 bits. So basically, they only have 64 words, and then we also reserved 4 memory addresses for us to verify their generic design across all the themes. So only they are left with 60 words now. And if you can see, actually almost 32 nodes are there in the arena. So at least one word for each node will occupy 32 more words. So potentially they are left with less than 30 more data space. You can also ask how did they manage their data space so that they can implement the path planner, let's say the extra, A star, anything. So that is our some more complication on writing path planner. So going ahead, scorer ready, judges ready, update the arena, right? On the count, ready? 3, 2, 1, start. Eco-center initiated, send the message. Obstacle detected, obstacle failed. Penalty +1, penalty +2. SIL +1, SIL +2, SIL +3. Penalty +3, sorry, +1. RP valid. P +4, P +1. RD valid. HA +1 human intervention. RTL valid, I missed it. SIL +1, +2, +3. So 3 SILs, so total 6. RP +1. RD +1. RDL +1, end of the run. Okay, second team run. So second team run will continue. Reset what guys? 6. Everything's fine. Yes. Connecting with the device. So update the arena. Second run, scorer ready. 3, 2, 1, start. MIL plus 2, penalty 1, penalty 2, SIL plus 1, SIL plus 1, SIL plus 1, SIL total 3, penalty plus 1, RP plus 1, penalty plus 1, RDL 0, RD also 0, it's not a valid deposition. Heading to second unit. SIL plus 1, SIL plus 2, SIL plus 3. Valid pick. RD plus 1, RDL plus 1. End of the run. Thank you. SLM 6. Next team 3408 come to stage.
So good. So why it was failing both the time picking up the obstacle?
Actually,
both time it failed.
Yeah, actually we forgot to notice that our gripper have came off little bit.
But it was not able to properly catch that, right? I think there was some problem.
Yeah, it is
some different problem.
slippery. It is little slippery.
So you know this area is very small. That's why it was not able to pick it up, and that's why it went.
But it has picked well the other obstacle again. Yeah, second one was slippery. Yes, of course. So again, I will ask same question. When you find such kind of situation, how you debug that? What might have gone wrong?
We have
there are a
used
couple of things, right?
STL to STL.
Initially, we faced many problems. We debugged using signal tap processing, so it's an inbuilt thing in
Signal
Quartus.
tap you can do only processor, right? Other than processor, because problem may not be of processor, or it may be of processor.
Sometimes we had issues with the Verilog code itself.
Right. Yeah. There may be issue of Verilog code,
So
or there may be issue of your path follower, or maybe it is running faster or something like that, right? So how you figure out that?
we basically build the logic, overall logic to implement the theme. So we know where it might have gone wrong. And additionally, using signal tap processing, it was a bit easier to debug.
So processor, how you verified that your processor is correctly implemented?
The eYantra team gave a test bench code to verify whether the process is working well or not. So our
that test bench was provided from
yeah,
you.
like to verify whether the processor is performing all the ALU functions.
So what kind of processor you have designed?
RISC-V 32-bit processor.
Single cycle.
We have implemented both single cycle and optionally
what frequency it was operating?
50 megahertz.
50.
Yes.
Single cycle.
Sorry, 3.125 megahertz.
3.125. So why it is working at 3.125? Can't you run faster than that? I believe you can run faster than that.
There might be race conditions to avoid that.
Race. What is the race condition in that?
I'm not sure about.
Okay. So you want to talk a little bit about who did what? Who? All of you did something, right? Contributed, yeah. You want to talk about who did what?
I implemented the CPU codes and pick and place mechanisms, and he worked with the line following things on motor driver, all the things, and he implemented that Fusion 360. Using Fusion 360, he built the modeling for the chassis and overall board design.
Okay, so CPU, what did you implement?
We implemented the path planner algorithm in the CPU.
Okay, you wrote
We
C code.
used Dijkstra's algorithm and we implemented that in the hardware to find the shortest path.
You implemented in C, right?
Yeah.
And was that the only algorithm you chose? Or
We preferred Dijkstra's over all other algorithms because
And you
it was a bit easy to implement.
And you didn't modify the CPU that was given to you?
No.
You didn't change the Verilog, so you did nothing in Verilog?
No, like we basically built all those Verilog, using in Verilog itself we built the CPU also.
What did you do in Verilog?
Like the basic things was given by eYantra and we added additional more functions
What
and other
can
instructions.
you specifically tell us what you did?
The ALU controller, they were AND, OR, XOR and other instructions. We added those things additionally.
Okay, so path planning algorithm you said that you have written, and you have observed that in the first unit actually it just scans it and then again comes back and then picks it up, right?
Yes.
So why does that?
Initially we thought like it should complete the full unit and then it should start navigating using the same message.
Okay.
So to complete the overall unit we started and ended at the same point.
Okay, is the optimized way because you are traversing it twice, right?
Yeah, like we thought like it should complete the full unit and then come, but after coming here we got to know that once all the 3 SLM messages are received we can navigate. So that is why we had to run full unit.
Okay, fine. And most of the penalties are because of obstacles, right?
Yes.
So the obstacle detection is only at the node or you continuously detect the obstacles?
Actually, there was an issue because of the digital IR only. Because we had issues while calibrating it. Like the minimum distance was not enough, so that is why this main issue is because of digital IR.
No, through in the algorithm, you detect the obstacle only when the robot is on the node, or it continuously detects checks for the obstacle.
Only when it is moving forward.
Only so whenever it is on the line, it checks whether there is an obstacle or not. Okay. Thank you. Yeah.
Okay, thank you. Going ahead, the next team would be team ID 3408 from TSSM Bivarabai 7 College of Engineering and Research. So team ready? Scorers ready? Getting ready. Okay. Connecting to the Bluetooth. Yep. Connected. Move down. Update the area. Done. So ready? Okay. 3408. Three, two, one, start. MAL plus 2.
The IR sensor has detected the obstacle. Yes.
Obstacle cleared.
It will scan now prototyping unit.
SIL plus 1. SIL plus 2. SIL plus 3. RP invalid.
It is scanning. It is going through to the maintenance unit.
Okay. RD invalid, RDL invalid.
Now it will scan the waste management unit.
Resetted color sensing. So SIL plus 1, SIL plus 2, SIL plus 3, total 6 SILs.
Now it will pick the resource from storage unit.
SLM will also be 6. RP valid.
Now the inefficient supplies will be placed given the subunit there.
RD valid, RDL valid, end of run. Second run, reset. This is also you taken reset. This is kept right? New block. Restart the UI. Okay. So yeah, again in the meantime we can speak more about what is being done by the students. So the stage 1 started with the, we took all the students, so we should assume the worst case. So we started with basics digital electronics. They will do simple AND gate or gate implementation of the quarters, and then go one step further where they implemented simple designs called frequency scaling, PWM generator, and then even color detection on simulation. And then in task 1C we started introducing to the CPU architecture. So these are stage 1 and task 0 and task 1, and then we move to task 2 for UART and UART implementation of the simulation, and even path planner implementation on their design CPU in the simulation again. Then they got the hardware, and then everything goes. So that was glimpse on stage 1. Maybe perhaps next time I'll give you a glimpse on stage 2. Going ahead, scorer ready, timer ready. So 3, 2, 1, start. MIL 0.
Now it will recognize the obstacle. The obstacle is value.
Obstacle cleared.
Just in the forest. Now it will scan the prototyping unit.
SIL plus 1. SIL plus 2.
Now it will
SIL plus 3.
Now it will pick up the inefficient machinery.
RP plus 1.
And it will be placed in a maintenance unit. Now it will place it in maintenance unit.
RDL valid. Even RD is valid.
Now Now it will go to scan the waste management unit. Now
SIL
scanning
plus
is
1,
started.
SIL plus 2, SIL plus 3,
Now it will go to the storage unit to pick up the inefficient supplies. Insufficient supplies, sorry.
resource peak valid, resource deposit valid, end of the run.
Thank you.
Turn the bot and keep it back. So the next team to the stage is team 3153.
Good, nice work. So last time it worked very well, but why it is so slow? Sometimes it slows down. So why it slows down?
We had a problem with that prototyping unit that the color patches and the nodes are very close, and so the problem causes it detect the color. If it detect the color at the very less time, its next node is started. So when the next node started, the same color is detected for both of the nodes. To reduce that, we reduce the speed, so it gets us little more time in between the color detection and next node detection.
You are directly
Okay, so first time it failed, right? So what could have happened?
Gripper, I think the gripper, we overused it, and so it just its grip just loses, I think so.
That was because of gripper.
That's why I think.
So grip has gone, that's what you are okay. So when you have made many experiments, right? When something is failing, then how are you debugging that? What might have gone wrong? Whether processor has gone wrong, interface has gone wrong, or your mechanical assembly has gone wrong?
We try to see where the error is coming. Means retrying the same event, so we got the same error. So we could clearly understand this, if this error is coming due to some hardware failure.
But it may not exactly. You may not be able to recreate the same situation. Last time it was moving and then it was in some state, and next time when you are again moving, in that case it may not come in the same state.
If it is very rarely coming, then we will leave it.
Okay, so you designed a processor, right?
Yeah.
Which one?
There is a single cycle.
Single cycle. At what speed it is running?
3.125 megahertz.
3.1.
Sorry. 3.125 kilohertz.
3.1 kilohertz.
Yeah, kilohertz.
Are you sure? Should be megahertz.
No, kilohertz.
Kilohertz. No.
No, sorry. 3125 kilohertz, and it is equal to 3.125 megahertz. Sorry.
3.15.
3.125 megahertz.
What did you say before? 3.12?
3125 kilohertz.
Oh, 3125 kilohertz. Okay. Okay. So, how did you design that processor?
So they give us the CPU, which some instructions are already working, like the add. We just add to some logic to it. So other instructions such as add I or logically left shift.
So add I, what kind of logic did you add?
Sorry, I
okay.
So I missed. Where are you coming in from? Pune.
Pune, Maharashtra.
Okay. So what do you want to comment on who did what and what was the most challenging for you?
The most of the coding was done by our team leader, and designing the building the bot was done by our side. Most of the coding was done by the team leader. We also helped him, give him some logic, or used his logic and try to create the code. It gives error, but we tried it a lot to give the threshold voltages.
Check this one.
Until it will fix the problem. We tried it, but the major work was done by him, and the building of the bot was done ours. The gripper that where should be placed and why the acrylic sheet should be there, and
Okay, any challenges? So did you have to modify something, so he had to modify the code, or you did, he did, and everything worked fine?
no.
Okay.
We faced challenges.
The technical work is done by him, and and the designing work is done by us. The gripper gives us lots of problem in designing firstly, then afterwards we use the 3D printing design for it. We have designed it and we printed it. Firstly we build it from scratch, and later on we have printed it 3D model, and then it have worked properly. That's why.
First, while stage 2 the hardware was given to us, we used some scrap material to gripper, but it was also working, but due to some damage from our side it was damaged, so we built that the same measurement and the same gripper just in 3D, and made sure that it is light.
Have any of you had previous experience that helped towards this project, or was it all new to all of you?
This is the first time.
Hold on.
Yes, so just one question. So why wiring of your system is because it seems that your code and your design was very robust, really. I mean, it was, but why wiring is?
Wiring.
You could have, yeah, really, I mean, you can do it very well. Yeah. And what do you think the reason is that relatively it was very robust?
So we didn't have the experience of creating a bot, so we just watched the previous video of e-Yantra finals.
Okay.
And we found out something which had a thermocol head, and we thought it will also be okay.
Huh.
If there are more obstacles, we thought
And we also thought that
we are
if
going to get more obstacles,
Okay.
or more cubes, more resources to pick and place. So we thought it would be.
So you practiced.
So we thought it would be great. It will place and the.
So did you practice with a similar kind of design?
Yes, they are in our similar.
But with more obstacles
More
and
obstacles. We put ourselves more obstacles. So
Okay.
we should be ready for what we are going to get the task.
That's good. Okay.
So I have an observation here, like your gripper actually is picking up things and placing, okay. So do you think there is any flaw if we want to use it in real world?
We think this will be an advantage for this map, as there could be obstacle after picking the object. So how will we handle it if we had already had resources in hand, and how will we handle the obstacle?
So you have made a provision for multiple object pickup.
Multiple objects.
But then you don't have space on the platform to hold multiple objects.
No, one can be held in hand, or if the obstacle needs to be pick and just push side.
So right now the gripper command is issued by your program, or it comes from the central Eco server?
Gripper command is from our.
From the server.
No, from
is
our.
it from your program that you have detected? What is the case?
It should be from their program.
From their program.
Yes.
Okay. So you have made provision for that?
Yes.
we we have made a master instructor type of module, which instruct other smaller modules. Like this also gripper also comes in that module. So which master instructor instruct that gripper module to pick and place.
Okay. So suppose I am using this in real world.
Yeah.
Then do you think there is any problem with the gripper? Not about multiple objects. If there is a single object, do you think there is a problem? Recall the action, how your gripper is working.
Yeah, it will if the object is hard, the motor will require
not about the hardness of the object. The object is there, like whatever we have currently, but it is a real world object. So what can be a problem, possible problem? Okay. So actually you are turning the object upside down.
Yes.
May not be advisable in real world.
Yes.
So that is one thing which you have to somehow consider in improvement. Yeah. Okay.
Clearing all area around you, but then that may not be the best. Upside down, fragile things, that may not be the best possible.
Now, first it was a slower little like placing on it. Due to we have to use the shortest time and complete the full task in lower time, we increase the speed. The PWM changes very fast for that. Before it was slower.
For a novel kind of approach, most people use grippers like this. Yours is the only one I've seen so far, which is a rather unique kind of a way of doing it and keeping its surroundings clear. But that said, you have to look at the disadvantages. Think about it.
Yeah, maybe.
This is not the end of the
Yes.
life. Your life is just beginning.
Yes, thank you. Thank you, sir. Thank you.
Good work, team. The next team would be team ID 3153 from Vishwakarma Government Engineering College. So let's set it up. Bluetooth connection ongoing. So yeah, continuing on what happens on stage 2. Basically at task 3, we call it as the stage 2's first task. They are thrown out the hardware. At the very time, this might be the first time they are working with the hardware. Even for many people, it would be the first time working on FPGA. At task 3, they receive the hardware. They start to work with our samples, which are to test the hardware. And then they go ahead with the next task, which will actually test how to integrate things, which are learned in the task 1. So they start with color detection, individual modules like color detection, UART transmission, and they all need to put it together and complete that task and then go ahead with the next task. We'll continue again. So in the meantime, let's start with this first run. Scorer ready? Judges ready? So 3, 2, 1, start. Send the message. So HI, restart, okay. So they want a restart. Right. Penalty +1. Timer keeps running. As soon as the GUI comes up, you can start, right? Start. Yes, restarted. Valid obstacle clearance. HI end of run. They will go for a second run. Okay. that was an invalid run. Okay. Okay, restart, turn it off and now restart the GUI. Okay, so in the meantime we can discuss something more. On task 5, that is the first time they are going to basically implement their design CPU into the hardware. So of course they are allowed to increase the frequency. I think in the discussion forum we have also instructed that you increase the frequency from 3.1 to 5 till when your memory is failing, because that would be the major cap, or your ALU. They need to test it out, find out which is failing, and then they can either go for a pipeline, because they also simulated that also in the pipeline. They can either go for the pipeline or they can stop till there. So that is the option we gave. Some teams have utilized, like the first team who went for pipeline. Apart from it, task 6 is the entire run. Even it was harder run than that, and everyone in the finals have completed those runs to reach the finals. So yeah, however, we'll go for the second run for team ID 3153. Team ready? Scorers ready? 3, 2, 1, start. Restart, restart, or else you just click on restart. You connect with the BNE. Connecting to Bluetooth again. You already pressed restart. Oh, okay. Penalty +1. Yeah. Okay, ready? Update the arena. Timer ready? Sorry, timer is already running. Start the run. So MIL +1. Valid clearance. Valid. SIL +1. SIL +2. SIL +3. It missed a node. 1 HI. Okay. It would be considered as what do you want to do? End of the run. End of the run for the team. So done. You can go for your careful. Okay, cool. Next team is 1547. Please come to the stage.
Yeah. So now, what do you think that what has happened in both of the times it failed?
Calibration was not done quite nicely. At home or earlier in the practice, we calibrated according to that arena, and currently this arena was not exactly that calibrated, so the black lines are not that black, or
in the beginning when it started, right, it could not go to the obstacle, right?
Yes.
And you both of the time you needed to restart it.
Yes, sir.
So why? And in such kind of scenarios, how you say, debug, do you think that always it is the problem of sensors? Your design algorithm and all these are not a problem?
Yeah, I mean, so all the LFA sensors potentiometers has to be set at like according to the calibrations or whatever the color prints are in this arena. So that was not being done from our side. So this was the main issue.
So only the problem is with sensors, not the programs, not the your CPU design.
Yeah, you can say about problems, but I mean in program it was fast. I mean we thought that there would be more competition, so we made our board fast.
So because of fast, do you think that this has happened? It has skipped those things.
Yeah.
So to make it fast, what did you do?
So we made our PWMs of the motors bigger. I mean it was potentially.
So what is the RPM of your this one servo motor?
It was something around 2000 RPMs. I mean sorry. I mean we were providing 60% of PWM to the motors at this current.
We have done it like we have a base value of any, like let's say 50% duty cycle, and according to change we will add 25 or minus 25 from right or left according to the changes, and that change would be linearly affecting the opposite.
What kind of processor you have designed?
RISC-V single cycle, yes.
Single cycle. So what speed it is running?
3.125 megahertz.
3.125. But can you run this at higher speed?
Of course we can run, but we
so
have not
did you
tried.
check that at what speed it can run? When you have synthesized, right? How did you synthesize?
Yes, sir. We did it in many different frequencies, like 1 kilo.
How did you synthesize that?
All RISC-V CPU. Yes,
you have written very low code, right?
Yes, also.
So from very low, how did you synthesize?
So I also for checking the design is properly working. There was also test bench written, and also we were seeing all the variables in the signal tape for analyzer for risk.
But how you synthesize it? Because ultimately it has to generate the circuit, right?
Yes.
And that circuit you can have in your board, right?
So there was many different modules like ALU decoder.
So how did you synthesize? What did you do?
Basic structure was given to us by e-Yantra.
Could I look at the robot? Sure. Could you perhaps tell us something about the learning experiences that each of you had that was major for you? Each of you in turn. What was your major learning experience in this whole?
Also, it was my first ever projects on FPGA. It was nice with working with FPGA. I learned many things, and also related to hardwares. We didn't earlier designed any hardware like this robot or gripper like this. Many difficulties were arrived during this design of grippers too. Like earlier, all the full design was designed like through a material acrylic. All the design was fully made out with acrylic. But when we started doing the different runs and configurations, we came up with some issues like the gripper was not wide enough to catch any of the block. So we changed most of the little bit of acrylic parts with the copper wires strong so that it can widely open and also grab the obstacle or any resources easily.
So did you have to create each of these acrylic parts yourself?
Yes.
Or was that by cutting?
Yeah, through laser cutting.
Okay, right. Okay.
First learning was first time with FPGA Verilog. We learned Verilog in this project, and architecture implementation. So we implemented RISC-V CPU architecture. And another was hardware. We have not done any project related to robots.
Yeah.
We have done in embedded systems, but not in robots. So interacting with the real world, it's quite challenging.
How did you find understanding the Verilog and how to deal with that? Because it's a rather different sort of language than you might have come across before.
Actually it was quite difficult. We have first learned C, so from sequential to parallel.
Yeah.
That's a task for us. But e-Yantra has a very great learning resources.
Yeah.
So we
Excellent. And how about you?
Yes, we got to learn more about FPGA and Verilog programming.
So did you all do some of every part of this? Because you were all dealing with FPGA, were you?
Yes, I was coding in Verilog.
Okay.
Designing of RISC-V CPU in task 1.
Excellent. Okay. And how about you?
Sir, Verilog was very new to us. Like we had a subject named VLSI in our 5th semester. So we got basic overview of the Verilog language. Now we are finding the projects on Verilog to implement our coding skills. So we got to know about eYantra and we participated and got a vast experience for implementing the Verilog.
And how was it to collaborate with 4 people on one Verilog program?
We all are from same class, EC background, so it was easier to cooperate.
Okay. All right, thank you. Stand back.
I want to ask one question. So you said that the white line sensors was a problem, right? But if you see, actually the line following worked well, and whenever there was node, it was missing it, and that's why actually it started scrolling.
Sensors are not the problem. The problem is the ink of the arena. So we worked on the arena on which the K value was like 100. So the black color was fully black. So our code works, logic works on the threshold values. Like we got the values in the signal tab, logic analyzer, and we put the threshold like greater than some value and less than some value. So that's a black line and that's white.
So could it have been done differently? Like at the starting only you can do the calibration through code only, right? Instead of doing manually every time. Because the lighting conditions everywhere will be different. You should have tried it with different lighting conditions also.
There's a very big learning on this.
Yeah, you said the same thing, yes, exactly. This is one thing I noticed, we hear from groups, right? Everybody says that the color condition was different. Yeah. But this is if something you already know, so why you don't practice with different color conditions? Yeah, so right. Yeah, maybe for the next time. Yeah, thank you.
Okay.
Next team is 1547 from Jabalpur Engineering College.
Good evening, everyone.
Yeah, of course you can introduce yourselves. Introduce yourself.
Hello, ma'am. Hello, jury members. My name is Sanskar. We are from Jabalpur Engineering College. So this is this theme we liked very much because we wanted to work on FPGAs and HDL programming specifically. So that's why we chose this theme. And
mention your year as well. So
and myself Sarthak Jain. I'm a 4th year student at JEC. I'm from Electronics and Telecommunication branch. So really enjoyed this theme and a lot teased by the theme developers.
We'll continue that later. Okay. So going ahead.
I have a question, mate.
Yeah, sure.
I have a question. See, this year we did something very different. Previously, we used to allocate themes according to our judgment, and Rutuja here is the person who developed the algorithm to kind of allocate themes based on who we believe might be able to work the theme, based on experience and what year they're in and what background they have and so on. This year, we changed it. We allowed them to register for more than one theme, right? For 2 themes. And we allowed them to run with both themes, and then they had to choose which theme they want to run with. So the FPGA theme was a particularly challenging theme also a popular theme, because many people learn about FPGAs in their colleges, but not one has actually touched an FPGA in the college. So this is very unusual that in our higher education system, we are teaching these things and not giving them exposure to it on the actual device itself. So this is quite rare in itself. And the reason why we have a phalanx of jury members here is because we want to advertise what we are doing and try to scale up this theme, because I feel that what we are actually doing here is teaching people the rudimentary principles of working with hardware, VHDL, Verilog, tomorrow Python, right, and various other languages, to turn them into chip designers. And there's a huge need for chip designers as hardware gets more and more affordable as time goes on. So these are very core skills, and we are hoping to grow it. So in fact, we are happy to work with anybody who wants to popularize and help us democratize this theme, this kind of theme, and increase the number of people and the quality of the teaching. So we'd like to talk to all you guys who've taken part in this theme to critique us, to tell us what we can do better, and we'd like to work with our friends here, the jury members, to see how we can actually improve the experience. So I'm very curious to know why you chose this theme and what you got out of it. It can come out in the jury interaction afterwards. Thank you.
Okay, thank you, sir, for the comments. So going ahead, we will start the first round of team 1547. Scorer is ready. On the count, 3, 2, 1, start. MIL plus 2. Obstacle clear. First SAL, second
now it's
SAL.
going to the PU to
third
detect
SAL.
SLMs. So now bot
RP
is
valid.
picked the first.
RD valid, RDL valid.
Okay, now it will go to WU for
SAL plus 1, plus 2, plus 3. RP valid. RD valid. End of run. It is a perfect run. So second run. Yeah, restart.
no problem.
Good job, guys. Perfect run. They get a bonus of 180 points. Meanwhile, something I noticed in the 2 days while everyone is practicing was everyone was actually practicing for the hardest run that I was not expecting, and everyone had an option either to clear an obstacle or else to replan a path. I noticed two different strategies. One team actually cleared an obstacle, that is a simple one. One team placed the other box to the side of the forest and then cleared this obstacle and got back the other package and started the run. That run was the team, like that was done by the team which didn't do the run. So interesting things happened between some days. The same arena we printed, they said like the color is not right. They did the same run on the outside area and did the perfect run. Okay, going ahead, Bluetooth reconnected. Okay, going on. Okay, ready. So update the arena. Okay, score is ready. On the count, 3, 2, 1, start. MIL
So
MIL
first
received
PS
plus 2.
received, again a 5-second delay. That will go to PU for sustainability level check.
Obstacle
The
cleared.
obstacle is cleared now.
And then one more interesting point is there is no points for clearing obstacle as well.
But there is penalty for it.
Yeah. So 3 SALs. Valid pick. Valid deposit. Guys, commentary.
So yeah, now it's going to WU for sustainability level check. Sorry. So now it's went to the start point. Now it will scan the
SAL plus 1, plus 2, plus 3.
Now it will.
Valid pick.
So block pick was successful. Now it's going for WSU3 to place the block.
Valid RD and RDL. They receive bonus for the run, negative points for the no commentary. So that concludes all our runs. Thank you all for checking, visiting our team implementations and asking questions. So the last team is on the Viva. We can go ahead with the Viva.
Thank you.
Yeah, very nice. You have perfectly run the 2 runs.
Yes,
and in reasonable time.
Yes, sir.
So how did you decide this speed, right? That's very important,
our
right?
approach was based on accuracy. Like we did, this is a threshold. Like if we increase the speed, it can the run took 88 seconds. If we increase the speed, the threshold will be 80 seconds. But instead of going for the at the threshold, we thought let it go a little slow. We don't mind.
And actually to control the speed, we are actually varying the speed based on the curvature, because sometimes when the curvature is more, so it becomes difficult if the speed is high, so the accuracy decreases. So for the W, sometimes we decreases the speed. For picking the block, we decreases the speed so that there's no errors.
Especially for maintenance and supply unit, because the track is very slow, and if we keep the speed as usual of like we did the duty cycle of 85% for 4 kilohertz frequency, so we dipped it to 80% for small paths there, because there is junction there and that's very close. So if we have to take left, right turn, any turn, we were not getting the correct route. So for that only we decrease the speed for some routes.
So who has designed the processor? Okay, so what kind of processor you have designed?
Sir, RISC-V RV32i, single cycle RISC-V processor.
Single cycle,
yes,
at what, running at what speed?
Sir, it is on 3.125 megahertz frequency.
Can it run higher than that?
Sir, it can, but we did not try it because...
no, but you when you synthesize, it must be giving you the timing, na?
No, sir, it was giving. But,
so what was that frequency at which it can run?
No, sir, it was not giving the accurate, like the timing analysis was actually not giving the accurate, not giving the correct results. It was failing that in quarters. So we also don't know what's the timing closure. No, because in quarters, we were not giving anything as what do I say?
When it was failing, right? Then how it was running?
No,
it wasn't failing.
So
right, there was.
So it gives you, na? Then it gives you that if you run on this particular board, then what is the maximum speed you can go for?
So actually from the output of the CPU, we are storing it in a different memory. So once the CPU gives an output, we are made a secondary memory, so that whatever will be the output from the CPU, it will be saved in secondary memory. Then from
But
that
that's
secondary
not the
memory,
secondary.
so
Secondary memory we are
So
calling
actually,
to something else.
So actually,
Yeah, that's fine. So what kind of design you made? What changes you made on top of the code given to you?
Sir, we were given basic instructions. So after that, we were given jump instructions. So after that, we did JLR and other instructions. Top of that, we hardwired everything. Like initially, we were doing it together, but after some time, he got busy and I was free, so I had completed it. And there was some
So
bugs.
you
For
did
example,
JLR?
Yes, sir. Yes, sir. Yes, sir. JLR, SLR.
JALR?
Yes, sir.
So how do you do that?
Sir, for that I will actually need the PDF from where I did it. So, it was not I did it in a moment. It was like a 1 month old. We were reviewing the PDF and doing it.
So it was very easy, right?
No, sir,
It was
not
very
at all easy, ma'am.
Not easy? So what
Little
was
bit.
difficult? It looks
Difficult.
like everything is so easy, no?
One, because it's been 6 months, so we are taking it.
So what was difficult?
Difficult part was actually integrating every module to bring out this theme out of this board. There were problems because what we did is our strategy was we will make separate modules for everything what we have made. For example, we made discrete CPU. Then we made a controller on top of that CPU which will do clock gating, bring out the path from that CPU. And secondly, sensors, we made separate modules and we were debugging them individually. And once we are sure that it's done, then we know that if we integrate them, then the problem is in the integration part. So that's how we kept on doing that, and voila.
So you said that you have been controlling the speed based on the curvature, and that was actually the reason that you could get a kind of optimal speed.
Yes.
But what is your now values, in the sense that did you try it by kind of changing the rate of the change based on the curvature?
There were many times we thought maybe we could increase the voltage of the batteries, but it caused more errors. Like whenever there is a counter or any delay in order to take a turn or anything, in order to skip a node. So at that time, the higher voltage of the battery caused those errors to scale up. So we regularly check the voltage of the batteries and the speed of the motors to have a accurate turn. So that's why we didn't.
No, that is true. That is true. But when you say accurate turn, my question is that how exactly, like within your code, that is done?
Trial and error.
Ah,
Just by trial
that's
and
okay.
error, we optimize
Okay,
that,
okay.
like-
Manually, right?
Yes.
Ah, okay, okay, good. So it takes time, right? Did it take
But
time?
it's,
It will.
We tried
Full
to
time.
actually decrease the time, but most of the time it actually faced more errors. So we decided to focus on the accuracy instead of the speed.
But overall, the speed was good, actually. Yeah.
Your anchor there, Vicky, right?
Hari, Hari
Yeah,
Viknesh.
because your shirt
Yeah,
says
it is
Vicky,
written with Vicky. Yeah, Hari Viknesh.
So Vicky complimented you for, first of all, compliments to both of you for your very easy, relaxed demeanor.
No, sir, we
I
are
think
stressed so much that now.
No, but it's not showing. I think outwardly you're not showing that, and it's a great thing to have when you go face the real world outside, right? Let me constantly remind you that the real world outside doesn't have so much time to kind of give to people like you and me, because they want quick kind of movement forward. Having said that, I think compliments to you for that easy demeanor, and both of you have, and I think you've been very forthright in terms of what you have done, what you have not done. He gave you credit for having completed a job, and job completed well without errors, etc. I have two questions. What was that little meditative run before you actually started? I didn't see anybody else doing that little meditative run in the beginning before you started. A, that could have probably saved time, as ma'am is saying here. Two, what was that little waltz-like turn at the second hurdle here? Why that waltz? I mean, why couldn't you approach it directly and, I don't know, both occasions you did the little
Yes.
waltz spin.
Yes. So for the second question, actually we took another path, because initially we were sending it, we were typing the messages and we were sending to the mobile phone through the Bluetooth serial terminal app. So once the colors are detected, we have to send the message. But the accuracy of human error, there were many human errors, and we actually skipped a node and then sent into the message. So it was causing some errors. So we added an extra path so that if there was any delay with the same message, it could be easily handled with that extra path. As a buffer.
That's the second hurdle.
That's the second hurdle.
But what about the namaskar? First hurdle. What is that? For the beginning, you
yes, sir.
did that little meditative up and down, you know.
So either way, initially in the task 5, the task 5 was to first go to the W on the right hand side. So initially we have made an initial state to just turn right and reach the first node. Then the CPU, then we'll take the values from the CPU and do the discharge algorithm to reach the shortest path. So first it has to reach any particular node in order to implement the algorithm. So we chose that node. Just for if the first message was W, we never noticed the extra movement. But since the message was PU, so we noticed the U-turn initially.
Good, thank you. Good job.
Thanks.
Thank you guys. Like, you can exit for exit interview. So yeah, that ends all our themes. Thank you, judges. And two takeaways from all the vivas I got is, one is emphasize on viva as well, because basic questions and they were not able to answer, but the same question they have answered previously to us in the interviews. So I think they need to, if they have brushed up little on what they have done for the past 6 months, they could have answered all your questions. Second thing I noticed that I need to put more emphasis on is the slack time. So the questions you were asking about the frequency, if I could have put more emphasis on the worst case slack time, we could have had better answers from everyone. That's it from my end. I like to call Kavi sir to get us more critics.
You guys have done a great job, and it's been very entertaining also. Thank you very much. Big hand for the team developers. I don't know about you guys, but when I set an exam paper and I'm sitting with the students taking the exam, I feel not they, but I am on exam. Because if we've not set the paper right, we get lots of queries and all sorts of issues. And if they're not having a nice experience also, it should be difficult, but difficult enough, not too easy and all those kind of things. If you've not set it right, you feel bad and you feel on test. So I think you share the same experience, right?
Of course, like all the 2 days I was thinking at least I should show something in front of them. So whenever they were practicing, I wanted something to show to the audience. Same thing they will also be expecting. They want to show something to the audience. Hopefully it happened very well. I am grateful to those students as well.
He's also learnt a lot. And then we realize that when there's a good performance here, when the students are answering questions well, when they're kind of getting into it and they're passionate about what they've done and explain what they've done and done things that we don't anticipate, that makes it very exciting for us, right? When we have solved the problem in the lab, so when we set the theme up, we solve it ourselves. But what excites us a lot is when students come up with better things than we have thought about, right? They come up with totally unexpected insights, explanations, and you can see the delight in their faces when they've, overcome these obstacles and they've grown in the process. And that for us is a real reward. And that's what keeps us going year after year. And what our goal now is, although it's a competition and only about 5 teams come here to the finals, a lot of people take part. There are almost 2,000 students who've taken part, right? How can we maximize the number of people who reach the finishing line is our constant endeavor. And as I explained to our team here, that you guys are actually teachers. And you teach very large online classes. So this is a hardware MOOC, which is extremely unusual. You don't usually have hardware MOOCs. So we are pioneers at this game, and we've been doing it for the last 14 years. And when we go to EdTech conferences or robotics and in education and so on in Europe, like I'm going to one in Greece in a few weeks' time, we see papers with sample sets of about 15 or 20 students being trained.
So when we say that we are training 2,000 people in this theme, people don't know how to relate to us. But actually this is a problem we are trying to solve because India has a massive problem of scale, right? So what we've seen here is extremely exciting. And as is customary, I'd like your views on what you've experienced today. So I'd like to invite the jury members. We'll start with Mariam perhaps. Your reaction to today's.
Our experience with today?
Address them. Because she's a veteran, she's been here, she's been gracious enough to accept our invitation almost every time, every year. So you've seen these things evolve.
Oh yes, yes, of course. Yeah, actually, if I have to talk about the e-Yantra, I have not been always every year here. Sometimes I tell you, sorry, yes, I am busy and kind of.
Yeah.
And I think the last part that you mentioned about the hardware training, remote hardware training in a real way as a MOOC, is important. One more thing is right now, which is considered in the teaching, and you may have heard, my colleagues also have heard, is the practice, teaching or learning with practice. That is what director also yesterday we had a meeting was mentioning. So learning with practice, and I see that this is... You
face them also, the camera.
Oh, sorry. Sorry. Yeah. So learning with practice, I think that is what actually you have started, you say 14 years ago. And nothing is like learning with practice. I mean, and this practice, there are two ways of practice and both are required. One is mental practice, which is more thinking about what you learn and how you can use it. And one is actually practical learning, and that is eventually what is mainly here. But to implement now, going to what you said, for example, they were not familiar with FPGA at all, and then reach here, that means that they have eventually gone through to both process of learning in this way, and I think that is the very important part.
Good, thank you, very important observation. Ian. Oh, we'll save Ian for the end.
Oh.
Madhura.
So, good job. I didn't hear even one team complain that hardware design was hard. Right? Did we ever see anybody say hardware? What did you do? The CPU, FPGA design? Nobody complained. I didn't hear it.
They might not, because it was a 2-hour, more than 2-hour tutorial video, which I showed what would be the error and then fixed it from the simulation how you would do it. So that would be one of the things. Apart from it, for CPU design, that would be the thing. And before they start with the hardware, we used to have live sessions before they start. So that actually, this is because I would say I was in the stage. Okay, sorry. Yeah. Okay, sir. I would say that I was also a participant on eYRC 21. That's where I was also actually introduced to FPGA. At that time, there was no CPU, however. So previous year we started designing, and like we wanted to justify more why we want to use an FPGA. So I know what are the hurdles already they would be facing when they are going to do team run. So everything was in my mind. So with the help, what I would do is before they start, I would already say this would be the pointers you need to already check on. Let's say this thresholding, everything you need to look before you are going to do it. So lot of pointers I gave and had live sessions whenever I can beforehand, so that they will know or they will have a pointers in which direction they can head to. So that would be the main things.
So the important thing is he was a victim of the FPGA theme before he came on this side of the arena.
No, but yeah. So the whole point of proliferating or democratizing FPGAs is making it easy to program, right? I mean, if you make it easy to program, then there are more and more people that will use it. And this is such a nice way of introducing and showcasing that it's easy to do for undergrads, and not just program. They did so many other things also alongside programming. The FPGA was just one part, and they also built hardware and
design
all
thinking.
Yeah, I think kudos to all of them who put together the activity.
Thank you.
I'm more energy to making it tougher next time.
Yeah.
Thank you. Virendraji.
It is really wonderful to see such kind of designs here. now I'm really worried. I have to rethink about my course on processor design next year. How I would match this kind of requirements. So they have developed everything by themselves, right from the processor to implementing that on FPGA, checking each and everything, then designing the interfaces, writing the algorithm, and everything nicely they have done. And maybe some of the teams were not able to complete the run, but still they have designed everything. The design looks very nice. So I think this is, as Professor Mariam mentioned earlier, that this is a new way of thinking or teaching, like say learning by practicing. And perhaps I heard that this used to be practiced earlier in German universities, and our IIT Madras also used to do that kind of thing. So I think maybe we can say implement in our own courses as well, other than of course this can democratize the hardware design platform. Software things are available almost everywhere, and there are so many platforms, so people can learn, and this can really say scale very well. I mean, it is one of the learning that we have, and I think all of us should participate in such kind of initiative. Thank you.
Thank you. So we are the best kept secret in computer science department, and incidentally we teach an embedded system. I teach the embedded systems course along with Paritosh, and the latter half of the semester is a theme taken from the competition, right? So we make all the 120 students in the class, in the MTech students, participate in the competition as teams, and that's how we assess them as part of the embedded systems course. So it works pretty well. And not only that, we've got very good scores from the students. They've really enjoyed the course, they've learned a lot, and we've been teaching them advanced concepts like programming in Lustre and SCADE, and compiling that code into processors and all that. So safety critical languages and things like this. Model-based design using finite state automata, state charts, and these kind of languages, and so on. It's worked. So this way works also in the class very well. And if you want help, we'll be happy to kind of work with you to take your ideas, put them in this format. You can use them in class, and we'll use them in the competition. That's an offer. Yeah? So, Sachin. And then Rutuja after that.
Yes, so it's been really wonderful. I've been in this, sort of witnessed this about 2-3 times, and I really feel I can't see any other similar venture or enterprise or like e-Yantra in general, as well as such competitions which are very hard to organize, hard to kind of, conceptualize and sort of bring them to this stage. So simply my mind boggles at what Kavi has done, what e-Yantra has done, and I think it's really something that can tap the best of the talent and really scale things up in the way it should for a big country like this. What he was mentioning, I mean, most of the other places don't even have the problem of a scale of this kind that we need to face. I mean, we need to kind of confront. And this has been a very pioneering kind of enterprise that Kavi has started. And my worry is that, I mean, how is it going to be taken forward by IIT? Maybe he on his own, as in a commercial way, he can take it forward, but it's something that really requires a lot more initiative and a lot more continual support from IIT ministry, and there has to be some new champion to take this further.
We are working on that.
Right?
Let's work on it.
Yeah, let's work on this. Really, congratulations to you.
Thank you very much. Rutuja. So we've not met. Okay.
So I have witnessed this competition since last 11 years, and I was participate in 2014. So I can truly understand how, I'll say, how nervous the teams are, and that's why maybe they couldn't answer most of the questions. But I think the main focus when you come to the finals is whether your robot works or not, and then afterwards everything comes secondary. So along with the technical things, I think the most important skills are like taking up the challenges, then breaking down the problem statement, and then finding the craziest solutions which works. So I think e-Yantra teaches us that, and thank you. I would like to take this opportunity to thank you, Kaviarya sir, then Saraswati ma'am and Krishna ma'am are not here, but yeah, and the entire e-Yantra team to actually start this platform and touching thousands of students and then reshaping them in a very meaningful way. Thank you so
Hundreds
much.
of thousands.
Yeah, hundreds of thousands. I am one of them, so yeah, that's it.
Tell us about yourself.
Yeah, so as I said, I was participate in 2014. During that time, most of the themes were only based on the embedded systems. During that time, we used to have Firebird 5 robots. And now, after 11 years, I think lot of domains we have started with image processing, then ROS, drones, and all that.
Functional programming.
Functional programming. So after the competition, we were the second winners, and then I joined e-Yantra as a project staff, and I spent 10 years here and worked on different themes. So I was organizer. I was sitting in that place till last 10 years, and just now left the e-Yantra and joined GE Healthcare Company last November only. And while working here, I also got admitted to the PhD program in IIT Bombay itself in 2018, and I'll be completing it soon, hoping that. So yeah, thank you.
Thank you very much. So last but not least, Ian Page. He's been engaging with us from before COVID in the school competitions that we do with the school children, right? In the virtual museum competition, in the robotics competition. The same methodology that we use here with the adults, we've tried it with school children in COVID because they wanted something and they found it to be a stress buster. We were throwing the same problems with them inside a simulator, and they were loving it. And they felt that after they took part in this, maths and geometry made sense. Right? And we were very thrilled about that they're actually discovering all these things and doing it with such passion and gusto and not being stressed about it at all. And that was a real eye-opener. So now we feel that we need to take this kind of education down to schools. Nitin Gupta said this morning, what this competition is about is not teaching skills, it's about rewiring the brain, right, in some way, making people problem solvers, which is quite important. But anyway, Ian, he's got some very interesting insights and he's been a believer. So look forward to
my first visit to an e-Yantra competition.
To India.
To actually come here. And of course I'm blown away by what's actually gone on. The learning experience that these students have been through and what they've gained from it is absolutely obvious. But in longevity, maybe I can claim something else, because maybe the idea of doing something in an FPGA might have come from Kavi's experience with what I was doing in Oxford in the 90s. So there's a very long perspective and a very short perspective I've got here. But overall, I'm just amazed at the success that e-Yantra's had. And it must be that it's the right idea because it's scaled so well.
Yes.
And Kavi keeps claiming that he doesn't have to do very much, that the team does it for itself. I don't believe it for a second, but it has scaled enormously well. I've tried to tell people about e-Yantra back in the UK, and that they've done 200,000, 250,000 engineers through the program, and you can see eyes glazing over because they can't understand it. Because we've got nothing like it. In fact, over my experience as an academic, STEM subject, practical subjects have been pushed out further and further away from the core curriculum, partly because they're hard to teach, you can't get the teachers. Supporting them with hardware is more costly, lab time costs money, and as universities are more and more geared towards being economic entities, commercial entities, the practical subjects are the first ones to go. So that in the UK, they've been pushed not out of, just out of university courses, but out of secondary school courses as well. And strangely enough, it's only the primary schools in the UK that still do very much practical stuff. Mostly it's cutting things out of cardboard with scissors, but it is practical stuff. And it's because the teachers have the freedom to invent projects, and they do. I've been involved myself with several of them. In fact, with my local school, we build electronic Christmas cards, and they absolutely love it. But you can't even imagine doing something like that in most school curriculums because there isn't space for it. And in universities, well, same sort of problems. So how to graft something like e-Yantra into a different national educational system is something that's been giving me some thought, and I wish I had some good answers. But celebrate the fact that it works here. It's been marvellous, and I've been very pleased and proud that
Thank you.
an ex-student has managed to do what I could never have done myself.
Thank you very much, Ian. Thank you very much. Big hand for all our jury members here. And I think this has been a very wonderful day for all of us, and it's I believe a successful day for all of us, and this is the height of, at least for the e-Yantra competition team, for having brought us to this point where we've had a very satisfying day. Thank you very much. And it's my privilege to give our jury members a little token from our side. As is traditional, we don't believe in useless things like certificates and trophies and stuff like that, which you don't have space for anyway. So we give them food. Such a... Yes, and I think this gentleman will take a picture of you in the middle, sir. Thank you. Very practical stuff. Tell us what you think about it. Mariam? Do let us know what you think about it.
Sure.
Thank you. See, I do what I'm told to do.
Thank you.
बताइए कैसा लगा? Something for your handwriting. Thank you. Madhura used to work for us many years ago. We are hoping to get her back in some way. Oh, you're a jury member. Ma'am. Thank you. That's it. So, thank you all very much. I think we'll close the session now. Is there some tea, or do we just... Pardon? Yeah, you need to give these to Shama. So should we close? Thank you very much all, and thanks for your immense labor and passion which has brought us to this point and made us very proud of you. And what we've achieved with you, we hope to achieve with very many more students. We are actually looking to scale up eYantra 100 times. We are looking to take eYantra global, so you should be competing with students from all across the world. We are hoping to get interns from other countries to this campus, right? So when you make your networks, you'll be able to make them with students from other countries. So that's the fond hope that we have, and that's what we shall work towards. So thank you very much. Good night, God bless, and Jai Hind. Big hand for all of you.